some add-ons that we have to do for the structural aspects of this new observation deck. We have the concrete blocks to put in place for the beams that will be put under the new structure, as well as wood decking for that new area and bracings on the outer beams so that we have a good structurally sound structure. And then railings will be extended throughout the new area. And then going with the two-story CNE lab, we have decided to do 2 Connex boxes that will be identical, and one will be set underground, which will be excavated to set in place, and then the other Connex box will be set on top of that, that will be underground. So the top level will be served as a workshop area where you can have tools and the air compressor and just kind of a space to where you can work and store tools. And then the underground level will be served as a storage space where you can put materials, more tools, anything that you really need to put. So what we're going to do is have a cutout area on the ground to have access to this lower level basement that will not mess with the structural integrity of the Connex boxes, because the outer points on the Connex box is where all of the loads are being held. And so as well, so we are going to add a sloped metal roof on the top with a gutter system for rain.
So getting into our prefabrication strategy, we looked at 3 main goals, which is a reduction in time, price, and waste. So by going after our CNE lab and using a stacked Connex box, we see that we get 2 fully functioning lab spaces delivered at one time. This is going to save both time, price, and waste. The next option we explored was a prefabricated staircase. We could build this off-site, and then after post-cutting and framing, we'd be able to install this full staircase from Connex 1 to Connex 2. The third object we explored was crushed concrete aggregate. So this would be off-site and would count as a recycled content. This would be used to set the Connex box so everything was level, and yeah. Now, picture yourself as a CNE student. This is the view that you can imagine walking into the lab floor of our top level of our CNE lab. So as you can see, we plan to have custom lab shelving and tables kind of on the sides, as well as LED hanging shop lights on the roof. And then on the right, you can see we have a power strip hub, outlet kit, and then GFSI fittings for any electric tools. And then also with that, we have an air manifold for any air tools. So keeping everything kind of organized on the sides. This is what you can imagine your lab looking like. And then going off of that, this is the safety and distribution we looked for with our lab. So the main important thing was wire management and work distribution. So where is everything going to be organized? Having the manifold, as well as the power strip hub, we could designate tools to one area of the workplace. So having your tools in one area for your air tools, electric tools, and knowing where that's going to be at all times. Also keeping everything mounted for safety and accessibility. This allows for storage with the shelves, and also elevated work tables, so nothing's on the floor, we don't have to worry about tripping or anything. Next important thing was electrical safety. We are working in metal Connex boxes. So using GFSI for the outlets, this is going to help protect any outages. We also plan to have a extension cord that's outdoor rated that could run out of the Connex box. The third option we explored was energy saving, so using LED lights. It's going to reduce the amount of power that we need to run those when we do require lighting in the Connex box. And then the power source. So primarily we plan to tie into the current CNE facility. However, we do have a backup plan, which we'll discuss later in the presentation. We plan to add portable solar generators. These will provide plenty of power for the DIY lab that we plan on having, and designating 2 circuits, one for lighting and one for all the tools.
Let's get into the schedule of the project. The critical path for this project essentially runs through the CNE lab. It's just the structure that has the most activities and some of the materials with the longest lead times. But we wanted to showcase some of the other important activities and events that were not just in the CNE lab. So we made this milestone schedule that has some of the bigger events like pouring concrete. And then the duration of our project, we are accounting for 12 work sessions, and we are accounting for a few weather days. And then the way we started our schedule was with this work breakdown structure, breaking each structure down into different phases, and then different activities from there. So observation deck was broken down into foundation, structural, and then stairs and railing, and then from there into specific activities. And then from there, with those activities, we put it into this team activity breakdown. So we figured we would have 7 crews, and we put 2 crews on each structure, and then that 7th crew was going back and forth between the roadway and the 2-story lab, depending on what was more critical at the time. And then as you can see, we do have some white space at the end there. So ahead of schedule, hopefully, and if any weather delays or material delays, they'll be accounted for in there. And then if you would like to see the full Microsoft project schedule, it's in the appendix of our final proposal.
Now I just briefly want to touch on our VDC workflow that we used for this project in creating our proposal. We used 4 main softwares, starting with Propeller. This was provided by the owner. This is a 2D drone scanning mapping software, so we were able to see the site on a 2D map and find the elevations of everything. So we were able to use that information and put it into Revit, which created our 3D model. This is where we spent majority of our time designing and creating our proposal. And then with that Revit file, we imported that into Lumion and Synchro. Lumion created our 3D realistic photos, and Synchro created our 4D model. And so what this video will show is our 4D model, which is taking a 3D model and putting it against our schedule. So I was able to take our Microsoft project and our Revit and combine it into this video. And so as it goes, you see the weeks going on up top. The green elements are what's being added that week. I think this is just a great visual tool to see the sequencing of events and what would be going on the project during that week.
All right, so most importantly, I think you guys all heard Brandon mention that most people are going to come in here and be over budget. We wanted to tell you today that we were actually under budget. As you can see, we're asking $9,981.03 out of the set $10,000 budget. So looking back at September when we originally presented, these are the numbers that we gave you. As you can see, this is the main breakdown of all the items that we have kind of priced out for this design. At the bottom, you can see we're asking for $10,000. On the right is our current budget, and you can see the breakdown for each kind of main subject that we have in our design. And on the bottom is our total, as well as a 5% waste that we are carrying. That is for any concrete that is in our design and any wood in our decks. So you're probably asking, how did we get from our original budget in September to where we are today? One of the main reasons is our 2-story concept. Originally, back in September, we planned to do a stick-built design where we're going to pour a slab, form up the walls, and build some kind of 2-story structure. We quickly realized that was way out of the budget. Instead, we got creative as a team, and we decided to explore the shipping containers that were already on the site. So we looked at Chicago, and as we know, as a country, we import way more than we export. So we're going to get shipping containers for a lot cheaper. So we got a huge discount on 2 shipping containers, as you can see, for $3,600. So this would allow us to have double design for our stacked kind of Connex box. Any shipping ships that go out, they come stacked very easily. So our plan was to develop a 2-story lab design using 2 Connex boxes, connecting them with a staircase. So yeah, on the bottom you can see we are doing a tilt bed delivery. That's going to allow us to not have to worry about offloading equipment. So it's not going to worry about our schedule. They could get delivered whenever they come. And once they are there, we're going to have our offloading equipment and we'll get them set in place. And based on our current design, we actually get 320 square foot, which is 120 over the asked for square footage. That gives us $11.35 as our dollar square foot. And then outside of that price, separate from the lab, is kind of our add-ons. So looking at the stairs from Connex 1 to 2, we have about $375. We also want to waterproof the basement Connex since it will be in the ground. It's not necessary because it is wind and water tight, but we want to get that extra security. So that's about $1 a square foot, so it's $160. Then the sloped roof system, which is also not necessary, but that's per the owner's specs. That's $375, mainly going to be for appearance since they are kind of wind and water tight, as I mentioned. And then lastly is the soil backfill. That's going to be used from our excavation. So the next main change that we have from September, originally we planned on using I-beams for our structural precast sections. Now we actually are planning on doing an internal steel bracing for the basement shipping container. So that's going to include welding these 8-foot angle irons that you can see on the bottom. And then on the drawing on the left, the blue is going to be the vertical structural steel, and then the red's going to go around about halfway up, and that's going to count for our horizontal structural steel. So this meets the requirement. It would be 72 linear feet of steel, and we saved a lot of money using this method of structural steel compared to the I-beams that we originally planned on. And then third was our cast-in-place concrete. So obviously, back in September, as I mentioned, we were pouring a slab. We have a lot less cubic yardage that we need now. So we were looking at pricing an entire truck. Now we needed to explore other options of getting small amounts of concrete. So we only need 3.7 cubic yards now of cast-in-place is what we estimated. So we looked at a volumetric mixing truck, which comes with short loads of concrete. They mix it, and then it's ready mixed, ready to roll. So we found a local company in Lafayette, Short Load Concrete LLC. As you can see on their Facebook page, that's their address, number, email, and their logo. And then some reviews I put up there, easy to work with, great option for small projects. We think kind of giving back to the local Lafayette community will be awesome, and we think they'd really love the chance to work with Purdue and kind of get their name out there as well. And then getting into equipment, this is what we see needing for all the steps of our design. So mainly we're going to need an excavator and operator. So the first thing they're going to do is excavate for that 20 by 8 by 8.5 shipping container that's going in the ground. We plan on sloping the soil and then obviously backfilling, setting the 10-foot precast pieces, and then setting the containers post-tilt bed delivery. Included with that, we have rigging and shackles, so nylons and shackles that will be used to set the above items. We also plan on having a welding machine, 170 amp, to weld that internal steel bracing that we showed in the prior slide. We're going to need a plate compactor. That's going to be to tamp any crushed concrete, so for setting shipping containers, setting our curbs, and then a grinder, which will be used to cut the corrugated or the steel container walls. So cutting for that staircase, cutting for potential windows or anything that might be added on to the design. So going into value adds that we were exploring. Keeping the green roof, natural irrigation. As I mentioned, the sloped roof is already just an aesthetic add-on, so why not make it something cool out there on a S-Bright, add some greenery, add some more aesthetic to it. Next would be a window unit. As I mentioned, we already have the grinder that we are renting, so it would be pretty easy to just also add a window. We'd only have to price the framing and the window itself. Earlier I mentioned kind of a second power source. So this is an option we explored. Enough power for home DIYers. So having a portable solar generator, it comes with the generator, it comes with the solar panel. You throw it out there, it charges 80% in 2.5 hours. And this is enough to power any tools that you plan on using for the lab space. And then lastly would be custom lab supplies. So kind of like adding an upgrade to all the lab supplies we currently have, maybe getting some metal ones or something a little bit more sturdy, just some nicer lab supplies for $368.
So now moving into our management and execution plan. The first for learning opportunities for other teams, just so we are keeping our job site as safe as possible. Our team also wants to implement a Team of the Week incentive. The Team of the Week is just going to be picked at the end of the week based on maybe they had good teamwork or they had a really good safety catch or they just showed general good initiative in what they were doing or they had a good suggestion for how to build something better. And then we'll reward that team with a small thing, probably just like being the first in line to get lunch at the next work session. So moving into the work packages, there's 3 work packages on this project. The first is the horizontal work package. That includes all of the construction of the roadway on the project. So the building of the roadway will include site layout and grading and precast concrete and cast-in-place concrete work. The teams working on the roadway will get to learn the importance of layout and grading in road work, as well as finishing work for cast-in-place concrete. The vertical work package will include both the observation deck and the laboratory space. The teams working on the observation deck will get to learn about framing and carpentry work, and those working on the laboratory space we'll get to learn about excavations, large material picks and placement, as well as a small amount of ironwork in the grinding of the space for the stairwell and any windows or doors that might get installed too. And the support package team, they will be in charge of placing in the compressed air system and the electrical system in the lab space, as well as the prefabrication of the staircase and any of the lab tables and such that will be put into the lab. So they'll learn about small things in carpentry as well from the staircase and lab tables, and they'll also learn some MEP elements from the placement of the compressed air in the electrical system, and a little bit of interior finishing as well if any doors or windows are getting placed inside a lab space. So moving to site logistics, we have here a general site logistics plan that we've developed to try and create a smooth flowing and safe workspace. On the north side, we've designated a vehicle parking area. Each team is going to be limited to just 2 cars per team because there's not very much parking space. So they'll have to carpool to the site. All vehicles will only move along these drive lanes designated for getting in and out of the site during work sessions. No vehicles will be moving anywhere else on site just to keep things safe as people are moving around site. Down here we have a material laydown area that's going to be used for storage of large materials such as the Connex boxes, the precast concrete panels, lumber, and also stockpiling of borrow from the excavation and any recycled concrete that gets delivered to site. Right next to that we have an equipment drive-through area where the equipment will move through when moving the precast panels or the Connex boxes or any other material. When equipment is not being used on site, that will be a work area, extra space for the team working on the lab area to work in and move their work out into. Beneath that we have a prefab staging area that will be used for the staging and preparation of the staircase as well as the lab tables. That way they can be set and prepared to be moved into lab space when the time comes. Then moving over to the west side of our site, we have 2 designated work areas as well. The bottom one is for the observation deck and the northern one is for the roadway. This is again just extra space for teams as they work in those areas that they can move some of their work out into, and those areas will be very clearly delineated beforehand. That way other people who are moving through the site won't be walking through these work areas, they'll be going around them because we don't want people trying to walk through an area as another team's trying to get work done. We want to keep things flowing smoothly and safely at all times. Now, communication is absolutely key for any construction project to run efficiently and safely. So our team will have weekly owner meetings with the owner to go over the current progress of the schedule, the budget, and any possible design changes that may have come up. And then we'll move also into a look ahead on the coming logistics for each of the activities that's going to be done in the coming work sessions. That way the owner is at all times on the same page as everyone else on site. They know what's going on. We'll also have weekly class coordination meetings. That will be done during the Capstone lecture, which happens on Tuesdays. The first half of that class will be done, again, just to catch up on what activities have been completed up to this point, where we are on the schedule, if we're ahead or behind. Then moving into the second half of the class, we'll go into the coming activities for what's going to be happening in the coming work sessions. That way every team is in the loop on everything that's happening on site. Since we do have 3 different work areas, it's very hard for a team to know everything that's happening on site. If they know in the back of their mind at least what the other teams are doing, it's good to be able to keep track of what's happening on site. As I said before, we're going to continue to use Procore. We'll use the progress tracking feature, which will allow teams each week to submit photos of the work that they've completed into the feature. That way we can see what's been completed, and we'll continue to submit any RFIs or change orders to the owner as well through Procore. And this will just keep communication online through a single source at all times. We have identified 3 risk areas that could potentially cause delay in the project. The first is delivery delays. The Connex boxes, the precast concrete panels, and the 3D printed concrete, if we choose to use that, will have long lead times. So to mitigate those risks of delay, first we're going to have ordering those materials at the very beginning of the semester should hopefully give us ample time for the materials to arrive before we need them. If that won't work, we also have identified alternate suppliers for the Connex boxes and the precast concrete. If we need to, we can move to those alternate suppliers, and if we are still not able to get those materials in time, we'll be able to resequence some of the tasks in our schedule in order to get us keep work moving through the project while we wait for those materials to arrive. Now for weather delays, as you saw earlier with the schedule with Chris, there are some built-in work sessions for rain delays. We have one extra work session for the lab space and more than one for the observation deck and the roadway. If we're still behind due to a lot of weather delays next semester, we have identified April 4th and 11th as 2 Saturdays in which teams could volunteer to come in, do some extra work, and get us caught back up on schedule if we need to. And finally, to mitigate any design errors, all of the work that was designed by our team was peer reviewed by at least 2 engineers on our team. For all the major design, it was peer reviewed by most of, if not all of the team. We wanted to just mitigate any errors beforehand because we don't want to be trying to redesign any of the project while we're building it. Now finally, moving into some technology that we're hoping to use on this project, we have 2 new technologies we want to use. The first is the Trimble XR10 with HoloLens. The XR10 allows the users to see an augmented reality where they're seeing the real world, and overlaid on that is a VDC Revit model. We want to use the XR10 for layout in the roadway. This will allow for very accurate layout and also much faster layout than using the normal methods of surveying equipment and total stations. Allow us to get the roadway laid out and get going on that really fast. The next we want to use is 3D printed concrete. We'll use that to create the form walls for the 180-degree turns we have on the east loop of the roadway. Those 3D printed walls will get made off-site, shipped to site, and we'll be able to place them directly where they need to be, and then we'll be able to cast and place our concrete directly against those form walls, rather than trying to form up those really tight radii we have on those turns using wood or plastic forms.
So building off of what Peter said previously, safety is extremely important to us at Hammerhead Construction. So we have put together a lot of safety training and management implementations. So obviously PPE is required on site at all times, no matter what is going on. And so we have put together a orientation for weekly and daily for these safety implementations. So we actually have trade-specific training so that you are going into your task knowing exactly what you're supposed to do. Whether it comes to building the observation deck or the lab, we have a safety kind of checklist and like things you should do and understand before going into those things. And so having management, so we will have faculty on site which will be observing us during our work, making sure that we are obtaining those safety goals, as well as we are promoting a good safety culture, making sure that we are holding ourselves accountable. If you see somebody doing something that is unsafe, to make sure that you are telling those people that it's unsafe and kind of reporting those issues.
I briefly want to talk about a small maintenance plan that we're looking to implement with our project as well. This would just be twice a year, just do a quick inspection of the existing site. This would require no cost. It would just be with existing staff and students. We want to take care of the existing facilities on site because they've been there for multiple years, and we want to extend the longevity of Esprite. And so this would simply entail building inspections, looking at the roofs, looking at the gutters, looking at enclosures of the buildings. We could also inspect the drainage of the roadway, look at site conditions. We want to pursue this maintenance plan in the upcoming weeks with our peers, and we are open to feedback at enhancing this maintenance plan so we can take care of the existing site. And so for our final takeaway, we wanted to share just one lesson learned that we had. It could be more as an advice, but shout out to Sally and Cassidy. They were our mentors for this project. We got great, valuable insight. They helped us prepare for this presentation, and they also just helped us give logistics and just improve our design as we created it. And so I would just emphasize that find mentors and utilize and pick their brains in the industry so we can all continuously learn and get better. And with that, we believe this proposal provides lots of value to Esprite and the construction engineering department. We feel that our senior class are going to learn so much this spring. We have new construction methods, new technology that we're looking to implement, and we also think that this design will benefit the future classes at Esprite where they can build off of our design. And so with that, thank you guys very much for your time.
So back to your budget, did you say that you had firm quotes like on the Connex boxes and things of that nature?
Yeah, we do have firm.
Everything you have for the most part is? you
Yes,
have
for the most
firm
part.
quotes?
Firm quotes, yes. Some things are general assumptions based on, prices, but yes, most of it is firm quotes.
But the larger items?
All the
in your
larger
budget?
items are firm quotes, yes.
How does the interaction between the lower level and the upper level of the Connex boxes work? It wasn't clear to me that you were showing the stairs and what space remains for workbenches and so on.
Yes, so basically our plan is once we set that basement Connex box after excavating, we would kind of measure out, cut out a space for the staircase. And then once that was cut out, fill back in, you're gonna place that top Connex box, and whatever that measurement is, a square foot off of the corner, you're gonna cut into that bottom one. So that's the staircase measurement, and then from there is the rest of the lab space. So that is also pretty flexible. But yeah, that's our plan.
Okay, thank you.
And one quick question, the floor elevation of your second level appears to be below existing grade. So how do you access that space?
For the lab space?
Yes.
You think, or
That
what
would
you're
be the
saying?
staircase. So the top Connex box would be at ground level, so that would be the doors, for like a shipping container. And then through the top, you could access the bottom through the staircase that we've designed.
No, I mean, the second floor appears to be below existing grade, I think.
That's not the intent. I apologize if that's what it looks like on the VDC. We would hope that it's a couple inches built up above grade so that we can make sure our doors swing open. And yeah, the Connex box is 8.5 feet tall, and the roof system would be an extra foot. That is still under our 565-foot elevation cap as well.
Thank you.
Yep.
So you're going to have a buried Connex box. Did you look in?
We kind of did not look in the soil types for that. It's good. Something we should explore.
I'm assuming you're gonna connect the two Connex boxes and then the stairs. Are these bolted connections? Are you welding all this stuff? You
So
didn't
we-
really talk about that.
Yes, so cutting, and then we plan on adding like a frame, rim. We do have the welder there. If we wanted to weld steel, we do have extra steel to weld kind of like a frame around it for the staircase. But we were planning on doing like a wood staircase down with pressure treated stringers. If we are gonna prefab it, which was one of the options we discussed, we could do metal stairs if we feel the need to do that as well. But that is our plan for the staircase down.
Okay.
Did you account for your operator and your welder costs in your budget?
Yes, we did.
Okay.
Still on the Connex, your construction sequence, when is that excavation being done in the overall sequence of work?
So I think our plan with that is once we have the Connex boxes delivered, I think that is the first step first. Whenever that gets there, we plan on also having the precast there to kind of enable to be able to do the excavation, to be able to set the precast, and be also be able to set the Connex boxes. So excavating, sloping, being able to set that first precast box, and then kind of going from there.
What about in relation to the other work?
So the other work is kind of asynchronous, in my opinion, to that. So while the Connex box is there, you could be doing the structural steel for that basement one. You also could be working on that west connection because it is pretty separate, and same with the observation deck.
Okay, so my concern was with that deep of a excavation, your layback, and I thought in the 3D fly through the track was already done, and you'd have to excavate because that sequence probably, you have to get your excavation and backfill done before you can start on the track adjacent to it. And then you also run into the, if you're excavating right away, frost and dealing with digging through that in the winter.
Yep. I think that's a valid point. We'll definitely start on the west side while we excavate and try and get our Conex box and backfill first before we can move forward with that track over there. And then I think that's a valid point too, thinking about the frost of the ground. It can be pretty rigorous to excavate when it's frozen like that. Hopefully we have good weather. Maybe we could explore options of maybe trying to excavate before, while we have warmer weather, if that's possible with the owner. But that's definitely something worth noting.
How are you guys going to handle the sloped slab? Because the slab from last year is sloped, and so how are you going to adjust leveling of your observation deck and your concrete footer blocks?
That's going to be a tricky process in which we need to think more on. Hopefully we have some type of survey technique to, I guess, build up our existing footers and maybe use some type of string method to make sure that it's level at grade before we place our panels.
What are you thinking of using to set the Conex boxes in holes?
Yeah, so we were planning on using the excavator to set the Conex boxes. So we priced in a medium-sized excavator, plan on lifting it. That's our ideal method of lifting and setting. However, if that's not really an option, we do have the nylon straps where we plan on kind of tugging and turning it into there. So we are sloping the sides, but we could also ramp the one side to be able to enable us to be able to kind of get that set down there if lifting is not an option. So we have two methods.
What are you considering mid-size?
I think we priced in a 12-ton excavator.
So let's pursue that a little bit. Where is the equipment going to be moving around relative to placement of the Conex boxes? And have you looked at that on the site? Where your where you would put the how do you approach the site to put in the Conex box? Because you've got, I think there's uneven ground there next to where the Conex box goes, right? Do you know what the soil capacity is going to be, and how much room do you have before you run into some kind of impediment, either slope that you're not planning on, or fences, or what?
I mean, I believe that site B runs for about, how many, like 40 feet, 50 feet?
Can somebody point on the screen where,
Do you want to go
where
back?
the
Yeah.
setting equipment's going to go?
Can you go back to the site logistics plan? So this area here is all just grass right now, and
Yeah.
we have permission from the owner to use this entire area, and it's all level ground right now. So we'll be storing the Conex boxes in this front area of our material laydown.
All right.
So we would excavate, slope back this way, and then we'd be able to pick up our Conex boxes and directly move it into the hole.
All right, okay, great, thank you.
Mhm.
So for your guys' safety plan, did you kind of sit down and think through what your high-risk items are going to be and kind of plans to mitigate any safety risks, especially with putting in that Conex box and the excavation associated?
I think we'll have to keep note when we excavate, having some sort of railing if we're not there on site to make sure that it's secured and no one can fall in. I think we'll have to take extra measures with our deck as it's elevated for 9 feet. We're putting up steel or wood beams, and when you put on the decking, there's not going to be any railings yet, so we'll have to take that into account too. And then we'll have to really emphasize when we're using our excavator and trying to set these Conex boxes that people are not in that area, because that is very dangerous, and so we will keep track of those high-risk activities.
There were some in the appendix H listed for each activity, kind of what mind for those high-risk items whenever you're working on the excavation or building the structures as well.
You first.
You talked about 2 Saturday work days that students could, or workers could volunteer for. Do you have a plan to incentivize that or reward that?
Currently don't have any plan to incentivize that, but we could certainly come up with something. Maybe even just having food there and a free lunch for the workers if they come in.
Thank you.
Not to keep digging on this Connex, but my question, have you looked at the underground utilities in that area? Do you have a plan for that? If there is, like, are there any active electric lines, plumbing, anything underground that you have to be concerned about?
I believe Brandon said the only active electric is far off, like
North.
it was like north, all the way up by the parking area. So we shouldn't have to worry about any electric. And I do not believe there's any other current utilities underneath that area.
You reported on the spring construction material and equipment costs. Did you also report on the other 2 categories?
Say that again?
So there's 3 categories of fees to report on. So fall 2025 design, and then spring 2026 design, management, and construction labor.
Yes. So that was included in our kind of our waste fee. We're including that as a 5% fee generally, and carrying that overhead.
So all of the costs for the fall design and then the labor is in that 5%?
Well, yeah, the labor is through the students, so I believe that would be essentially free. Same with our project management team. We're offering that as a Hammerhead construction. And then the 5% overhead for the concrete and for the wood, is, as you can see in that budget. Yes.
What's the under surface drainage plan around the Connex boxes? How do you ensure that you don't get any water infiltration or premature corrosion of the boxes?
Yeah, so as I mentioned, we are waterproofing that basement one.
Yeah.
So I think that will be essential for preventing kind of that corrosion and getting the water inside that basement one as it does drip, come down from the PVC piping irrigation from the top Connex box. That is our water plan, I guess, with that.
But no sump of any kind?
No,
Okay.
not priced in currently, but if the owner does think that we need that, we can certainly add that.
Did you guys account for a slope on your east side roadway? Because I know you have the PVC piping going through for the drainage, but how are you going to mitigate standing water that might occur on other parts of the track?
Hopefully there's some small gaps here and there that it doesn't build up too much, but maybe we can try and slope it slightly so where maybe it feeds more into our drainage system that's currently there.
Understood there was a perceived budget constraint, so this is more of a comment than a full question, but we've heard about items like delineating work areas, needing more potential implementation for safety. Did y'all consider contingencies in your number at all? Didn't see that in the budget, just for items you might not be thinking of day one?
So the main contingency that we held was that 5%, which was for our main items, so the concrete and for any lumber that we have, due to shipping errors, if a precast panel comes cracked or whatever may happen. We wanted to carry overhead for that generally. We think a lot of the other stuff, generally if we need some railings, could be put up kind of prematurely. I think that would be kind of more or less minute, but yeah.
Just from a design aspect on your roadway, why'd you guys jag the horizontal part on the western side? And why not just include that square feet on your eastern roadway? Because you're blocking access to the observation stair towers.
That is a great question. If we were to make this roadway 30 feet straight, we would go over the 5% slope because there's this section of the roadway is 2 feet higher than this, and to go straight there, we would be over the 5% slope. So that's why we made it 50 linear feet to get a slope of 4%. It's not showed in this picture, but we're gonna include steps that would you'd be able to cross here and steps to cross here. There's already steps on the existing roadway, and so that would help with the ingress and egress of the site and the observation deck.
Another important part of that too is they're 10-foot pieces, so doing 10-foot segments, we wouldn't have to worry about cutting or anything like that.
And are you guys interacting with the existing masonry structure on site at all?
No, I don't think so.
If your intent is to waterproof the basement connex box, have you considered the buoyancy of that?
Have not considered the buoyancy. I looked on roll-on waterproofing, and that's kind of what I priced it at.
Yeah, I guess my point is if you have a watertight vessel and you have a large rain that then becomes a boat,
I see what
it's
you're
gonna
saying.
start to float
Float
through
up.
the hole and push up. So you might want to consider some anchoring system into the ground to prevent that from happening.
For when you're building your roadway, I know when we did it, we had to have concrete under our road so that we could anchor into something. Your design looks like it's just going into gravel and grass. Do you have any plan on anchoring or how you're going to secure your roadway to your ground?
The roadway would be, I guess when we put our 2-foot masonry walls, we kind of try and embed that with the dirt and try and put some pressure along the sides. And then, yeah, I guess that's our main way of anchoring it. And then when we use mortar or anything to secure the walls, when we put our cast in place, that concrete will combine the system and hopefully it just weighs enough to stay there.
Your time is up. Thank you for your presentation today. You have about 5 minutes before you have to clear out. If anybody's got any one-on-one or comments to share, by all
Thank you.
Tim, were we good?
Yeah, all good.
Was it hard to hear?
No, it was good.
Okay.
We're putting more quality, more mics. If you want to move that one to the left a bit more in the corner, that'd work. Sure. Overall, good. This is gonna be your job next year, so.
Yeah, that's why I stopped.
This over here for you.
Hey, Brett. Oh,
All right, we got a couple minutes before we get going. Anybody have any questions for me? Jack, are you?
Feel great.
Feel great. It's good to be in the pole position, right?
Yes, it is.
Where's the crowd?
Coffee? Great question. Great question. Let me see what I can do about it. All right.
Hello everyone, we are OnTrack Engineering, and to get us started, we'll go ahead and present ourselves. We'll start with our project manager, Alex Paul, our site superintendent, Joe Violanda, myself, I'm Gonzalo Hernandez, I was in charge of EDC and safety, and we'll move on to Greg Gerardo, our horizontal lead, and Owen Berkey, our vertical lead. Now for what we're going to discuss today, here is our agenda. We're going to go ahead and start with our RFP explanation. This will be done by Owen Berkey. And if you guys have any questions, please save those for the end, and we'll answer those appropriately. So now, we'll move on with Owen Berkey.
Thank you, guys. Before I go any farther, I would just like to say a thank you to everyone in this room. Thank you for being an industry that supports the education of students. I'm speaking for all of us. We're the beneficiaries of that, and we're incredibly grateful. All of us have had the opportunity to have 3 amazing internships over our time here at Purdue. And something that I hear quite often from my classmates is I feel like there's a disconnect between what I learn in the classroom and what I do every day at my internships. I wish I had more hands-on experience before I stepped into the industry. Honestly, that's something that I can relate to. This semester, I've been learning all about formwork in my CEM 455 temporary structures class. I've learned how to design it, how to size it correctly, how to brace it, and all of that is on paper knowledge. I can slam through the calculations, but if you asked me to go out into the field and assemble it, I would have no idea what I was doing. 2 weeks ago, Bowen Engineering came in and gave a demonstration in our temporary structures class where we actually got to go out to Esprite and put together some forms. It started to click for me, and I feel much more confident in my theoretical knowledge now that I've gotten to bridge it with practical. At its base, that is what Capstone is all about. It's about bridging the gap between what we learn in the classroom and what we're doing in the field. Now to hop into that a little bit more, we've broken down the RFP into 4 scopes: horizontal, vertical, maintenance, and electrical. I'd like to draw your attention to the figure. First, the horizontal component asks that we connect point A to point B using more than 200 linear feet of roadway, requiring more than 360 degrees of directional change and a slope of no more than 5% at any point. It also asks that we create a structure at C. Existing right next to C is an observation deck. We've chosen to extend the observation deck and also tie it into the horizontal structure. If you're unfamiliar, the observation deck at Aspright is used by the quality and safety teams for inspections because they're able to have visibility of the entire site. We'd like to expand their visibility, giving them a larger field of view. It's also used by people driving RC cars. You can pilot your car from up on the observation deck, and so we'd like to tie the observation deck into the horizontal roadway, and we'll do so through an elevator. The elevator will pick the car up and actually transport it up to the deck so that someone doesn't have to go down and get it in the need of if they need to do repairs or swap out a battery. Moving on to the vertical component, as you can see, there's a small building at B. The RFP dictated that the maximum height for any structure on site is 565 feet. The ground level at point B is 555 feet. Now, it asks for a 2-story structure. If you do a little bit of math, you realize you can't fit a roof and 2 stories in 10 feet. So it forced us to do excavation and go into the ground. Moving on to the maintenance scope, Aspright has been used for 3 years of Capstone so far, and hopefully many more in the future. In the same way that you take care of your yard at home, we would like to take care of this facility so that we can continue to promote hands-on educational experiences for construction engineering students. We'll be maintaining some minor upkeep of the site, and we're also planning on keeping it really, really clean so that next year's group doesn't have to redo our work. Finally, the mechanical and electrical scope. We'd like to provide the lab space at B with lighting and power, as well as power to an air compressor. I'm going to be handing it over to Greg to talk more about the horizontal component.
Thank you so much, Owen. So I'm going to break down the horizontal component. So this is the actual roadway and for the RC track that will be located at Aspright here. It's going to connect into the existing structure over on the west side and come in and do a turn and then loop under itself, ending almost at the lab structure at C. Now, in previous years, teams have used a one material system, but this year we have actually elected to use 3 different types of roadways for our track. The first is wooden ramps. We are using these for our elevation changes. We are doing this for a few different reasons. The first is a prefabrication aspect. Being able to prefabricate these ramps farther away from the site, farther away from those horizontal components, allows them to have better quality control and then not be working directly on top of the bolt-to-block and other cast-in-place areas on the actual roadway. Then these ramps can be moved in and set on grade so that we can actually be precise and get that 5% slope and not over that for the RC car. Next are 2 steel bridges, one located at that north end going over the track and one located at this south end. Both of these are being donated by the Purdue ASCE Steel Bridge team and are currently weighted for over 800 pounds each. These are going to provide an excellent aesthetic feature as well as providing an example for future teams to look at and see how steel fabrication is done. Lastly, we have both cast-in-place and precast panels. The cast-in-place sections come off of the wooden ramp at the west end, as well as over on this east end throughout the turn. The precast panels were chosen because of their overlap with the site. And so, once again, we do not want any teams to be working directly on top of each other. These will be able to be fabricated over out by that red box and then be moved in with the telehandler for the end and final straightaway of our horizontal component. As I previously mentioned, we have a lot of parallel work that is going to be happening at once. This is going to require a lot of coordination between teams and a lot of coordination with us as the general contractors, working with these teams to make sure that each one of these components can be completed on time and not before or after it needs to be done. So that all of these things will be happening safely, have correct quality, and can end with an excellent final product. So here are pictures of the donated steel bridges from Purdue ASCE. This is from our 2025 bridge that was rated for 2,400 pounds, and this is from the 2024 bridge, which is rated for up to 800 pounds. Plenty enough for the wooden decking that is going to go on top of this, as well as many RC cars as the teams would like to run across them. As a quick budget check, and we'll have this after each one of our sections, there are a variety of donated items that are bringing our costs down. You see that originally this would cost approximately $6,700. But after our donated items from our steel bridges, our bolt block, and our concrete from IMI, it brings it down to approximately $1,700. Now, right here, our bolt block, we're using this at 2 different sections of our site, and this has been graciously donated by the bolt block manufacturer, and they are willing to come in and help train us and train all of our students to make sure that we are able to fully utilize bolt block to the maximum of its potential. We are also expecting to receive concrete from IMI. This is huge, as it means that we can work more precisely on controlling what our mix is and controlling our quality during our actual construction process. You can see that brings our costs down quite significantly, and if we check in with our total budget, we can see that the horizontal component is, our horizontal component is there, and it comes out to approximately 13% of our total overall cost once you take out those discounted items. We are also choosing to extend the observation deck. There's an existing observation deck that is used by both during construction and during everyday use for the drivers to keep track of their vehicles, and during construction it's used for one team to be up there to manage safety across the site and manage quality control to make sure that all teams are actually being able to complete their expected areas of work. We are extending this to provide a wider area for more drivers, for more people to stand up there for safety, and for more simple spectators throughout the lifetime of this project. We are also choosing to create an elevator that will attach into the road directly below. You can see that that is tied in to the existing structure here, and we are going to extend it using the same pressure treated decking that is currently already existing on this site. This elevator will be able to be used for both lifting the car up to perform temporary inspections without having to leave, and also to be able to take the car up to not only do any inspections on it, but minor repairs for it, or if a car simply needs to be gotten off the track while any other cars are on there, that can be done as well. Now, this is a small component of our schedule, taking up only approximately 1 month, so if anything were to really need changed or shifted around, we would be able to take crews off of this and send them elsewhere, which we will cover later in our schedule component. Once again, another quick budget check-in. All of our costs for this observation deck is coming directly from our lumber and our hoist for the elevator system, and it comes out to another approximately $1,700 cost and another approximate 13% of our total cost there. Now, there are a few different value engineering options for our horizontal component of the track. The first is utilizing a wooden road instead of a poured concrete road. Last year, the team elected to choose a wooden road, and this helped a lot with a lot of different quality control options, as well as schedule improvement. Now, obviously, I don't need to sit here and explain that. This is going to be a project done by students for future students. As students, we do not have a whole lot of experience working with concrete, working with actually pouring it, and doing all of the form work that is required for that. So, taking the time to do a wooden road instead is much easier to fabricate. It's much easier to control the quality, it's easier to check dimensions, and if anything goes wrong in a wooden road, it is much easier to go back and improve it later. That ties into our quality control piece. It is much easier to end with a final product that we are happy with versus a poured concrete road where there are errors that we might not see until later on, and it may be too late to fix those. It's also hugely more sustainable. As we all know, wood is a much more sustainable resource. There's no point in this Capstone project to be dumping carbon into the atmosphere when we can be taking some of that carbon out and capturing it with a wooden road instead. Once again, I've already touched on it, but a maintenance flexibility component. This project will exist here for years to come, and we expect our students to be able to continue maintaining that site. A wooden road, you can, if one of the planks starts to rot, you can take it out, replace it, no harm, no foul, versus a poured in place road. It'll be much more difficult jackhammering it out, reforming it, repouring it, and we do not want to cause future students any harm. Next, another value engineering option is 3D printing a bank turn. As you can see with 3D printing concrete, you can get much more organic curves like this. If we were to do this on the west end of our turn, it would provide a very unique experience for both the driver versus while the rest of the horizontal component is a very flat and sometimes 5% angled slope. This would provide a more organic turn that would allow drivers to practice going through a different environment. It would also to provide large aesthetic improvements as future teams would be able to see what 3D printing concrete can look like and what it can do and what exactly the difference is between a 3D printed concrete and a normal cast-in-place system. I'm going to pass this off to Owen Berkey to explain our vertical component.
Thanks, Greg. As previously established, the vertical component is intended to be a lab space, and so we've designed it as such to support hands-on learning. The main floor will be exactly that, a lab space. Students can do small-scale demonstrations, can learn about formwork in any weather, or it can be a prefabrication shop for years to come. To support this, we have a roll-up door. It's easier to get material and equipment in and out through a larger space. We also have a man door. The basement will also support this goal, functioning as a storage facility so you can keep demonstrations that aren't being used or tools down there, and our air compressor will also be stored downstairs. Now, as we were brainstorming, like, what do we want this space to do? Something that, and once we reached our conclusion, something that we kept asking ourselves is, okay, how do we as students actually build this? We don't have experience with masonry. None of us are masons. None of us are union carpenters. So we need to pick materials that we can actually work with. That leads me to our building components, the first of which is bolt-to-block. If you're unfamiliar, it's a masonry unit held together with a skeletal steel structure. It derives a lot of its strength from that, as well as its cohesiveness. It also gives us a faster schedule, higher productivity, and as I said, greater strength. So what we're going to do is we're going to pour a 6-inch concrete slab at the base of our excavation. To that, we'll anchor bolt-to-block. That will go up 11 feet, 1 foot above grade. We'll coat it with an elastometric coating to waterproof our basement so we don't see water intrusions, and our storage is safe from water damage. Prior to the termination of the bolt-to-block, we'll anchor in our 12-inch wood floor joists using hangers to the masonry units, and then use plywood to complete our floor. Transitioning to above grade construction, you'll see 18-gauge metal studs spaced at 16 inches on center. Plywood sheathing will be hung from the outside of that, and then vinyl siding will be hung from the plywood sheathing. That will give us an aesthetic that is professional and will stand the test of time. Finally, topping out, we'll use pre-engineered roof trusses and a sheet metal roof. After we answered those questions, it brought us to, okay, yes, we know what we want to build it out of, we know what we want it to do, but from a means and method standpoint, how will this actually be built? What are some of the constraints and challenges? The first constraint and challenge that we ran into is, how are we going to do our excavation? We've been operating under the assumption, as confirmed with the owner, that the soil is type B. If you're unfamiliar with that, OSHA dictates that there are 2 excavation opportunities for type B soil. One is to cut back at a 1-to-1 slope, and the other is to install, shoring using piling and lagging. Because we're not extremely constrained in the footprint of our site, we have chosen to opt for the 1-to-1 cutback. Reasons for this include 1, reduced cost, 2, faster schedule. So, we'll dig our hole. At the base of our hole, we'll pour our concrete slab. Once that slab is poured, it brings us to our next question. It's important when installing bolt-to-block and building a basement to maintain access to both the interior and exterior of the basement. Traditionally, to do this, you might just slap a ladder up on the outside wall and slap a ladder up on the inside wall, tie them together, and call it a day. We've chosen to approach it in a unique way for a couple of reasons. We're going to build 3 walls. This is going to be our first complete wall system. Once those walls are in, we'll install the floor joists to provide lateral stability. As I said, there's a couple reasons that we're doing this. One, there's only really one person who can go in and out at a time if you have ladders. If you have multiple ladders, maybe two. But we might have 6 or 7 people working inside of the basement structure at the same time, and we want easy access for everyone. In case of a safety issue, we want everyone to be able to evacuate quickly. Additionally, it's hard to carry material up and down a ladder, so providing an open access point while we're constructing these 3 walls is incredibly helpful. Now, once those 3 walls are in and we've installed our floor joists to provide lateral stability, we'll also brace the back and side walls from the interior, and then it might be kind of hard to see because of the lighting, but we're going to backfill about halfway. The reason for that backfill is afterwards we'd like to install our permanent staircase. I don't know if you can see it in the back, but someone will be able to walk up on the backfilled dirt and down the permanent staircase to gain access to the interior of the basement. Once access has been granted, we'll begin building our 4th wall. Now that 4th wall is an entirely separate system, but once it is built, we'll use brackets in the corners to anchor masonry unit to masonry unit. Once that 4th wall is constructed, we'll finish our backfilling operation and then proceed in our construction once we're above ground. To check in with our budget, the vertical component of construction is by far the most expensive part of our project. As Greg mentioned earlier, we're expecting to see some significant donations, and so it'll slash our $17,000 cost down to just over $9,500. This is also, when you look at our total project cost, all the donations take our cost from $25,000 down to just over $13,000. When you look at this component of construction in terms of the whole project, it represents about 74% of our project budget. I'd like to pass it off to Joe Bulanda to talk about site maintenance.
Moving into site maintenance, obviously the SPRITE facility is very nice and we're lucky to be able to use it, and we want to be able to maintain it and keep it as nice as we can for as long as we can. One of the things we're going to do is after every day of work, we're going to do a very good job cleaning up and tidying up the job site. This will help to point out any issues that may have come up during the day or any dings that we may have in any structure that's already there, and then we can rectify those either immediately or the next working day. We also have a couple items that we plan to address as soon as we get on site. On this bolt block structure that they built last year, the roof trusses are not enclosed, so we're just going to close those up, probably with plywood. And then one of the gutters on one of the Connex boxes has been damaged, probably due to some weather, so we're going to put that back up and make it all nice. And then rolling into our power distribution plan, we have a 1200 watt-hour solar battery cell. Using that, it'll run through a breaker, which gives power to everything else in the it gives power to everything else on site, and we're going to add electrical wiring to bring it to our new structure at point B. After running the calculations, it'll run our air compressor for at least 2.75 hours. This is most likely more than we would ever need to use it for on site, because considering our shifts are probably about 3 hours. It also runs it runs saws and drills and charges up our batteries and runs our lights. And if for any reason we may need more power, we do have a generator on standby just in case. Now I'll roll it over to Greg to talk about the schedule.
Schedule is always important because it tells us how exactly we're going to get the project done, and it tells us when things are going to happen. One of the most important aspects of our schedule is that we are starting this fall. In approximately 2 weeks, we will actually be on site doing layout, getting ready for excavation. We've done this for a few main reasons. The first is we want to minimize excavation in winter conditions. I don't need to sit here and explain to you guys how difficult it is to dig during the winter. So if we can minimize that, which with this schedule, this puts excavation being completed on December 11th. This puts us far ahead and also allows us to get a head start on group planning activities. All of our teams will be able to go on site, see where their work areas will be, see what the work areas will be, see what they're going to be doing, and start getting ready for next semester before next semester even starts. On site, there are generally 3 major activities happening at one time in preferably different areas. These areas are at the structure at C, with the excavation and then eventually coming out of the ground. At the horizontal component, installing the bolt block and then the cast in place concrete, and then a fabrication area located near the material storage. The critical path follows the vertical component of construction almost exclusively, which is one of the larger risks of this schedule, but there are multiple things that we are doing to minimize that. If we take a look at our milestones here, we start out with finishing excavation in December 11th. This is critical because this puts, once again, that excavation being done before those wintry conditions set in. And if you notice here, this is December 11th. Our school year goes until approximately December 19th. So hypothetically, there's a little bit more time if something were to happen in excavation were to go slower than expected. Then, next key component is all of our pours being complete on January 29th. This is absolutely critical because pouring concrete in winter is extremely challenging. This is why we have budgeted for admixtures, for heaters, and for multiple tarps that we'll be able to use to keep our concrete perfect while it is in that curing phase. Once our pours are complete, we can finally split off into all 3 of our sections here, with our finishing our road component on February 19th, our observation deck on March 26th, and finally fully enclosing our structure to get everyone inside on April 23rd. All of this comes to a final project turnover date of April 30th. Here you can see just the general breakdown of our 3 components here, seeing that we start with our vertical component and going all the way till the end of the project. And once again, this is the critical path, which means that if any delay in our vertical component will delay the entire project. Luckily, that is why we have split our horizontal and observation deck to be in 2 entirely separate times, so that whatever team is supposed to be working on the observation deck will be able to go and assist in the vertical construction activities and the prefabrication activities to increase their productivities and shorten those durations as much as possible to minimize the risks. Here you can see a 4D time lapse. You can play that. There we go. Here you can see a 4D time lapse. This is us finishing excavation in the winter there. This is winter break passing by. Then once school starts up, you can see all of our construction activities happening all at once here, filling in that backfill, finishing up that road, finally assembling the rest of the structure here. And you can see with this schedule that a lot of the activities are crucial for following that vertical component. You can see that almost everything on site was done while we were still finishing up those walls and putting on those roof trusses. I'm going to hand it off now to Gonzalo to talk about safety.
Thanks, Greg. Now we're going to go ahead and talk about safety on our site plan. Now, I believe before we get started about talking about safety, I think it's important for each one of us to ask ourselves, why should we be safe? Now, me personally, I want to introduce you to some important people in my life. See right here, this is my high school graduation photo, and alongside me you'll see my mom, my 2 brothers, and my 2 sisters. Now, I'm a big believer in saying that we shouldn't be safe just to hit a metric, or just to hit a company goal. Rather, quite the opposite. It should be for reasons like this, so we could come back to our families and enjoy spending time with them like these. And as you guys know, most people that are going to be working on this project are seniors, so pretty soon this will be them, but instead we'll be in our Purdue, with our Purdue degrees and our Purdue gowns. So at OnTrack Engineering, we built a strong safety culture around the people and not the paperwork. And thanks to this, more people will take it more seriously when it comes to tasks like, even if it's carrying a ladder, handling equipment, or what may seem like a mundane task, they'll take it with more seriousness as if they were on a real job site. Now, to talk about our safety plan, we implemented a 4-step process. The first step is preparation. Now, before anyone steps foot on site, we'll have everyone complete their OSHA 30 safety training, and then they will also have review tool handling, have hazard recognition, and we'll also even bring in some manufacturers to help explain how to handle some material. such as the Bolts Plot Company, teaching us how to use their material. And the second step in this is communication. Now, what I love about communication is that we keep everything very consistent and super simple. We'll start each day with our simple stretches at the beginning of every field day, and then afterwards we'll start with our track start plan, and this will basically outline what our plan is for the whole day. We'll then move on to our PTP, our pre-task plan. This will kind of separate it out more into each crew and explain the hazards that they will encounter and possible controls that will need to be implemented. And a big part of communication is the fact that anyone, and I mean anyone, can stop work at any time. Doesn't matter whether you're the lead on it, doesn't matter if you're the one following the leader. You can always stop work at any time if you see that something unsafe is happening. And all those documents that we mentioned before, they're also going to be available on our SafeTrack system so that anyone can have access to these documents at any point if they need to review how we're handling our safety at any point. The third step is safe operation. Now, this means that whether we're handling tools, we're making sure that we're doing it in the proper way, we're staging materials correctly, controlling access to the site, or having spotters for deliveries, making sure that everything is in place. So whether we're on site 1 day or even 2 days, we're treating it as if we were on a real job site. The fourth step is securing the site. This means having clear access points, having one outside, inside, depending on the situation, barricading active work zones, making sure that people who shouldn't be in there shouldn't go in there, and then also closing out and locking the equipment at the end of each workday. Now let's move on to some of the daily rhythms that we'll be talking about, which we mentioned a little bit in the communication portion, but we'll go into more detail now. First, we'll always start with our track start daily briefing, and as we mentioned before, this is basically just a sum of what the plan is for the whole day. And this will go to everyone, and that's going to be working on the site. Afterwards, we'll move on to our PTP, as we said, our pre-task plan. Now, once everyone is separated into their crews, now every task will be more separated and delegated into steps. And then we'll also talk about each control and each way we can mitigate risk in any way, whether it's wearing PPE, perhaps maybe even eliminating the risk in total. Those will all be brought up at the daily pre-task plan. Afterwards, we'll discuss the daily safety checklist, and no work, and I mean no work at all, can be completed if something is not checked on that list. This will make sure site conditions are good, weather is okay, the tools we are using are in good condition, or anything else that comes up to mind. We'll make sure that everything is up to plan on that. Now, having this safety plan kind of just shows us that we take safety as a big priority in our job. And having an organized and clean way just goes to show, like how I said at the beginning, that we want everyone who's working to go back to their families being happy and in one piece. Now we'll go ahead and move on to our management and logistics plan, and this will be taken by our project manager, Alex Paul.
Thanks, Gonzalo. Starting with the management plan, I want to first talk about communication. Our number one goal as a team is to have clear, honest communication, not only with all of us working on site, but also with the owner. And we collaborated as a group, and we came up with a collaborative decision framework for communication. This is an example of that during construction, of a schedule recovery option during construction. With this, it allows the team to demonstrate our thoughts moving forward, and allows for the owner to also give input for any ideas that they may have moving forward. This will be partnered with weekly coordination meetings, daily field walks, quality milestones, and any safety or regular trainings in process. Now, moving on to the procurement and site logistics, I'll first talk about our site layout. Here we have our lab structure and our horizontal component. Something I will note about the site layout is that this is dynamic and will be changing over time. Because of this, we feel as a team that it's really important before everyone gets onto the construction site to be able to understand where construction is taking place on that day. So because of that, we will be updating this regularly on Tuesdays as a briefing before we head out for construction on Thursdays. Partnering this, we have our equipment and our material layout areas. And we will also be using the facility that last year's CEM group built as an equipment area. We also have our traffic areas and our parking areas delineated from any construction zones, and as well as we have an outdoor and indoor muster point in case of any emergencies that are taking place. Moving into our procurement, it starts with our vendor selection. Joe will talk about this more in our work breakdown session about how our leadership is constructed, but leadership will give a heads up of 2 weeks of any material or equipment that needs to be brought into site. After this is a solicitation process. I, the project manager, will ensure that the equipment or material that is asked for is what is needed per spec and is actually what we need to complete construction moving forward. After this will be an evaluation and approval. This is going through and submitting this through Procore as a purchase order, and after this will be a tracking and delivery to ensure that all material or equipment will arrive on site in a timely manner. Now moving forward, I'll pass it to Joe to talk about work breakdown.
Yeah, going into our work breakdown, the way we're going to split up the whole class into teams is in the next few weeks we'll send out a survey, and this will talk about, it'll ask the students what they have experience either seeing or doing or what they want to do on this project. It'll also give them the opportunity to express interest in being either a team lead or a foreman type of role in order to be sorted into these teams. We chose to break these teams into these specific groups because if we broke it into trades, there's not always something going on for each trade every day. So we're going to keep it to areas of the site and which structure they're going to be working on. This also helps our team oversee each component, like the roadway, which was mainly worked on by Greg. He's going to be in charge of that, and the lab structure will be run by Owen. And then safety and BDC coordination will be done by Gonzalo. We also have our carpentry team. They'll be working on our forms and also doing our stairway and our observation deck expansion. And then we have a float team, which will primarily do our MEP installation, which really happens later in the project. And then they'll be able to give a helping hand to whatever team needs the most manpower at the time. Our safety and quality team will be stationed on the observation deck throughout the project. This team will be comprised of students one from each team, chosen, a different person will be chosen each day, and they'll be responsible to stand up there and observe, make sure that all work is being done safely and to a quality standard that we come to expect.
Now, moving forward with the training process with this, as engineering students, a lot of us might not be familiar with using certain equipment or potentially construction going on at the construction site. With this, we feel it's very important for us to be able to learn how to use tools effectively and for everyone to gain a general understanding. We feel that we've created these training sessions in a way to create more of a learning experience and more of a discussion dynamic for all of us as students. And this begins with an initial orientation. What this is just everyone sitting down in one room, talking about what the semester will look like, some of the hazards that will be taking place, our schedule, as well as any potential hazards in our first few starting weeks moving forward. After this, training will be more broken up into different teams and will be task specific. This means that each team will be learning how to use their equipment properly and effectively to ensure that people aren't getting hurt, and also in the end of the day, this will help us with our schedule, but also create a more high quality product in the end of the day. Moving on into pre-task plans, this is what Gonzalo mentioned earlier, but this is small groups of people sitting down, talking about what they're doing for the day, talking about potential hazards, how to mitigate these hazards, and talking about their work moving forward. Complementing this, we have our daily safety training. This is a big group discussion at the end of every construction day, talking about what happened during the day. This could be talking about things that went well, things that we could potentially see going wrong in the future, or anything that could be brought up into discussion. And with these 4 components of training, we feel that we can create a great layout for students to be able to learn how to use tools effectively and create a high quality product. Now, speaking of high quality product, I'm going to talk about quality control. Quality control will first begin with daily inspections by our site superintendent, Joe Violanda. We will also be doing material verification for any material or equipment that gets to site. This is just essentially a quality process to ensure that any of the material or equipment that came in is actually what we ordered, to not potentially screw our budget moving forward. We will also be doing dimensional checks on any critical dimensions throughout the construction process. Anything like slopes of the roadway, our final lab vertical elevation, or anything like that will be taken a photo of with a description, submitted into Procore in a quality module, and will be flagged on right if it is incorrect and will be needed to be refixed before moving on with construction. And we also have a concrete material testing module of this too. As students, we learn a lot about concrete and part of the testing that goes with it. And I feel that as students, some of us may not have actually ever done concrete testing in the real world, as this is something that would be really nice for everyone to actually use and learn how to use it effectively on the construction site. And lastly, we'll have proper storage. We understand as a team that in past years, proper storage may have been something that people haven't been taking as critically as they should have. And with this, we'll have a storage plan for every equipment or material that's coming onto site to ensure that nothing will be damaged by any weather or any moving parts or any of these critical components. In partnering quality with Trimble, I'll take it to Gonzalo to talk about this.
Thank you, Alex. So for those of you who don't know what Trimble is, we'll go ahead and actually demonstrate it here with our friend, our model, Greg Gerardo. So this is the XR10 headset here. And for those of you who don't know, this is basically a virtual reality world where you can basically see your model. And to show you an example of our model, actually, we have a video for you. Here, this is someone wearing the headset, and you can see our structure. This is when I was wearing it, so you're at 5'7". And that's our lab structure we plan on building, as well as our track. Here, now you can see the extension to the observatory deck, as well as the existing building that's already there, as well as the existing track as well. And I believe, we implemented this XR10 model to help us with field verifications, verifying as-builts, so without even having to go to the site itself. So if there's ever a day where we have a question, and maybe the site conditions aren't available, or maybe we just don't have someone to go there with us, we can just pop on the headset and then measure it straight from the tool itself, because everything's up to scale, and it makes everything so much easier rather than having to travel over. And I think this model just goes to show us how much our kind of group cares about this project as a whole, and how much we push forward to reach the end goal of having a good, successful project. But this concludes our presentation. We'll now go ahead and open the floors to any questions that you guys may have. And we'll also ask, if before you ask your questions, if you guys could state your name, that way we could get to know you guys a little bit better as well.
Any questions? Yeah, go ahead.
Cassidy, I graduated in 2024. Sorry if I missed this, but for the bolt block to the basement, have you guys looked into the specs for the bolt block? Are you sure that it can support the soils coming in from the sides, at least from our year? And granted, there was maybe some constructability issues on our end. We had a wall fall and the soil was maybe up 2.5, 3 feet on one side in a wall collapse. So have you taken that into consideration and made sure that that will support it?
Yeah, Cassie, your question is, will our walls be able to support the soil load on it?
Yes, and not cave in, as well as obviously the load that's going to be on top of the building, for the first floor as well.
Yeah, absolutely. The math says yes, and I sat down for multiple meetings with Jack Miles, who is the head of product development at Boltablock. He is aware of our design and intentions, and from our calculations, it looks like it should. I can't speak to it from a practical standpoint or to your experience, but from our end of things, it looks like it should work great.
Yeah, but just, when you're building it, obviously,
yeah, be very careful.
Make sure you anchor it into the ground.
Yes.
Even more than maybe you should, so
And that's partially why we're running the two-phase construction, is so that people can get out if they need to get out. Ideally, we would never want to see that happen, but it's better to be safe than sorry. Anyone else? Yeah, go ahead.
Mark Porniconi graduated a long time ago. You had a great idea to reuse those bridge sections from the competition, but did you check the other thing that kind of happens here in Indiana, snow load?
Mm-hmm. So your question, Mark, is will our bridge be able to withstand the snow load? Yes. Greg, go ahead.
Yes, so we ran the calculations, and each one of those bridges is, as I said, rated for more than 800 pounds. They're also going to be reinforced more than they were even at the time that was tested. So those snow loads, we ran the math for the 15-year blizzard, and it is more than enough to support. And there's also the benefit that it is highly unlikely that we plan on running any RC cars along this track, so we do not have to worry about any sort of loads other than the snow load if there does happen to be a snow load.
Great, thank you.
Thank you for your question. Yes, Meredith.
Meredith 05. So this is a scheduling question. I appreciate the fast tracking of the excavation here in the next couple weeks. Did also note that during the presentation you all mentioned that everybody would have to complete OSHA 30 training.
Yeah.
I guess in the next couple weeks, as well as a survey for the students starting and what team they're going to be assigned to.
Yeah.
In the next 2 weeks, if you're going to be starting excavation. So I also noticed that between the horizontal observation, there was float available, but the vertical component was the critical path. So I guess with all of that starting in the next 2 weeks, there was a lot that had to happen prior to that. What is your plan to kind of make sure all that happens with Thanksgiving around the corner?
Yeah, I'll speak to the training portion, and I'm going to pass it to Greg to talk about the schedule. From the training portion, that's something that we partially misrepresented. Actually, every student in our class has already completed OSHA 30. It was a requirement this semester, and DPR actually graciously provided us with that training opportunity. So that's not something we have to worry about. The survey will get sent out. That should be something that's really easy to fill out. It might take someone 15 minutes. Greg, you want to address the schedule?
Yeah, I'd love to address the schedule. One of the important things is I say that we start construction in that 2 week time. But that is actually only the site layout and excavation activities. The rest of building any formwork and doing all of those things, when we get on site, part of what we will be doing in those first 2 weeks is breaking out into teams. And so when there are not any concerns that we have for having that time to break out into teams, because a lot of our time during the first 2 weeks is not spent directly on activities, but spent getting into our groups, setting up our work areas for when we arrive in the spring, and we can actually start the rest of those activities. We can also see that excavation starting and get that out of the way while the rest of our work areas are set up for success starting in the spring. Does that answer your question?
Are you using the same crews for the horizontal and observation?
No, we are using different crews for the horizontal component for the wooden ramps. We are going to be using the same crews that are going to be prefabricating those ramps and then putting those into place. We are then going to relocate them from the horizontal component over to the observation deck because the alignment of the ramps are very similar to building the decking for the observation deck. So that alignment of skills will work out.
Use your lessons learned.
Exactly.
Yes. Thank you very much.
Yeah, go ahead. Sorry, you in the front.
So I'm Sam, I graduated in May. And I guess my question is, you're doing the excavation theoretically in 2 weeks. How are you going to protect your trench from any of the snow that might come in there, the water, and also protect from people?
I can speak to the first part of that, or to the second part of that. From people, the SBRI facility is actually locked off, and then we're planning. So the gates are shut, and only certain people have keys. Brandon being one of them. We don't anticipate students getting in, but we also will barricade off our excavation, as is proper safety practice. Go ahead.
I would also like to note that because of the location of SBRI, the only people that should actually be having access to this, it requires going through a locked gate. And so over winter break, that should be locked off, and hypothetically, the only pedestrian civilians that should be coming through are those that are from the university, and they've been instructed well beforehand that this is an active construction site and are aware of the hazards that are going on. Thank you.
In the front row, sorry.
Some wider faculty. So I noticed that you had your excavation. That looks good. You addressed the concerns about snow accumulation, water accumulation. While the excavation is open, there'll still be water in the ground. How do you plan on getting the water out of the ground around the foundation going forward once you've done all your backfill and everything is occupied?
That's a great question, Professor Widener. To be honest, it's not something that we've considered yet. We have learned in our temporary structures class about how to use pumps to drain a site, and so because this is a design build project, that's something that we'll need to consider moving forward. But I don't think it would be too hard for us to do.
I think that also one thing to add on to this is that we expect the water table to be well below where we are. So the only water that we really need to be concerned about is runoff from snow and other rain activities. And while the excavation is complete, the only real hazard will be that snow, as once again all of our pours will be complete by January 29th, and our excavation should be fully filled in by nearing the end of February. This means that really we'll only be having to deal with snow, and that's relatively easy to remove with sump pumps and other sort of dewatering methods that we have budgeted for a few different sump pumps and hoses that can run that water farther away.
You've had your hand up twice. Go ahead.
The pre-constructed bridge with the ASE, I think that's a really unique and a really cool idea that you guys are incorporating. From a surveying perspective, those measurements have to be pretty exact, and I know are you planning to build around that bridge, or are you planning to install the bridge after? What's your plan to construct that and put in the puzzle piece?
Yeah, so your question is, are you going to build around the bridge, or is the bridge going to slide in at the end, and do you have controls in place for dimensional checks, etc.? Yeah, great, go ahead.
Yeah, so I'm actually captain of our Purdue ASCE steel bridge team, so I've been had a personal hand in the fabrication of both of these bridges, and we actually already have 3D models of both of these bridges, so we have those precise measurements, and also these bridges are made to be constructed on one portion and then lifted into place. I think the 2024 is 200 pounds, the 2025 is 300 pounds, so 4 people can all get in, lift it up, and set it exactly into place. So we plan on building the rest of our system and then sliding this into place because we know those dimensions very exactly, and if we ever need to go check them, we can just pop into the ASCE shop, run our tapes, and then go back out onto the site.
And if for some reason a modification would need to be made, Greg's a certified welder, so we have it checked off.
So you mentioned that a lot of your raw materials are going to be donated from various entities.
Yeah.
So in the negotiations for that donated material, were there any accommodations that you need to make for those companies, like recognitions or site visits or anything like that?
Yeah, I can speak to Voltablock. They were incredibly happy to hear that we reached out, and they were like, hey, you can have everything you want. Our only ask is that you keep us updated. Like, we're kind of curious to see what you want to do with it. So send us pictures, invite us out. Like, we want to be invested in this. If you need extra training, we'll send Hagerman's Masonry team out to come help you. As far as Henry Poor and IMI,
yeah, so Henry Poor and IMI, I've talked to them. It's a very similar. They're more so doing this out of the fact that they know that we are the next generation of engineers and the people doing this construction. And so they more just want to see what exactly we're doing with their materials because it's their materials, we're just using them. And so they really just expect pictures, they expect updates, and they expect, obviously, at the end, we plan on sort of having everybody a chance to come and view our final product. And we're going to have all of these companies come in and see, hey, these were your trusses, look at how great they look. This is your Voltablock, look at how well you trained us on being able to use this. And really give them a sense of pride that their materials are being used for the good of the next generation of engineers.
Yeah. This is our last question. We've hit time. Jack, go ahead.
I'm Jack. I'm class of 26. For your horizontal constructions, can you reiterate where you're using your cast-in-place concrete and your precast panels?
Can you show from the top view?
Yes. So we can see here, so here are wooden ramps. We plan on using cast in place for this here and then around this turn, and then we plan on using our precast panels, fabricating them over in this wider area, and then moving them in with a telehandler and setting them right down here. And so we plan on doing that because this area is going to be very busy with the cast in place, and so then the precast panels are just going to be able to fit in here once they're fully done. Does that answer your question?
And is that on a slab the entire way too?
No, that was just to make the easier of.
Okay.
Yeah.
Thank you guys for
today.
Thank you so much.
Yeah, so.
you have an extra one, then
How you doing? All right, sorry. How are you?
they closed the windows. How lovely. We were looking at
We'll go live in about 2 minutes. We'll go live in about 2 minutes.
I'll still send that for you. Yeah, no, I'm
You want to start the same order that team?
Yeah. Yes, yeah.
Just so you know, after I do, I'll bring everybody back together. Here, it'll count up to 50. Just so you know. All right. I'm guessing that clock's not out here. Yeah. Andy, it'll count up to 50. You got about a minute. All right, we're going to go live here in about a minute. Just like I told Purdue Cody, we'll have coffee in about 30. So at the end of this one, we'll have coffee for you. Okay? It's been a good start to the day. I appreciate everybody's effort. All right.
Good morning, everyone. We are SMAWL Construction, and we have the honor of presenting to you S-Right Nexus. So this is just a quick agenda of what we're going to get into today. I'm going to give a little short introduction to our company and our team. Then we'll get into the meat and potatoes of S-Right Nexus. Then we're going to talk about our budget as well as our schedule. Then we're going to get into the value propositions, a little bit about the management plan. Last but certainly not least, we'll talk about our safety program, give you some final notes, and then we'll open the floor to any questions. So, like I said, we are SMAWL Construction. We are a company where communication, reliability, and honestly, just overall protection is what we're about. Our mission is simple. We want to give you high quality, buildable solutions that push the project forward. Our mission? Start small, dream big. We turn ambitious ideas into achievable results. And above all, safety is a non-negotiable. And that's in every task, every decision, every day. Now I'm going to introduce our team. My name is Andy Flitner, and I'm the VDC/Design Manager. I have about 4 years of experience in construction and graphics technology, and I'm dedicated to making a model that is a database of information that provides for all aspects of construction.
I'm Logan Stevens, the project manager for our team. My responsibilities are the management plan and monitoring progress over the duration of the project.
I'm William Perez, superintendent and scheduler on site. My job is to track progress on site, communicate with the owner about everything going on in the field, as well as ensure attention to detail and constructability.
I'm Matt Dirksen. I am the estimator, and my role is to create a quality estimate for our team to use.
My name is Soren Colby. I'm the safety manager, and I'm dedicated to making sure that this project is completed safely.
Now we will get into S-Right Nexus. So before we get into our proposed design, I'd like to go over the proposal review, as most of you haven't had the full pleasure of going through the entire RFP. As you can see, there are a lot of details that SMAWL Construction was tasked with achieving. There's just a couple high points that I want to go over. The first of which is the 2 vertical structures, one of which is located at location B and the other is at location C. There is also a horizontal component that runs from location A over to location B.
I would also just like to point out some terminology for you on the site. This structure here between location A and C is referred to as the existing masonry structure. These two tracks that you see on the image are referred to as the existing horizontal components. This deck down here is referred to as the existing observation deck. Right adjacent to it is referred to as the connex, and then up here in this box is referred to as the existing drainage collection point. I would now like to give you a model walkthrough of S-Bright Nexus. Nexus, in the terms, that is the next generation of a legacy that we have been building for many years here at S-Bright. This is just a quick snapshot of the site overview. Up here, we have a designated parking lot area, which shows arrows of the flow of traffic in and out of site. We also have a designated area for laydown, precast for concrete, and a washout pit for concrete trucks. These two highlighted areas refer to vertical structure B and vertical structure C. The green line that you see that goes across the entire site maps out the horizontal component. Now I'm going to talk about the specific components, getting into vertical component B. This structure mimics that of a pole barn design. Its intended use is for a concrete design lab. The upper floor will sit on a layer of vapor barrier with a wood frame floor that will sit 4 inches into the ground. The pole barn has 6-foot 8-inch tall sliding doors, which allows for the movement of large objects and materials in and out of the space. There is a skylight for adequate internal lighting, as well as solar-powered stake lights that will surround the perimeter of the building for adequate external lighting. This upper level will also house the compressed air system that will be owner-furnished and contractor-installed. I would now like to get into the lower level, which is that of a bolted-block basement that will be used for drainage collection. It sits on top of a mat slab that will be surrounded with vapor barrier perimeter to prevent the seepage of water in through the walls. There is a hatch door for access, which will be locked properly with signage, as it is intended for maintenance purposes only. This entrance will be accessible by an A-frame ladder that will be built into the side of the wall. Inside of the space, there is a tarp-lined wooden tub, which will be used to collect the water from the gutter system of the upper level, as well as the drainage from the horizontal component that will tie in near this location. In this bucket, there will be a pump that will lead up and out of the basement and over to the existing drainage collection point on site, where there are exchangeable buckets that can be taken on and off site as needed. One of the reasons we decided to construct a basement beside the building is for that of constructability. This allows for parallel work to concur on the upper and lower levels at the same time, allowing us to push the schedule forward. This also significantly increases the drainage system performance, as it is much easier to collect water at a location beside a building rather than underneath it. To do all of the elevated work for the upper level, we will be using a temporary elevated platform that can be moved as needed. This will help us put the trusses in place, put up wind bracing, lay down our roof panels, and then finally install the skylight. Now getting into vertical component C. We are planning to do an observation deck expansion at this location. We are planning to expand 16 feet due west at an identical width of 8 feet wide. This mimics the aesthetic of the existing observation deck. We have added a staircase for better flow of foot traffic, which allows for the movement of 25 to 30 people at a time versus the original 10 to 15. This also helps increase the visibility over the entire site, allowing for a better view of the existing masonry structure, the existing horizontal component in front of it, and the horizontal component that we would be adding later on. I would like to note that we have made the time to check that our staircase has adequate movement, as it does seem very close to the existing horizontal component. Now getting into the constructability, we will be making this in 2 modular sections. As you can see in this image here, the red bubble surrounds that of the existing deck, while there are 2 modular sections at 7 foot and 9 inches long. We will first start by setting the posts for this observation deck in the existing slab, and then we will make these modular components on the ground and lift them up in the air and tie them in. Finally, we will throw boards down for flooring, put up railing for safety, and then finally add the second staircase. Now we will get into the horizontal component. I've separated it into 3 runs, which total 200 linear feet across the job site. This first run here is the far west run. Underneath the existing masonry structure, there will be a mechanical hoist attached into the ceiling that will lift a platform from ground elevation to the 2-foot elevation of the horizontal component. This run also ties into the existing horizontal component, as you can see where it ends. Now getting into the south back run. This is a very long back wall run that also ties into the existing horizontal component and passes by the observation deck and the connex. Finally, this is the far east run. This includes the S-curve in the road, which achieves 360 degrees of radial change, as well as tying into vertical component B. I will now allow Will to pass out 3D models of a section of the horizontal component.
These were done in collaboration with the Mechanical Engineering Department at Purdue University. They were designed by us, but ultimately printed by them with their help.
This section of the 3D model shows a concrete support, a piece of the metal panel, and then a piece of the half pipe that will be used for drainage collection. For the concrete supports, these will be poured in 2 separate lifts. The first lift will be the first 4 inches that make up the H-frame base. The second pour will be that of the vertical posts, which stand at 2 feet 2 inches tall. There are 21 supports total across the entire site. 10 of these will be precast on site, as I indicated in the site overview. These 10 will be placed along that back south wall run that I indicated. The other 11 will be cast in place on the far east and the far west sides of the job site. The construction sequence for this process will follow that of pouring the supports, drilling holes into the concrete, and then installing the panels and the half pipe underneath. This will follow a sort of train track process, as when we complete the supports, we will get into laying panels sequentially. We will then install the mechanical hoist in a similar manner as you can see in the image here, underneath the existing masonry structure, as well as installing the bracing for the platform to come up. As we move across the site, we will level out where needed, while accounting for the maximum slope of 5%. I would like to highlight the S-curve section of the road. This road consists of 3D printed concrete walls and accounts for 24 linear feet of the run. It is made up of 4 pieces, 2 of which are the outer walls and 2 of which are the inner walls. These walls will be 3 feet tall, as it will have to sit 6 to 8 inches into the ground for support and stability. We realize that this is presented as an alternative in the RFP, but we would like to implement it as much as possible, as we think it is an invaluable experience to be able to work with such amazing and fantastic technology. We do realize that if this is not made available to us, we will be able to revert back to our original design with concrete supports. Finally, I'd like to touch on our maintenance plan. As you can see in this image here, there has been significant damage due to wind and weather to the top of the connex roof. We plan to repair this roof by replacing the modular section, laying down the original roof panels, and also fixing the gutter system that lines the perimeter. As you can see in this image here, there is a significant crack in the existing horizontal component, as well as a crack in its 3D printed wall. We plan to repair these by beveling into the cracks, filling with as much epoxy as needed, and then finishing with a non-shrink grout. I will now hand it over to Matt for our budget development.
Thank you very much, Andy. So yes, getting into the budget development. The first thing that I would like you guys to notice is this pie chart that shows the distribution of funds and how they're going to affect the project. So you'll notice real quickly that vertical component B and the horizontal components take up a large majority of the cost. Now, as eye-opening as this might be, we believe it's completely warranted, considering these 2 components in particular contain a lot of value for the project. So for example, in the horizontal component, we have these steel panels that the car will run on, which do cost a lot of money for us. However, we believe it adds great quality to the project. And for vertical component B, the basement portion, which consists of concrete and bolted block, also is a large cost. However, again, this adds a lot of quality for our project, and we believe it is completely warranted to have these 2 components as they are. And then, of course, you have vertical component C, the maintenance, and the contingency that makes up the rest of the cost. So along with this, we want to emphasize, one, that we're going to have weekly checks during the construction process. We understand that many times the estimate is sometimes fluid, and in construction costs can change. So the purpose of those weekly checks will be to evaluate where we are in our budget and how closely we are following it. And of course, with that, we would like to have strong communication with the owner, because along with those weekly checks, it's important that the owner is fully updated on our plan. So, moving along, here is a chart that shows the actual costs by the number. So our proposed total, just over 17 grand. For the sake of this project and the unique circumstances, the labor has been pulled out of that proposed total. But of course, if you are curious in that, on the far bottom right, just shy of 28 grand would be the hypothetical proposal if labor were to be included. But we believe strongly that this number is a good one for our project, and we believe that we can deliver a great project with this budget. And before we move on, I would like to emphasize our original budget for this project was intended to be $10,000. Of course, we're above that. But later in our presentation, Andy will actually go over some value adds and proposals that can lower that cost while maintaining quality. So, moving forward, part of the process is change orders. Obviously, we're going to need those most likely. So this is the form that we will use for those. They will be very strictly tracked and logged. We want to make sure that those are kept track of very well. And obviously, like I said, format is shown. And as far as the budget itself goes and the number that we've come up with, we've taken that from various sources. A lot of the materials we used were from retailers like the Home Depot primarily, and as well as the RS-Means software that we use to put together the estimate. There are a lot of material and labor rates that are in that software in itself. So, all concluded, that is our budget. Again, we believe strongly that the number we have proposed for you guys is a great number for the work that we're going to do, and we believe that we can deliver great quality with the project. So, moving on, I would like to hand this over to Will, who is going to go over the schedule.
Good morning, everyone. I'll be going through our schedule for S-Bright Nexus. So at a quick glance here, we have our project structured here to demonstrate a summary of what's going to be happening. We have different components of the project categorized between phases as we move on through the project. Our critical path follows the vertical component of B, which is going to be our main focus for the majority of the project, since it requires the most amount of labor, coordination, safety, as well as planning, and amongst many other things. Our initial start date following our notice to proceed from the owner is November 24th, and throughout the total project duration and calendar days, we're looking at approximately 119 days, and then 73 in the spring, following the 2 weeks that we have allocated for safety and project coordination. Moving ahead here in our project kickoff, the biggest challenge that we faced with our schedule was being able to access the ground in the basement. It's kind of hard to dig in January and February when the ground is frozen. So after speaking with Ken Denneman, we came up with the solution to insulate the ground by putting tarps and weather blankets on top of it. This permits us to get into the ground January 29th and begin to start excavating and moving around the ground. He came up with a really good quote that I'd like to share with you all, and that's that construction happens year-round. And we digested that, internalized it, and we shifted our mindset from working around challenges to working through them. And I believe that's a big part of what we pride ourselves on, is completing things and making sure that things get done on time. So as you can see here, on our next vertical component B, phase 1 and 2, this is where we approach milestone 1. This is removing the winter blankets and beginning to hit the ground running. Following all of our safety components, our site coordination, we start getting into the real groundwork of vertical component B. Our first milestone encompasses pouring the concrete slab below ground, excavating, compacting, and doing everything required so we can start building from the ground up. Moving in our vertical component B, phase 3 and 4, this is where we begin to start tying in our above ground structure, where our vertical component B is going to be sitting on top of, as well as the roof for our basement, our vertical component B. We're tying them in together, and this was scheduled simultaneously to ensure that the team that's going to be coordinating and installing the vapor barrier would not be waiting around and having to relocate, reinstall material, and have to move between both of them. This was done simultaneously and with a purpose. Moving on ahead here to vertical component B, phase 5, 6, 7. We have our milestone 3 scheduled for April 9th. This is when our entire building is weatherproofed, tied in, and then we can start getting our utilities team in there to provide temporary and electrical power and have everything really set up so that that lab space can be used following our completion date. Now, we've built in float here through compressing our schedule and trying to get as much work accomplished in the beginning half. Our utilities team isn't scheduled to be in there until the 16th. However, we've extended their timeline and allowed them to work through the remaining time that we have in our project. And this was done so that if we need to reschedule and allocate certain things, because when we're monitoring project progress, things aren't going as fast as we would like for them to, weather delays are certainly expected. This allows us to push our project back, expand, speak with the owner, and see where we can move things around in order to complete the project. So switching gears here to our horizontal component, we have our phase 0 and 1. Phase 0 involves excavating, cutting the ground, filling it back up, and compacting it over by the observation deck on the south side of the project. That area isn't completely flat, nor do we feel comfortable putting our horizontal supports on top of it, because we want to have a consistent level and slope that doesn't change throughout the duration of the project to prevent settling and any other things that may come. So once we get that done, then we'll move along and start working on our formwork for type A stands. One thing that I'd like to note is that this was purposely done with the intent of not having any beams hanging overhead while we're installing or moving people around, as the observation deck and the nature of it being elevated. There's going to be components that are going to be hanging overhead and being lifted into place with the beams and the supports. Moving ahead here on horizontal component phase 2, this is where we begin to do our type B cast in place stands. Just something I'd like to note is that this would be our first concrete pour here, where we start having a framework done for all of the stands, and then we're pouring them in. Now, this is where we're also moving them in to the back of the component for the observation deck and setting them down once we have the ground completed. Moving ahead here to our horizontal component phase 3, this is where we reach milestone 5. So at this point, we're putting together all the track, just like a train track. We have the stands in place, we've set them, we've laid them out, there's no foot traffic happening. At this point, we'd be able to lay them down and then put them all together so that the car can go ahead and move along the track. For horizontal component phase 4, this is not a part of our critical path. This encompasses what we essentially want is to have the joists that hang at vertical component A being tied into and place supports in, so we can have our hoist lift the truck up onto the 2-foot elevation where the track's going to begin, and then have it move along. While this isn't a part of the critical path, this is something that we can structure and use to our advantage, where in the event that we have a weather delay, given the nature of the vertical component A being covered, we can accomplish and move this forward in the project and rearrange things. So that way, we're not losing time and we're not having people sitting around if it snows, if it rains, and it's just going to help move along our project. This here is our table for our workforce allocation. What you see here for work weeks are the days that we are going to be able to be on site. As of right now, we're planning for Thursdays. Overall in the project site, the time that we're going to have for the labor is 40 hours. This is going to be our biggest challenge and our biggest issue throughout the entire project. The limited amount of time that we have on site, working, and getting ready to do stuff. However, we've planned for this. We have our owner and construction meetings happening Monday and Friday prior to our pre-install meetings on Tuesdays with the rest of our workforce. Throughout these meetings, we're going to be preparing work packages, talking through issues, coordinating things, and making sure that everything is planned meticulously and efficiently, so that way people can hit the ground running and start taking small steps and giant leaps. Pictured here is our working days and pre-install meetings. Working days happen on Thursdays. We're expecting a 3-hour duration period. That may be a little generous depending on how we situate, materials are allocated on the site and delivered. And then our pre-install meetings will happen on Tuesdays, where we'll meet with everyone, deliver work packages, as well as communicate with each individual team. Here we have our key dates, milestones, critical path, and overview. So the schedule, again, I'll just summarize a lot of things that I've said because I know it's a mouthful. Our schedule is made with the purpose of prioritizing vertical component B. We realize that this is something that is going to be used and utilized throughout the duration of its life cycle by students at Purdue. So we want to make sure that we build it and we prioritize this. Again, Tasks involving vertical structure B's floor and roof are scheduled to finish, and finish simultaneously, reducing stoppage and coordination. Areas surrounding the observation deck extension underneath pose a challenge for the track and stands, which is why we purposely planned and designed to move the precast stands in that area. We're pushing hard for the vertical B at the beginning of the semester, so that would leave us around 3 weeks to work and expand our schedule, as well as 13 working days total. So just a quick recap of our milestones. Milestone 1 is the vertical B underground slab being poured and completed. Milestone 2 is going to happen to be our vertical structure B above ground floor and underground ceiling floor section being tied and connected, as well as vapor barrier. Vertical structure B building envelope dry and complete is our milestone 3. Milestone 4 is our observation deck, and milestone 5 is going to be the completion of our horizontal track. I'll go ahead and pass it on to Andy here so she can talk about our 4D modeling and XR10.
Thank you, Will. So, in the spring, we will be using the XR10 to overlay a hologram of our project or our model on top of the actual physical project. This will allow us to catch any issues before they become severe problems and could impact the schedule. We will also be using our 4D modeling in order to validate the schedule and help with construction sequencing, as you can see in this example that I have made for us. This will help us coordinate with the trades and allow them to have a visual roadmap of what's occurring out on site. This will also help confirm what we're doing for the workday and making sure that it's getting placed correctly. I'm now going to get into the value propositions. Starting off, we would like to propose a material alternative of using wood and timber for the horizontal component. This would significantly decrease the cost and the labor it would take to create the horizontal component, as you can see in this figure here. This would also match the aesthetic of the current existing horizontal component at the S-Bright site. This would also decrease any hazards that we would encounter, such as strains from lifting heavy metal steel panels, as well as any burns we might get from being in contact with concrete. Another material alternative we would like to propose is that of a concrete pad at vertical component B. This would increase the durability and the structural stability of the entire pole barn, as well as helping with moisture resistance, because there is only so much that vapor barrier and a wood frame floor can do against West Lafayette's rain and snowfall. Although this would add to the cost in the schedule, as Will had mentioned before, we have added in float for adequate value propositions such as this one. An addition we would like to propose is that of an overhead canopy on vertical component C. This would provide great weather protection, and it would prevent ice and snow from forming on the observation deck, which could lead to slips, trips, and falls from those traveling across it. This would also significantly increase the longevity of the deck, as there would be much less wear and tear from any rainfall or snowfall. This also just gives the deck an elevated appearance. I think that's a great add to give to S-Bright in general. And finally, we would like to propose for the removal of vertical component B. As you can see in this figure here, this is going to be a very large excavation area on an already small footprint of a site. It will be difficult to manage any groundwater maintenance, as this will be an open hole for a long time, and we will have to significantly improve our adequate pumps and everything in order to keep water out of this excavation site. Although we are following OSHA standards with a 1-to-1 ratio for type B soil, we cannot confirm the trench stability as we are working in this area, which poses as a significant hazard to those in it. This is also a large fall hazard, as it will be open for a long amount of time and will have to be barricaded off for this duration of its opening. As you can see in this figure here, this would significantly reduce the cost in the schedule, which we feel is like an add to the project. This is just a summary table of the alternatives and the cost and schedule impact that they have. You will be able to refer to this in your appendix when needed. I would now like to hand it off to Logan for the management and execution plan.
Thank you, Andy. Now that you've all had the opportunity to hear how we're going to build the project, here's how we plan to execute in the spring to have a successful project. The management plan covers 6 main components of the project. While these may be sequential, it is imperative that the management plan ties into each and every part. The phase that poses the biggest risk is the build phase. The build phase has the most constraints with the time and the varying weather conditions on our site. To mitigate these risks, we've designed a plan, and we will be ready day one to pursue our construction goal. A key component of achieving our construction goal are going to be our constructability reviews with the owner. Each week, we will meet and ask ourselves one central question: is this process safe, smart, and efficient for everyone involved? Smart, as in an innovative addition to the S-Bright Nexus, safe for all personnel, and efficient as in a way to maximize our time. Our constructability reviews will be handling everything from 3D model walkthroughs, work sequencing, site logistics, and code compliance with OSHA. To maximize everyone's experience on the site, we will be sending out a survey to gauge interest and aptitude in what discipline people will likely want to spend most of their time doing. We will also have the opportunity for people to volunteer to be foremen to gain additional leadership experience and work hand in hand with our project team throughout the semester. Our project team will step up as general foreman during the construction days, and this way we have a hand-to-hand approach with our disciplines, and we can work closely with everyone. A key part of managing our workforce is training them. We intend to have everyone cross-trained, therefore they can help out when needed, that are very flexible, and that they have experience doing everything, so everyone has a good, well-rounded experience. They don't feel pigeonholed into doing one thing for the entire semester. Another key component of our trainings are going to be our toolbox talks. These will cover everything from safety to the tasks of the day to even using small tools that people might not be familiar with. When it comes to procuring our materials, this will be coordinated between our project team and the CEM office once we have negotiated our lead times and our costs for materials. We will have an updated material log and receipt form to track our progress, and we will be using this to schedule just-in-time deliveries to maximize or minimize any site logistical errors that may occur, and to make sure we don't move material more than once. Our prefabrication components, this will be coordinated between our vendor and our project team, and we will be creating illustrated shop drawings to help with this, smooth the installation process for our workforce, and to help foremen give them a key thing to show on how we're going to accomplish this. When it comes to quality, we understand this is a very fundamental part of our project, and we've basically divided it into two main components, as most of the industry has: assurance and control. Assurance, this is going to cover everything we do ahead of time to make sure that we produce the best quality possible. This will be our pre-install meetings, our inspection and testing forms, and document control. Quality control, on the other hand, will be everything we do in the field to make sure that we have a quality result. These will include our pre-pour checklists, our field testing reports, and our daily quality control reports. This will be a key responsibility of our foreman in the field. As for progress tracking, again, this is something that comes from the foreman up to the general foreman, and eventually to our project team, and we will be making sure that our project is on time based on a percentage complete model of materials to date. We will also be monitoring man hours to see how we're estimated to complete the project. We will also be gauging our schedule based on our major milestones and how our work packages are being completed in comparison to those milestones. For our subcontractors and vendors, if needed, we'll be using a competitive bidding process, and we ask that they upheld our standards that we have set for ourselves in terms of safety. We will also be using local subcontractors to support local businesses and to aid and ease the mobilization throughout the project. Risk management is twofold. First off, the safety component. In the case of any emergency, we will be contacting 911 immediately to make sure that everything can be handled by professionals when needed. And from a building standpoint, we have a 5% contingency fund allocated to the budget. We'll be having volunteer work days to offset weather delays or other unforeseen delays, and we have a next man up leadership format to ensure that we have no scheduling issues on our end as an executive team. Lastly, we want to ensure that everyone has a good experience that they are going to remember and cherish for a long time. These have certain incentives in place in order to get people to buy in and want to be more involved with our project. These will hopefully include a food truck once we achieve milestones, hopefully sponsored by some industry donors. And then we'll have toolbox talk trivia, as well as a safety recognition program in which people are available to get rewards such as gift cards and t-shirts for participation. And now I would like to hand it off to Soren to cover our safety program.
Thanks, Logan. Talking about safety, we know that it's not just something that we can fit in a few slides. As you've noticed, we've talked about it throughout the whole presentation. First of all, I want to talk about it by design, however, and how we'll be implementing a tracking system to monitor who has what qualifications, who our competent persons are when it comes to our different tasks. On a daily level, on a site level, we'll handle JHAs, job hazard analyses, job safety analyses, and we'll also implement a near-miss system. Those job hazard analyses will be completed before work begins to analyze what could be happening, what hazards we have on the site. The job safety analyses tie into that, where it handles more of that changing conditions that we have on the day-to-day, so that each crew is aware of what work they will do. Now, housekeeping is also very important for our safety, because if we have everything in order and we know where everything is at, there's less to trip, to fall, to be worried about. A dumpster will be provided on location for the duration of the project. Next, we'll talk about safety by crew. We know that there's different safety programs that we can implement. On the daily level, we'll implement those toolbox talks, in which we'll have that trivia. Our different crews will know what they're going to handle that day and what they're going to be doing. On the weekly level, we'll have safety meetings so that we can review perhaps those near misses, what we're doing well, and what we might be doing wrong. We recognize safety is something that's always changing depending on the condition of the site. Now on the monthly level, we'll also have those high-level meetings and those crew awards so that people are encouraged to keep on working safely and it's not a chore to do what they're supposed to be doing. We recognize that also by crew, we have high-risk work, especially work from elevations. Seeing as our vertical component B has that roof system, our extension of the deck at vertical component C, we want to make sure that people are well aware of what they're doing, as well as any other possible high-risk work, such as electrocution, getting caught in between things, and things of that like. Next, we'll talk about safety with regards to our location. We know that working at the Center for Aging Infrastructure at SBRITE comes with its own difficulties and challenges, just such as the speed limit. To get to the site, there's a 15 miles per hour speed limit. Once we reach the site, we're enforcing a crawl. That way vehicle traffic is not a danger to any foot traffic on the site. We also know that the 2 weeks at the beginning of the project are dedicated to orientation, which comes with safety included. Here's a map of our evacuation plan in the case of any emergency. You'll notice a muster point located on the north side of the project and an EMS site on the south side. In the case of severe weather, we'll follow the proper protocol. Next, I'd like to talk about the pour plans. The first pour plan, you will notice the arrows indicate the vehicle traffic for concrete trucks. This includes our first horizontal pour and the mat slab pour being done at vertical B. We'll have designated flaggers, and that day will be solely prioritized to concrete construction. Similarly, for our second pour plan, it'll be another concrete focused workday, except we will not have the pour at vertical B, so our area of traffic for those concrete trucks will be smaller. This is all for safety. Now we'd like to go into some of our final notes. Our schedule, our estimate, and our project management and execution plan. We have worked on these tirelessly to show that we are capable and well off to do this work. We know that this job will come with its challenges, but we are ready to adapt and to work through these. I'd like to thank everybody for coming here, whether you're faculty and staff or industry partners, our judges. I'd especially like to thank our mentors, Christy and Tom, for being here and for helping us throughout this entire project. Now we'd like to open the floor to any questions. Thank you. Yes.
You mentioned subcontractors. Could you be more specific? I mean, what subcontractors would you be procuring on this project?
That would be mainly for excavation. We would need help from that standpoint, getting operators.
Okay.
Yes, in the back.
You identified a 5% contingency amount. I'd like to explain how you arrived at that and what are the factors that affected your selection of that amount versus 0 or 15. I mean, it's just a number. So maybe describe that a little bit, and you're welcome to talk about cost elements or schedule.
Right.
So as with construction, there's going to be a learning curve. We expect that there's going to be some rework having to be done, whether that be for framing. There's always incorrect cuts, things that may not line up correctly. That's where we expect to have to purchase more material or potentially have some added stock. This, will be something that we'll continually monitor throughout the project. So that 5% was a general number that we kind of estimated through industry standards and piecing together our previous experiences throughout our previous projects as well. So that's kind of where our number comes from.
How about schedule? I mean, the issue of schedule uncertainty. I know that mostly it affected your free labor, but I mean, where are the pieces of this that are uncertain in terms of schedule? And were there any considerations made in your design to reduce that?
To reduce it, yes, absolutely. So having to work our way around the excavation site, this was where we implemented the weather blankets. Had we not implemented those and had to wait for the ground freezing line to soften up and be able to dig in there, we may not have completed our project in time. It's a long schedule, and at minimum, we're going to be looking at 10 weeks for vertical component B the way we have it designed and planned out. So having to implement that change into our project and our schedule was what allowed us to be able to feel comfortable presenting today our schedule, our design, and giving ourselves that float time, which we're certain that will come in handy through weather delays, slower than expected construction progress, amongst many other things.
Thank you for that answer, Will. I'd like to add on to that if I could. I think another great component of that is what we proposed with our value propositions. Coming into this project, we wanted to give something to the owner that fully met the requirements that were listed out on the RFP. Now, on the RFP, it does not explicitly state anything about the schedule, so that's why we presented it in the way that we did, and then we gave value propositions to be like, this is where we could reduce some cost or some schedule, or maybe we could even add on to it in order to further enhance the project itself.
Behind the right there, yeah.
On the value proposition for removing the basement, that did have significant schedule savings in the schedule, but the dollar value was only $1,200, which seemed light for concrete slab and excavation and multi-block and all that. What all went into that credit?
I'll touch on that first, and then I'll allow Matt to go further in the budget. The bolted-block walls, we are going off of the existing material that is still on site right now. There are about 8 to 10 pallets that exist of the bolted block that was left behind from last year's group, and we are planning to implement that as recycled material since it is made available to us. Now, if there was a problem with that and it didn't work out, we were fully prepared to give any other design alternatives for the walls of the basement, but that had a help in the terms of the cost. Matt, is there anything you'd like to add?
Yeah, thank you. And that's pretty much what I was going to say. The recycled material did bring that cost down, so that was a big reason for why it seemed like such a small number.
Professor Widener.
Building on the issue of that alternate, if we do not accept, or if the owner does not accept the alternate, what are your, do you have any concerns with, number one, groundwater accumulation around the foundation of that lower level, outside of the structure? And number two, are there any concerns about the foundation structure for the adjacent pole barn portion of that structure, given that you have to do the excavation with the cutback that you described?
Absolutely. So as part of our excavation art that Andy demonstrated earlier, our plan is to purposely lag behind the excavation following the initial underground basement. This was done with the intent to allow for teams to go in there and compact the ground once it's filled back in, and the CMU blocks our CMU blocks are ready to get put up. And we'll be starting from the edge moving backwards so as not to back machines into the hole. So this was one of the ways that we mitigated risk and improved safety on our project site, while also thinking about the things that you mentioned. As for ground watering, we're planning on covering the hole throughout the times that we're not working there. That's why there's a big push to be completely tied in from the above ground vertical structure, which is gonna act as a floor, and the ceiling, which is gonna, or the underground structure ceiling. And once we have that done, vapor barrier and waterproof, ground water shouldn't be an issue at that point.
For your safety plan, it looks like your muster point was in the laydown area and your EMS site was like the furthest from the road. Can you explain like what's the thinking in placing those?
Right, with the EMS site, that's located there at that Connex, which is a indoor space. At the moment, it's one of very few. That's the reasoning for that. As for our muster point located at the laydown area, we wanted it closer to the road. We know that our parking is further east on the site. We didn't want to put it there because it would be a little further out of the way. And that muster point having it there, it's kind of a not quite centralized location, but out of the way and centralized, if that makes any sense, close to our construction projects.
Thank you.
Professor Graf.
Yeah, just make it back to some of the issues about the viability of the basement and things like that. As I'm interpreting the overall project configuration, it seems like the last portion of the horizontal component would be running over the top of the roof of the basement. Is there any way that those are interacted, or is that alignment just not, am I not interpreting that alignment?
I'd love to answer that question. So the horizontal component is terminating right before the edge of the building, and then the underlining drainage will basically be following into the top roof of the basement. So there will be a cutout that will allow for water to drain into there. So it'll be within 6 to 12 inches of the edge of the basement.
Question? Yes.
Are there any concerns with the boulder block of once you put the dirt back after trenching and building on top of it collapsing inwards once you start construction?
Yes, that is something that has been considered in the design, which is why I also brought up the alternative of materials for the walls. We did do very quick calculations on this, time permitting with all we had to present with the rest of the project. This is something we couldn't have sat on for very long, since it is more a focus of the type of material. We feel comfortable in providing design alternatives and being able to get those out to the owner in an adequate amount of time if we do eventually sit down and take the time to fully design and fully calculate the stress that the walls would be experiencing.
Perfect. Right here in the front.
So I know you guys kind of touched on it in the beginning, the design of that you're putting a hatch into the basement. What, like, kind of what's the dimensions of that hatch? What's the, just kind of specifications of what you guys have done in your design?
So it is a square hatch door. It is a 5 foot by 5 foot area. It is locked off because of ADA requirements, to where this accessible area is intended for maintenance purposes only. We don't want people in such a small and confined space at long periods of a time anyways, because we can't confirm any of the flow of oxygen through this area because of the limited supplies that we have in order to provide an HVAC system in there. And so it would be for the purpose of only getting in there to fix a pump or make sure the water isn't overflowing or anything like that. And we would be willing to implement any proper external monitoring systems, such as cameras in the basement, so we would be able to have a quick visual on that and prevent the entry into it as much as possible.
So I guess I was kind of hoping my question would go more towards like the material.
Yeah.
Like, are you purchasing a prefabricated hatch that you can just set in, or are you gonna build on site something made out of like
Yeah, so it would be intended that we would purchase a hatch door from any of our provided vendors. Obviously, with time permitting and cost as well, we are fully capable of making the hatch door ourselves, just to mimic the exact same structure of the top of the basement with wood and any hinges and adequate locks and handles.
Will, this question is for you regarding schedule.
Absolutely.
I saw the critical path. You had great schedule visuals, thank you. Regarding the vertical structure, you would have a spring break component there.
Yes.
For a non-work period. I did not notice the same non-work period as spring break for the horizontal components on the visuals, but I just wanted to, I guess, have clarification that you did include that in your schedule analysis for the non-critical path horizontal components.
Right. So even though it's not considered, I don't believe that there's anything scheduled on that week for those days, because in our schedule we usually do use pre-install meetings as a date where we'll meet before, and then the workday follows sequentially with that one. So although it's not listed there, we are keeping track of it throughout the duration of the project.
Any other questions? Any comments, concerns, compliments? Things you guys like?
Did you all go out and buy the same colored ties and pocket squares?
That's called having a woman on the team.
That's right. Well done.
Thank you.
Thank you so much.
Good job, guys.
So waiting on time.
have this one too. I guess around.
Wait, sorry. Everyone's ties looking good. All the ties looking good. iPad's over here.
How long have you been here?
Hey, you might want to tell them. Just fix it. He knows what happened.
Let's go, guys. you're like text. What I'm doing is I'm getting pictures out on LinkedIn if you haven't seen it already.
All right, let's go.
All right. You're gonna see this.
Okay, saw that.
So we got about a minute and a half. Okay, make sure you get some snacks back here. Get your sustenance up.
Joe, you wanna?
Yeah, we're close to lunch.
I got it.
Close to lunch. Okay. All right.
Thank you everyone for coming out. We appreciate all you guys being here. We all know how busy construction industry really is, and you guys taking them out as much time as out of your guys' busy lives to come here and hear all of our hard work this semester. We really appreciate it. We know that you guys had a couple proposals already, and we're going up until lunch, so we thought it might be a fun idea to everyone stand up and get a little stretch in. Show our commitment to safety and what we're going to be doing every morning when we're on that job site. We'll start with a little bit of arm circle action here. We won't do too much, but loosen it up, get the blood flowing. We're going to have a fun presentation here. Maybe some neck rolls. And everyone loves the good old wrist action. We appreciate everyone. You're welcome to sit down whenever you want. So we are Last Call Construction. This will be our final proposal for the S-Ride expansion project here at Purdue University. Here's our agenda for today. We're going to start with a team introduction, go through some safety orientation, and get a design overview, some maintenance, and hit all on our budget, schedule, and what value we bring to you guys as an organization. Here's the site overview. In this bottom left corner will be our first structure, which is the centerpiece of our project, which is a 2-story laboratory building. The first story is actually a subterranean condition, approximately 8.5 feet below grade, constructed with bolted block. The second story is a wood stick-built design. Over here, in the middle, we have a 200-plus linear feet roadway that has 360 degrees of radial turn throughout. And the last piece of our project is an observation deck extension to the existing observation deck, which you can see in the top right corner here. We're confident that our team brings a lot to the table, and we're not going to be the best just to design this project, but manage the 40 laborers and students throughout and minimize risk and get that cost as low as possible to get this project done for you in time. We'll start with our team introduction here. I am Joey Phillips. I'll be our project manager on this job.
And I'm Luke Butler. I'll be the superintendent and safety lead.
I'm John Kuster, our virtual design and construction engineer.
I'm Captain Reese, I'm our design structural engineer and assistant safety lead.
And I'm Elijah Gill, project engineer and chief estimator.
Alright, so starting off with safety. As always, safety is going to be our #1 priority. And today I really want to show you all why we have a culture of safety and how it's going to be integrated into all phases of construction. So as I stated a little bit earlier, I will be the safety lead. I will be assisted by Catherine East right here as the assistant safety lead. Our overall goal is to have a 0 incident job site. And we think that by having this, we're also going to be able to reinforce quality and production. Starting off with training, we're going to kick things off on January 15th with our safety orientation, where we're going to go over things like hazards, PPE, and emergency plan. We're going to have weekly toolbox talks every Thursday before work that I'll lead. We're going to have monthly formal safety reviews on February 5th, March 5th, and April 16th, where we go more in depth on safety, things we can improve on, things we've been good on. We're going to have past-specific training, things such as excavation, concrete work, working on heights, as well as a 15-minute safety moment that starts every lab, with the pre-task plan review, as well as the stretch and flex that I'll lead. In addition to this, and commitment to having a safe job site, all of us managers, as well as laborers on site, will be OSHA 30 certified. So for PPE and documentation, at a minimum here, we're really looking for a hard hat, high vis, gloves, glasses, boots, and long pants. For our documentation complete weekly, this can include pre-task plans, JSAs, or job safety analysis, field inspection logs, near miss and incident report forms, as well as observation deck safety audit, which I'll hit on a little bit later. So for the observation deck safety role, this is going to be a dedicated crew that will primarily be on the actual observation deck, but will also be roaming, that's going to focus on safety primarily, but also quality and production, seeing things that we can improve on and report back to for our Tuesday work sessions. They're going to be capturing video and photo for training records, things that we can look at on Tuesday, as well as for future labs. And they're also going to complete the weekly safety audit. So for industry practices and alternatives, I think it's really good that we can have Procore because this is going to make managing and tracking safety a lot easier than versus just doing everything on paper. We're also going to have a good catch program where we can prioritize finding hazards before they become a problem, as well as the stretch and flex program before we're valid. So for emergency response and key metrics, the superintendent safety lead, I'll be the incident commander. I'll be assisted by Capstone, who will be qualified in first aid and CPR next year. For communications, that's going to be run through our project manager, Joey Phillips. And as you can see here, our muster point is actually going to be right there in the neon green. So essentially we're going to be meeting every morning, Northwest Gravel Lot. And for our safety metrics, we're looking for a total reportable incident rate of 1.0 or less, a lost time incident rate of 0.5 or less, and an EMR of 0.75 or less. We're also looking for one or more near misses catched per week.
And I'll get us started on design with the horizontal roadway. So project requirements included over 200 linear feet of roadway, as well as 360 degrees of cumulative change and a 24-inch elevation change. Our solution for this included modular roadways that had both precast concrete and cast-in-place concrete, with the curves being created out of wood, as well as loading docks on where the new lab space is and where existing conditions are. The rest of these are all made out of wood, and then I'll be handing out a small scale model to you guys while Casper gets us introduced on all the details.
So yeah, first with our lab building, we're going to use excavation with it. So with the excavation, we're planning to use that SMAWL as a leveling for our roadway. And that first roadway will utilize the cast-in-place concrete. So with that modular section, I'm going to go more in depth with this concrete modular section, which will be designed as steel decking tops with 4x6 wood beams and girders, and then we will be utilizing scaffolding legs as our legs for this that will be put into the ground using post holes utilizing concrete, which is recycled from the quickcrete that is on site. Then we have our wood modular section, which will be utilizing 2x4 wood tops with 4x4 wood beams, girders, and legs. And then we have our 3D printed concrete modular section, which will be utilizing 2x4 wood tops, 4x4 supports, and 4x4 wood legs. To go more in depth with our precast concrete, we're going to utilize 2 foot by 8 inch by 4 inch precast concrete slabs, which we will be prefabricating off-site. Each of these slabs will be utilizing number 3 rebar and wire mesh within to establish a more structurally sound design. Each of these slabs, there will be about 6 slabs per modular section. There intends to be around 100 modular sections per with the section. And then we have our mortar mix bed. To connect these slabs to the modular sections, we are going to utilize mortar mix, which will be about 1 inch thick, which will lie under the slabs and above the steel decking to create a stronger connection, as well as mortar mix between the joints of these slabs to make it continuous. Then we will be, for our cast-in-place concrete, we'll be pouring 4-inch thick pours with 2 number 3 rebars and wire mesh throughout. As you can see from our pour plan map right here, we are intending to have mixer trucks come into the site and go on to these mixer locations and move their chutes to the desired spot where we level out the concrete to meet our requirements that we had tasked. Then we go into our wood modular design. Like I said before, it'll be 2x4 wood tops as more of a deck style, and then 4x4 wood beams, anchors, and then legs. The concrete sections will be placed before these wood sections are installed, and because of that, we are going to construct these wood sections on site to allow for quicker measurements, and it helps our schedule and cost. It's a little more cost effective without having to transport it. And when we say curved sections, we mean these shapes will be trapezoidal to allow for that curved action to happen.
What we failed to mention earlier is, but you can see in our model, is we will have drainage using some of the PVC on site as well as additionally bought PVC. Lastly, our 3D printed concrete horizontal modulus. This will be a parking or loading zone by the existing storage facility. It'll consist of a 2x4 top with 4x4 wood supports and 4x4 legs with an architectural 3D printed wall around. This is really just to show our company and Purdue's commitment to innovation and constantly trying to look into how we can build better and build safer. And here are some of our horizontal renders. This first straightaway here will be all of that precast as we were speaking of, and then you can see the wood curves, and then those other straightaways will be the cast in place concrete bits, as well as our 3D printed horizontal modules.
And now getting into our lab building overview. You can see our rendering here. We'll have a 2-story laboratory building with approximately a 200 square foot footprint. This will have a subterranean basement condition, which is 8.5 feet below grade, along with utilities, lightings, and ample space to support all lab CNE operations. This will be integrated with recycled materials such as Voltablock and PVC for our rainwater collection system that will tie into the already existing water collection system. And lastly, this is going to interface with our new horizontal construction. Luke's going to get into our excavation details now.
Yeah, so with excavation, the main thing here that we wanted to figure out early on is what type of soil we're going to be working with. And after some conversations with the owner, we came to the conclusion that the soil will be type E. And with type E soil, that means we need a 1-to-1 ratio of vertical depth to horizontal depth. So for the excavation area, on top of the 20 by 10 footprint, we'll be adding another 2 feet of clearance for working with the formwork, as well as 8.5 feet of slope dirt on all sides to meet the shoring requirements. Additionally, here you can see spoil storage, where we'll be keeping this very close.
Now for the actual basement slab that's going to be supporting this whole structure. We're going to have a monolithic 4-inch slab with a 12-inch thickened edge footer. You can see here in our drawing the interior is going to be this 4-inch slab, which will act as the floor for the basement. Then going around the perimeter, we'll have a 16-inch wide, which is the width of Voltablock. That will be the footer that is 12-inch depth. That will maintain the load of the weight of the building. For the structural steel on this slab, we're using 20 number 3 bars running horizontally, and then overlapping that, we're going to use 10 number 3 bars. For the thickened edge footer, this will go completely throughout, but we'll additionally have 2 number 4 bars at a deeper effective depth to support the additional load. We verified this by calculating the area of steel required per the slab and finding the minimum and maximum spacing and the effective depth needed. Additionally, it was important for us to make sure that the soil that is going to be under this slab can actually support the weight of this building. Due to it being a pre-existing job site, we knew we did not need to take into account right now for water acting forces on it, but we used the area of the soil and the load path from the trusses all the way down to the footing to calculate the average soil bearing that's going to be within limit. For the actual structure of the basement, we're going to use recycled Voltablock on site. After a site visit, we counted over approximately 500 Voltablock remaining from previous projects. We're accounting for additional use of footing blocks needed and corner blocks, so within our budget we accounted for this and anticipating our purchasing of more Voltablock material. Voltablock is a post-tension through steel grid system that locks up immediately, meaning there's no grout cure required, meaning we could do 3 courses per work session and creating an efficient workflow. This also eliminates safety risk of the wall collapsing in as well. For our entrance to the basement, we had discussions with the owner of what they were exactly looking for. We found that this space was not going to be an ADA compliant working area, so we knew it was not necessary to have accessibility entrance, and we wanted to go in with a ladder entrance system that will be constructed out of 4x4 posts and 2x4 ladder rungs. This will ultimately optimize the amount of space in the working area and overall storage of the complete project. Additionally, like I said before, we didn't want this building to collapse inward on anyone. That would be obviously the worst case scenario, so we ended up using the type E soil previously discussed to calculate the resultant forces of the load of the soil acting on the wall. Once we got those resultant forces, we used pre-engineered Voltablock tables that were designed to show the capacity that the walls can actually support and ensure that our soil resultant force was less than the capacity with an added factor of safety. Now Eli's going to, My bad. We're actually going to talk about our wall elevations first, and we're going to have 20-foot wall elevations showing the amount of actual bolted blocks required to be used. There's going to be corner blocks, line blocks, and footing blocks. Additionally, here's our 10-foot elevation showing the amount for the 10-foot block. Now Eli's going to get into our first floor construction.
Yeah, so once the bolt block structure is erected, we'll begin framing the floor joist system and the floor detail you can see on the right here. This involves a 2x8 wood sill that goes on top of the bolt block wall, followed by 2x8 floor joists, followed by a rim joist that goes around the perimeter in order to secure it. On top of this, there will be a 3/4 inch plywood subfloor. And then we'll begin the framing of the walls. This is a 2x4 frame with windows and doors framed within it. And then on top of that, there will be pre-engineered roof trusses, followed by metal framing panels that will go on the roof. Then we'll have MEP, rough ends, power, and all the systems that make it successful to become a lab space, as well as recycling PVC and other materials in order to create a water collection system for the building. You can see here on the left, this is the sill that will be attached to the bolt block on that detail here. And then this is the floor joist plan. This is going to be spaced 16 inches per floor joist. And this is the different types of bolt blocks that will be used in the plywood floors that will be used on the floor right here. Then this is the detail and plan design for the framing. This will be sheathed around with weather-treated plywood. And then on the right here is the pre-engineered roof truss system. These will be attached using hurricane clips in order to secure it to withstand any weather that it might experience.
Next, we'll be talking about our observation deck expansion. After discussions with the owner, we found that the primary use of this structure would be to provide more ample space for not only more students to be on the deck, but to be able to view the expanded site. To conquer this, we ended up just going with a deck extension that would be similarly designed to the pre-existing deck. With the larger deck and the more people being on the deck, we thought it was important to add a second form of egress in case of any emergency exit. We're going to add, once again, a ladder system that will have a safety latch for only use within emergencies. This will once again be 4x4 posts and 2x4 rungs. Taking into account that we are in Indiana, we knew that would be important to account for all the wind and snow loads that could be affecting this. So to ensure that this was structurally stable, we took the load path of the floor joist to the outer rim, to the post, to the footer, and verify that all individual members can support the total load of the wind and the snow and the weight of people acting on it. With the added length of the structure, we also knew it was important to check for buckling. So we verified that there would be no buckling on the structure, and this is going to be a completely safe and sound structure for large group students to be on.
Lastly, I'll get us started with systems. Ultimately, we decided to go with a solar system. This has been proposed in many previous projects, but has been failed to be implemented. We found a kit that included 4 100-watt solar panels, which would be a total of 400-watt solar array, with a 1.2 kilowatt-hour lithium battery and a maximum PowerPoint tracker controller to make sure we're getting the most out of our solar panels. It'll adjust the voltage and the current to make sure we're actually getting everything we need to power our battery. And then lastly, we'll have an inverter to make sure we can have that DC power converted to AC power that's usable for all our lights, outlets, and the compressor system that will be in there.
So to go more in depth with our compressed air system, we are going to utilize an oil-free June Air 87R15B as the owner request. This can withstand 120 psi and outputs about 1.2 cubic feet per minute. We're going to utilize half-inch polyurethane tubing to distribute it out to our 3 points of use. These 3 points of use will be the lab building, the existing structure, as well as next to the compressor and adequate areas near it. And this will be powered by these solar panels that were discussed previously. And as you can see from our PNID diagram right there, we will have an air intake into our compressor, which will go to our separator, into the tank, into the regulator, into our points of use.
And lastly, we didn't want to just build whatever we were building. We also wanted to maintain and add value to what is existing. So on site, there's a lot of wood roadway construction, and although it's all treated wood, we have noticed it is starting to deteriorate a little bit. So our proposed plan is to add wood seal as well as paint, so it more closely matches the owner's intent of using it for RC vehicles as a roadway. Additionally, we found portions on site that didn't have walls on the side of the roadways. So in order to preserve the owner's investment of the RC vehicles as well as to prevent people from falling over, we intend to add a guide wire to make sure we're protecting everything. And lastly, it isn't pictured here, but there are 3D printed portions on site, and they have cracks in them. We've been told by the owners it's not structural, but to make sure everything on site still looks good, we have budgeted out route to make sure we fill those cracks and make everything look nice.
Next is the budget overview. Like we have mentioned before, this project has 4 major components. This includes the horizontal roadway, the observation deck, lab space, and maintenance. This total comes out to $15,491.84. However, we're also budgeting a 10% contingency for any future possible costs, which brings our total to $17,041.42. With this cost, we here at SMAWL Construction, we have a large commitment to quality as our main focus. We want everything to be documented in Procore. Everything that we do, we want to have cost transparency. Every choice that we make, we want to bring value to this project. And we want to coordinate with everyone we're working with on this project to make sure we're all on the same page. These are the major cost components. You can see the lab space does take up a majority of our budget. This includes the excavation costs, bolt-to-block, 2x4s for the framing, and the truss, and the waterproofing and other costs as well. The next highest, of course, is the horizontal section. This includes the concrete slabs, the structural steel, modular sections, cast in place, and precast concrete. And then finally, the maintenance and observation deck do not have a large part of our budget. However, it is crucial for maintaining the value and usability of our project site. Next is key savings. We work very hard to find other ways we could save money on this project without causing detriment to our safety and durability standards. To do this, we will reuse and recycle as many materials as possible. This includes the bolt-to-block we already have on site, as well as the spoil we have from our excavation we'll be using to grade the horizontal section of our project to the way we want it. Next, we have prefabrication. You can see in the picture on the left is the prefabricated concrete sections. Those will be completed off-site in order to save time, as well as make it safer so we're not working all on site at the same time. And of course, value engineering. Every decision we make, we look through a lens of value engineering, making sure we're able to save money in ways that will add value to our project as well.
So now for an overview for the project schedule. So starting off, we have this project starting on January 15th with the safety orientation I discussed earlier, and ending on April 16th, 2026. This is built entirely in Microsoft Project, as I'm going to explore the Gantt charts from that in a little bit. The main thing with this is we have 4 concurrent work packages, as kind of in with the budget. And these are all going to be working in parallel, but the critical path will be the vertical construction, so the lab building. So that is something that we're going to put the most emphasis into, and possibly moving that forward even more. We'll also be implementing safety and quality control, specifically through the observation deck team. That will be filling out reports on this, and kind of be the eyes, all seeing eyes that can see everything, as well as the management team will be assisting with that. Starting next year, we will also implement foremen to lead each team based off who has skills in what places. So starting off with the vertical construction, for this right now, we're proposing kind of a 10-person team. For milestones, we want to start on the 22nd of January with that. But I will say one major thing we've been discussing recently is possibly moving that to be even earlier, just because, as you guys know, in Indiana and working in January, there is definitely going to be a risk of frozen ground and snow loads. So that's definitely something that we're going to be flexible on, and something we'll be working with the key operator and the owner for. We're going to be ending this on April 16, 2026. So for the horizontal construction, this is something where we also want a 10-person team. This is the second most critical part of the project, though it will have 2 weeks to float, which gives us some flexibility with that. We have this starting on January 22nd and ending, on April 2nd, 2026. With the observation deck, not to be confused with the observation deck safety team, these are the people that can be expanding the observation deck itself. For this, we're looking to have a 5-person team starting on January 22nd and ending on February 26th. For maintenance and support, so we're going to have the actual observation deck safety team, and this will be a team of rotating people, so different people every week. We're working with that. It's going to be a 5-person team. So they're primarily going to be on the observation deck, actually seeing everything, but on days where there might be some obstruction to that, they can also rotate, and they will be going up to each individual work site in the project. We're also going to have a 5-person team for maintenance. That's going to finish on February 28th. So another thing that's giving us a lot of flexibility with the schedule. So for our weekly rhythm and cross training, so on Tuesdays, starting next year, we're going to start us management team. We're going to give a 25-minute reflection, as well as the team from the observation deck, about things to look out for, things we can do better on, safety points, quality points, production points. We're also going to have a 25-minute look ahead planning, so forecasting not only what's going to happen that Thursday, but some general things to look for in the following Thursdays for the actual field work, as well as owner-instructor coordination, things that the owner wants us to do better and is related to us. On Thursdays, these will be the actual work days, starting at 10:30 a.m. with the toolbox talk and safety review, led by me. In general, this is going to be the field work following the Gantt chart sequence. This will be assisted by quality control and documentation. For rotations, kind of as I discussed earlier, will be 1 per week assigned to the observation deck team. It's going to be rotating every week, talking about safety, quality, and getting done. So with this project, although we are going to have morning safety moments, we definitely want to hit home with safety, and that's something we can't compromise on. So that's why we're going to have 3 more formal safety reviews, where we spend more time actually discussing safety and things that we've seen as managers, the observation deck team has seen, as well as the owner. So that's going to be on February 5th, March 5th, and April 16th to finish it off, as well as assisted by quality control uploads from the observation deck team, as well as assisted by the management team, and the weekly toolbox talks. So for contingency and recovery, because we are working in the winter to spring months, there are definitely likely going to be some days that we may have to miss because of heavy snow or very low temperatures. And that's definitely something we want to take into account for. So because of that, we've built in 2 weather makeup days into the schedule. There's nothing special about these Saturdays in particular, and that's going to be something next year we're going to work out with the owner to find specifically what Saturdays we want to use for weather recovery days. But even then, it's something we definitely want to be thinking about now, because there is going to be a large risk of weather delays. But the good news is that because we do have parallel work packages, this is going to reduce single point delays. And even though the critical path is going to take till April 16th, we have the flexibility with the other projects. Additionally, the prefabrication, something we're still exploring and we're going to build into the project. That's going to help alleviate these weather delays by possibly being able to do work off the site in a controlled environment. We will also look into having Tuesday windows available for accelerated work if we need it. That's all.
And using Luke's schedule that he developed, we did a 4D simulation. Here we see our roadway being constructed as well as our observation deck addition. And then the wood portions of the roadway, as well as the 3D printed section getting started, and lab space on the left. I'll get us more detail on the lab space in the next video without the existing conditions there. Here you can see, first we're going to pour the slab on the left, there you go. And then shortly after, with the concurrent work, the bolt block walls will come up as well as the ladder in there. And then we'll do the floor joist and the floor sheathing, as well as starting to frame the walls, the truss system, the roofing, and ultimately some of the more finishing details such as the systems work as well as the door and window. Exotown utilization. I know you guys have used the AR before, and previous groups have implemented it. We have not actually done it, but we have had many considerations for doing it in the future, so both our owner and our laborers can see where everything is meant to go. The given model was not accurate for actual conditions. So we had to make edits to the Revit model to make sure everything is where it's supposed to be, so then our model would be ultimately accurate for existing conditions, as you can see here.
Next is our management plan. We know that working with some untrained individuals, we need a strong management plan in order to make sure our project gets done on time and with our quality. This involves clear communication between everyone on site. This includes construction personnel, owners, as well as architects, and everyone who has a stake in this project. We will be using lean strategies, which Joey will go into more detail on, as well as collaboration, again, working with them through Procore and in person, making sure everyone's on the same page with everything that we do. And additionally, we have risk analysis, looking ahead to make sure we have no risks that we're unable to avoid, and then analyzing ways we can get away with that. This collaboration and communication includes daily huddles every Thursday, making sure we have our daily tasks, and assigning tasks to everyone on site, making sure they know what they're doing. We also have weekly planning and OAC meetings, working with the owner architect, making sure we're looking ahead and making sure we know that we're on pace for getting everything done on time. And of course, Procore documentation. Both of these meetings will be documented in Procore so we can look back and see what we've covered and what is looking ahead. Planning and site management. We have a four-phase design flow, including brainstorming, designing, reviewing that design, as well as finalizing our plan. Also, early procurement. We were looking ahead immediately after awarding the projects, looking ahead to see what materials have long lead times and ordering them to make sure they're on site in time for installation. Risk logging management. We want to, again, look ahead to risks and being able to identify ways to avoid those. And then going on to site management, scheduling and quality, again, using lean strategies to provide value to the owner and everyone who has a stake in this project. And then CPM scheduling, providing weekly look-aheads to make sure we're hitting all of our milestones. And then a three-phase QA QC. Once work is being completed, we have a pre-punch while work is being done, CM punch conducted by us to make sure every finalized work is meeting our heights of quality, and then we'll have an owner punch where owners will come in and make sure it meets their standards as well.
Some value propositions we're going to bring to the table throughout this project are the use of lean construction, our process for 3D printed alternate concrete, and all alternative lab design that we'll get to here in a sec. To start, for lean construction, some lean principles are just looking to overall maximize the efficiency in the flow of a job site. This comes in many ways, such as on-time delivery and just keeping a job site clean. Some objectives we're going to have are to make sure we're doing weekly pull plans, so we're fully thinking through each scheduling part of the job, and we're identifying areas of risk and areas we potentially aren't thinking of. We also take advantage of 5S, which is sort, set in order, shine, standardize, and sustain, along with just-in-time delivery to overall declutter the job site and allow for more efficient productivity numbers. We will also be taking advantage of root cause analysis. In case of a problem occurring or an accident, we'll be able to use root cause analysis to break down every part of what caused it and be able to prevent it from happening again in the future. This only isn't used for negative reasons. This also could be a positive for different work tasks. If one activity is producing better productivity than other areas, we can do a root cause analysis and find what exactly is causing the increase in productivity and apply it to other work areas. And lastly, we'll be using tap phasing, which is different time, splitting the job into different equal time intervals and being able to fully think through the scheduling process and having more efficient workflow. Now Casper will tell us about our 3D printed concrete alternate.
So with the 3D printed concrete alternate, we have some direct impacts that will have towards our projects, with some of our big ones being reduced material costs and shortening our schedule due to lack of formwork. This is that we don't have to deal with the cost of formwork, as well as the installation and the removal of said formwork. And with our design that we have, with the constructability of curved edges, it's more difficult, especially with untrained workforce to create these curved edges with traditional formwork. So by utilizing the 3D printed concrete that we have here at Purdue, we can get these very unique designs that we feel is very special to our project. But I believe one of our biggest things is safety. Like I said, we have an untrained workforce, and we don't want to put them in vulnerable positions. And with our site, it's not a very big site, so if we can make sure there's less people on site that can collide with each other, it can reduce the amount of injuries that can happen and prevent any sort of causes that could happen. But some potential risks that we have here is with the concrete is some finishing durability with it, and our thermal and moisture movement. With it being in Indiana, we experience freezing and thawing conditions, and with the weather, so it causes the concrete to compress and expand. So to try and prevent this from happening as much, we will put waterproof ceiling, as well as try to make sure there's more ways to let out the water inside of this design to not allow these aspects to happen. And then supply, with the design of our 3D printed concrete, it utilizes a different mix compared to the other concretes that we use on site. So some risk that can happen is if we print and it causes a failure, we will need more supply. But to prevent this, we have accounted for this more supply in our budget by implementing more mixed bags just in case of these events happening. But to go more in detail into our attack planning, first we will finalize the design aspect of it and make sure it meets our owner's requirements using for the quality assurance aspect of it. Then we will go on to the off-site printing, where we will print this in different phases, as we can't just print straight 3 feet of concrete without it collapsing with the designs that we have. So then we will go into the curing aspect. We will allow it to cure and make sure that there's no cracks before we transport it onto site and make sure there's good quality control. Then we will finally transport the site and prepare the site to finalize putting it in, and then we will finish it by setting it, reinforcing it, and then applying it and connecting it to our existing roadway.
Moving on to our lab alternative design. Like I said earlier, we want to bring value to this project. We constantly look for ways to bring value from our team and where we can separate ourselves from other firms. Doing this, we've had a design mindset of not only looking to fulfill the scope and meet all the requirements the owner wants, but actively looking for ways to value engineer innovative solutions that ultimately reduce risk, reduce costs, reduce schedule time, and keep everyone safe on the job site. Leading into this, where we have our actual lab alternative design, we're proposing a 20 by 20 pole barn design that is 1 story. We believe that these hits all these previous factors discussed, and not only is it cost effective, saving approximately $1,700 compared to our proposed design, it additionally reduces risk significantly. Like I said before, the lab building is known to be our biggest risk on this project. We all are students here. With that being said, if we go past May, I can't keep all 40 students here. I'm going to have some very unhappy classmates. Additionally, with that being said, safety is one of our key focuses. One of my favorite things about our major is having a smaller class, and I'm proud to say that every single student in our major is my friend and all of our friends, and we don't want anything to happen. We want to keep each other safe. Additionally, it's going to shrink down the total cost and schedule like previously noted. It also better suits the overall operations of the job site. Having a 20 by 20 footprint will allow for more ample working space and declutter the working area, better suited for CNE operations. And then, once again, safety is always our first thought. We want to keep everyone safe and make sure everyone gets home and they can get out of Purdue without an accident. At Last Call Construction, we like to say our company motto is we aim to be the first and last call our clients need to make to bring their vision to life. With that being said, I really appreciate all you guys coming out here today, taking time out of your busy lives to hear our hard work proposal and everyone here. We truly believe we are confident enough to put the time in and create an effective design, but also be able to manage it and take advantage of the 40 workers that we have to get you guys a product that you guys are proud of and that we're proud of to say we built that. Thank you guys so much. If you need to contact us, here's some information. We additionally have some business cards we're going to pass out to you guys, and you can reach out to us in the future, and the floor will be open for questions as well. Thank you.
Thank you.
I'm sorry, do you mind repeating that question?
Yeah. So you opted for a ladder design instead of a stair design
Yeah.
for the basement access. Can you talk through that?
Yeah, so initially in the design requirements in SOQ, they mentioned the building being ADA compliant. So we knew that when we designed our stairway, it actually cut out a lot of the space within the basement. And after discussions with the owner, we found that there's no one that needs to be within ADA compliance is going to be accessing the basement, as it's going to be mainly a storage area. So we thought in order to optimize storage and get maximum space, additionally with the working area on the first floor, because there's going to be no stair entrance, there will be a ladder hatch that locks and then opens up. That it will overall provide more working area and more storage area on both floors, while still giving access to some people.
So an extension on that, do you feel that ladder access would work with, facilitating storage in terms of moving equipment and material up and down through that? And what thought and planning have you done in terms of thinking about the carefully outlined structural planning of that floor, but introducing hatch?
Yeah.
Have you looked at that?
Yeah, so earlier on our subfloor design, you could see there was a hatch in the corner. We have mainly designed this project for completion, and we are still going to have to do more information to actually figure out how the hatch is going to fully work. But one of our processes also was looking for how are we going to effectively move material from the first to second floor. Most residential or commercial buildings that are going to be storing material on different floors will actually have an elevator. If we were to install an elevator, that would probably be more cost than our entire building as a whole. So we are looking into ways to actually have almost like a buck hoist design that goes along the rungs of a ladder and that hoists material up, so we could safely move material from floor to floor without having to lift it overhead and keep it in a safe working way. But with that being said, that is definitely something throughout these next weeks of procurement that we're going to have to really get together as a team and fully get an answer for how we're going to do that and the full means and methods behind it. Professor Wider?
Talk to me about the basement area and how you deal with any water intrusion or potential water intrusion coming in from the soil around the foundation. Do you have any kind of footing drainage, or is there a sump available?
Yes, sir. So we are anticipating our design using a permeable membrane waterproofing lining that goes around the slab to reduce seepage from going into the concrete or the bolted block material. But with it being a pre-existing construction site, and after talks with the owner and there being no geotechnical information available, we're going under the current assumption that there is no groundwater condition. But with that being said, we always know that stuff happens and you don't fully know what's underground, so we did look into potential vertical draining and some options that we could potentially apply if that occurs. We do not have specific information of exactly how we're going to apply it and which pump we're going to go with, but we have looked into ways to potentially apply a pump and deal with water if that was going to occur.
Thank you.
Yes, sir? Over.
With the basement excavation and the adjacent horizontal roadway work, did you coordinate that schedule for backfill completion before you can get started on the work that goes up to that?
Yeah, I'm going to pass you over our scheduler, Luke, here.
First of all, that's a very big question because it definitely looks like there's a conflict of interest there. But the good part is, especially with the 2 weeks of flow, we are able to move that till the end so that that area will already be backfilled by the time we get to that. Thank you.
Mr. Owens?
Yeah, this is probably for the scheduler as well. How did you look at leveling your resources across the project? What criteria did you use to do that?
Like in terms of like the actual number of laborers?
Yeah, and the skill training for various time frames during what's going to be needed during your schedule?
Yeah, so I will say, first of all, thank you for the question. And that
And building off of that, we understood that we were going into this with a low-skilled workforce that had never actually completed construction like that. So that being said, we had no historical data to base it off on actually how to allocate our resources. So we as a team decided each week we were going to do a full assessment of where resources needed to be, and that's why we allocated different buckets for larger groups of people and built-in flows to be able to flex people around to where more help is needed. Professor Watt?
Talking about that a little bit. Putting 10 people on vertical portion of your project makes sense, 10 people, but it's a little going to be crowded. Do you predict any problems with crowding and inefficiency associated with crowding the work site with a lot of workers to get the work done?
Yeah, so in order to minimize crowding, as we previously mentioned, declustering the job site is one of our key focuses. We're going to be using on-time delivery to make sure materials aren't in our way and keeping the site clean. Along with that, we have built into our schedule parallel work activities even for the lab building. So some people may be working in the basement, but they may be working, another group of people may be off 50 feet away, framing out the actual stud walls for the area and pre-assembling or pre-cutting away from the site, so we're not having too many people focused in one area where injuries can eventually occur. Thank you, Professor.
So I know you guys said for your safety crew, you're going to have people up on the observation deck. Have you guys looked at the risks of having people up there while you're also building an extension off of it?
Yeah, you guys are going all right at my wheelhouse here. I like this. So we knew when looking at the existing observation deck, there's obviously a barrier around it on top so you can't fall off. Our plan beforehand to be able to use the existing observation deck during construction was to go in a foot in and build another barrier from where the existing one is. So if the end is here, the new barrier is going to be here, so you can't walk off, and then it'll be safe for existing people to be on there. During actual attachment, there's going to be certain periods where we're attaching the new deck that we would like people not to be on there for potential incidents of nails shooting past, just being out of the work area. But we have considered how we're going to safely put up a guideline. Thank you.
To add on to that too, even though I have to kind of following the observation deck safety team, they don't necessarily have to be in the observation deck at all times. So if it is too crowded out there, we'll act more as roamers and going to individual sites in the area.
Bird?
With the observation deck, I know you guys are installing a ladder. First off, where is that ladder going on the site? Like, where does it lead to?
Mm-hmm.
And then how are you going to get, if there is an incident, they need to evacuate from both points, how are they going to then exit the site if, per se, they're trapped in the middle of the track? Are you guys going to build stairs, or is that just free-for-all?
Yeah, that's a great question. What's the point of a safety exit if it leads you into a trapped area? We did thought about that. Currently, there is a horizontal terminus that does create a 360-degree box almost. There are currently stairs. Our ladder is going to lead right out to the south entrance of that, and we're going to put that means they can go around the horizontal terminus as well, but we can provide another stair system that goes over the horizontal terminus that leads you to the second stair that will get you safely out to the break area. Thank you, Burton.
This is for the schedule. I noticed that you have 2 weather makeup days in the middle of winter, one January, one February. What was your decision behind those makeup days in the winter? And if they do get into the spring, are you worried about schedule, like compression?
First of all,
oh yeah, you got it.
So first of all, thank you for the question. And looking back at that, although I did put those in January and February, I think ideally it actually maybe where we want to move them further on to more combat the risk of like weather delays. I'm sorry, can you repeat the last part of your question?
If you do have to move it later, are you worried about schedule compression and running out of time?
That's a good question. I think it's something we'll have to look out for sure. But I think that's where also the Tuesday work sessions that we may have to implement that could be where that could come into place. Ideally, I don't want to have to ask a lot of students to come in on Tuesday as well. But I'd say with the schedule in general,
that as well is our schedule isn't dependent on those 2 makeup days. It's not dry, it's not flowing, the path is not flowing through those 2 makeup days. So that moving those back won't compress the schedule at all. It'll just allow for a little more time, a little more leeway for more activities and have some more flow.
Good job.
We're done? Thank you guys. We appreciate it. Wish we had more time for questions. Enjoy lunch, everyone.
And what it's like to be in. It is funny. The brown on top. Yeah. I'm becoming. No, not for this. I'm sort of James Cole, safety manager. I think most people might already know that. I'm saying it's not. What's your name? It's not 30 minutes, talk for 5 minutes. You can talk for another 2 or 3 minutes.
Oh, because, yeah. Versus other ones, just like they go out and go in there.
They're really only 2.
But we get to mingle and settle. What? We get to like settle and we're just so great. Everybody's just happy. Yeah. Everybody gets a bathroom break, so they're all happy now. I wish she's going to be 2, 3, and the tide keeps going over. I know, mine does too. Like it wants to drift over, my suit coat wants to drift over to the side.
One positive hiring. Alright, not surprised.
For what?
None of that Thank you. My pleasure.
Have you met Maggie yet?
No, oh, wait. I'll meet her afterwards. Or probably before. Oh, yeah.
Smaller than I thought.
We still got 8 minutes? Dude.
See us, alright.
Can we just like go now?
I don't know, bro.
Ooh, that is neon.
That's not the color.
That is not what it was.
There's been something's been done to the hexadecimal. It looks very wow. Look at the projector light. It didn't look like that on our slideshow.
We've added it to the setup for
I think it's pretty clear when it's not supposed to be that,
Okay, so why are these letters marked? Explain that. What?
Did we make those letters?
I don't know which letters. We got a clicker, we don't need to do
Not right.
Nice. You've been targeted.
What?
Look on your chest.
Hey! No.
No, because I'll probably go through his glasses and like blind you. Look at your shirt.
It's super. That's why you're not supposed to do it. It kills them.
Do what?
If you try to laser at a helicopter or a plane, it kills everyone.
Oh yeah, definitely.
Keep tagging.
Alright, we're gonna go live in 3.
Keep tagging. No.
We actually have extras.
Somehow.
Figuring out who's worthy of the extra copy. Those glasses are awesome. Well, there's always that fact.
Amen.
These rights are closer. I don't I'd rather
I'm not going to put vision, so.
must be nice.
You actually. That's so lucky, bro. I have -5. And it just gets worse every year.
I don't even know what that means.
-8,
Very
9,
bad.
9, and 10 or something. I don't know.
What?
I think I have like -9 and 10.
You get a 10.
Or 8 and 9, I don't remember.
So last time I did the eye test, I was 2020, so.
Do you want me on that side? Girl pass.
It's gonna go up to 50. Just so you know.
Okay, thank you.
All right. Good to see everybody again. Hopefully the food was good. Appreciate that. Hopefully we had a good dialogue going on. And without further ado, we're going to get the second half of the day started.
Good afternoon, everyone, and thank you for taking time out of your day to be here with us. We are Team Greenbeam, and we will be presenting our proposal for the 2025 Capstone Development Project. I'm Carly, I'm the project manager.
I'm Ben Schultz, I'm the chief estimator.
I'm Grace O'Malley, I'm the scheduler and quality manager.
My name is Jensen Long, I will be the safety leader.
I'm Nathan Dutlinger. I'm the project superintendent and design manager. So before we start the design, there are supplemental documents in front of you guys. Feel free to reference them throughout the presentation. They're in order of what we talked about. There's plots and charts for you to reference if they aren't on the slide anymore.
B over to the right, structure C down in the center, and then we have two separate sections of track. We have the west section and the east section. And then our existing structures are the green rectangles. Primarily structure 1.0 and 1.4 are important to remember since they are later referenced. So starting over at structure B will have two levels to it. A ground level, which we designate as level 1, and a basement. Each level will have 200 square feet and will be connected via a wood staircase. We have a peak roof elevation of 564 feet and 11 inches, which is right below that 565 mark, but we will make sure in construction that it stays well below that with a more accurate grade reading during construction. As you can see in the image, we plan on using a bolt-to-block walls for level 1 to keep it consistent with the masonry structure and create a consistent look across the site. The purpose of this is to provide a learning and lab space in addition to possible material storage, depending on the owner's needs at each day. And for learning, we planned on a concrete testing facility down in the basement where our water collection facility will be, since concrete testing requires a fair amount of water, and we figured that would be a good use of that resource. For lighting, we will have ample lighting on both levels via LED lights, and we will have a powered air compressor and sump pump within the structure. So starting with the basement, it will be entirely concrete walls and floor, which will be done by a professional subcontractor. This is because of limited skills of the student workers, the scheduling aspect of it, and just overall safety. Down here, the wood stairs will lead down, and we will have two metal support posts that will be used to support the level 1 floor. And in the northeast corner will be a recess in the floor where a sump pump will be used to efficiently discharge all unwanted water collection. The sump pump has a backup battery within it so that if there's a particularly gloomy month where we run out of solar panel, it will still be able to be powered by itself. Going up to level 1, this will again be open to learning and material storage space. It will have a wood joist substructure and then a plywood flooring on top of it. There will be two openings for an RC hauler, both on the south ends of the east and the west wall, which can be briefly seen here and will be later looked upon further. The air compressor will be located up here so that it is a more bearable noise, because in a concrete basement that echoing will be unbearable for anybody down there. And then there's plenty of room up here for the owner to install equipment or other furniture that they want, including with the basement, so that they can have freedom to design how they want. Going all the way down to structure C, this will be a pavilion-style structure. It will have wood posts with wood trusses on top that support a metal roof. This metal roof will be a continuation of the masonry structure roof to again create a more consistent look across the site. And that's how it will interface with the masonry structure, and then it will just be screwed into the observation deck to create the interface there and add some structural stability. This covers 200 square feet as well, and the purpose of it is to provide cover for students and faculty who want to observe that wood track area, but want to be protected from the elements such as the sun or rain, for instance. And additionally, the lighting beneath the structure will illuminate that area in addition to floodlights, which will illuminate everywhere to the north of it as well. And here's a vertical view of how exactly it will look with relation to the track running below it. And so when we make our way over to the west section of our roadway, so we will have to pour an additional concrete pad that juts out just a little bit from it in order to create our 51 feet of roadway. And this will connect to the northwest corner of the existing wood track and go all the way down to the northwest corner of the masonry structure. Over this 51 feet of roadway, it will have an elevation change of 2 feet
going up to the masonry structure, because this is how it will interface with the shelving units currently in there. We have it go all the way up that way so that it will come out at chest height, and the ergonomics of not having to bend over to load it every time will provide a safer use of the facility. The construction of it will be bolt block siding with a pea gravel filled inside and a concrete track poured on top of that. The concrete track will be 2 feet wide, and you can see in here how it will slope up over the extent of the roadway. The purpose of this track is to connect the masonry structure with the entire track system so that an RC hauler can go from the shelves on the masonry structure and they can reach anywhere on site in one consistent drive without having to be picked up or moved around. This makes moving materials a little easier depending on what materials you're trying to move. Over to our east section. So this section will start in the dimension structure 1.4. This is where the track currently ends and the existing water collection facility is. So we will branch off of this in the structure here, and then once it comes out, it will be more of a sidewalk design. It will be 3 feet 4 inches wide, and will have painted lines similar to those of the state roads, and those will paint a 2-foot wide roadway for the RC hauler to follow. This will have a total of 164 linear feet, and will also complete the 360 directional change as it loops through the structure B. The reason we have it looping through structure B is so another ergonomic reason of students, faculty don't have to bend over to flip the RC hauler around. Instead, they can unload or load it and just send it on its way straight through the holes. In order to get it to come out of the structure 1.4, we will have to make a small little hole in it, but it will be properly braced and continue to have a structurally sound structure. And then like the masonry structure, the purpose of this track is to connect structure B with the rest of the site. And so the top picture here shows a little bit of how it will interface with the existing end of the structure. It will be the same design style as the west section of the roadway. And then the other picture kind of shows our 2-foot by 2-foot hole in structure B, and how the roadway will come up to level with level 1, and the RC hauler will be able to just drive right on through. Moving over to our utilities, so we will expand the electrical system by building off of the existing solar power system. We will add another battery and 2 more solar panels. These will provide ample power to the system and be able to power everything we need, the air compressor, sump pump, all of the lighting that we have, and additional electrical needs that will be done that will go through outlets. For compressed air system, we will have the air compressor housed in structure B, and then the piping will run as that pink line follows, and which will also be how the electrical system runs. At the black dots, which are a little hard to see, at structure B 1.4 in that bottom right corner, there will be low point drains to prevent any freezing in the pipes, which would be pretty bad. And then at structure B 1.4 and C, we will have tying points to where you can actually utilize the air compressor system. For our value add, we will be expanding on the existing water collection system, and as previously mentioned, we will have water collected off the roof of structure B. There will be a pipe that goes directly from the gutter system down into the structure and will feed directly into those previously mentioned barrels that will collect the water. This pipe will have a overcoat fill protection valve to where if we close it, the water we divert is just a standard gutter system. So if we were full in water, it will just run right off rather than overflowing our basement. This will be used for non-potable reasons such as water supplies to our lab and cleaning tools. For lighting, our floodlights on structure C will provide more illumination for the area north of the structure. There is a lot of sloped terrain and tripping hazards in this area, which are an injury risk. So providing more lighting in low light situations will make us a lot safer in the area. And over to our alternative construction. On that southwest corner of the west section of our track, we will replace the 90-degree corner instead with a curved corner. This will reduce costs by $156, but it will add additional man hours outside of the scheduled class times, and it won't be as structurally sound because it is much harder to install, to secure the 3D printed concrete to the concrete base compared to the bolt block. Now Grace is going to talk about our schedule.
Thank you. To ensure a smooth, on-time construction delivery, there are a few things that we will be following. The first of which is our organized work sessions. Tuesdays will be 50-minute sessions dedicated to reflection for improvement and any planning and training to prepare for our Thursday sessions. Thursdays will be 2 hours and 50 minutes dedicated to executing the plans that were developed during Tuesday sessions, and Fridays will be our owners meetings where we will update the owners and answer any of their questions. Second is communication. Consistent, clear, open communication is vital to ensuring everyone is on the same page and knows what work is upcoming. And last is planning for the unforeseeables. Being proactive and building in some cushion, such as contingency in our budget or floating other days into our schedule, can help minimize the negative impacts of any unforeseeable events. When it comes to our construction approach, I'd like to highlight a few things. Again, as Nathan mentioned, the basement concrete work will be subbed out, and we plan to have that scheduled so that it's completed before Greenbeam is on site. And once we are on site, we will have 7 crews of 5 with up to 4 work areas each week, which will allow for simultaneous progress of each structure, as well as minimize people tripping over each other. Throughout the construction phase, I will be managing the schedule by updating it with our superintendent, and I will be providing updates to the owner, like I said. If we find that the schedule is getting behind, we will use our Saturday sessions, which are scheduled for February 7th and March 7th, and we will incentivize those by providing breakfast or lunch during those sessions. And if we feel that after Thursday session, if we feel that schedule should be caught up before either of those dates, we will ask our workers to stay up to an additional hour the following Thursday if their schedules allow. This is our baseline schedule made with Microsoft Project. Again, the basement will be completed prior to Greenbeam mobilizing. Our first work session will be dedicated to safety, orientation, and training. And then the following week, Structure B, the East Roadway and West Roadway will begin. Structure C will begin the week of February 2nd, with wrapping up the week of February 16th. And then Structure B, East Roadway and West Roadway will wrap up the week of March 30th, followed by punch and quality inspections, completion of those punch items, and weather and float days, which puts owner turnover May 4th. I also worked with our superintendent Nathan to develop a 4D BIM model to help us visualize the schedule.
So for those of us who may not have as imaginative a mind from a on-sheet schedule, this provides a better quantity tracking, and over this course you can see how we try to maximize working in 3 locations at once to prevent the overcrowding in a specific area and increase the overall project efficiency. And you can see how Structure C will go up pretty quickly, and the east section of roadway will take quite a bit of time to do because of the sheer size of it. And then we will finish up with the west section track and the trusses and roof on Structure B being our last parts. And then Carly will talk about our management plan.
Thank you, Nathan. I'd like to go over the beginning of the phase that we have just now completed. And during this design phase, Greenbeam submitted 25% design reviews and 50% design reviews to the owner to be able to go over and maintain that we're in a clear, on a clear vision with the owner. These design reviews will allow our team to successfully transition into the construction phase with one consistent and clear vision. As Grace has mentioned, the project delivery work week schedule will look as follows. On Tuesdays, we will have a weekly coordination meeting with the trades. Here we'll be sending out a weekly agenda for them to be able to update to ensure that they have allocated time to address their open items. Before we begin these weekly agenda-based items, we will start with 3 weeks of safety training from our safety lead, Jensen Long. On Thursdays is where we actually carry out the construction portion of the work, and on Fridays, Greenbeam will hold an owners meeting where we'll go over safety updates, schedule updates, financial overviews, and settle any open RFIs or submittals, and also discuss manpower and work hours. How did we decide on our work packages? In working with our schedule coordinator and also our site superintendent, we determined that 4 bid packages were necessary to complete this job efficiently. These will be masonry, concrete, carpentry, and electrical. If a trade is not currently working underneath their particular items, we will allocate them into our general labor category to be able to maximize the site efficiency. We will begin with sending out our RFP in the next coming up days. That will be asking for qualifications, scope of constructability, general labor costs, and also just our compliance agreement. We'll then be doing an internal selection with each other on Greenbeam's team to be able to decide our recommendations. We'll then submit these to the owner for owner of approval. It's important that we openly discuss our selections so that we can identify risk and mitigate it with the owner, as we recognize that some of our trade contractors may have varying levels of experience. We will then hold pre-construction meetings with each of the trades to go over our expectations, and finally we'll have our kickoff meeting, which is the first Tuesday of the upcoming construction schedule. Secondly, our base infrastructure fee will be a more owner-guided process. As we are trade contracting out with an actual industry related, we'd like to have further guidance. In our site logistics plan, in your packets above, you will see the actual site logistics plan we'll be handing out to our trades and delivery drivers. We will ask that all trades carpool and allocate only 2 personal vehicles out on site. We'll have parking for personal vehicles. We'll also have parking for our heavy rented equipment. Furthermore, we will have both potable and non-potable water on site, as well as a 6-yard dumpster for all trades to use and a portalette. How are we going to procure our materials? So, in working with our lead estimator, Ben, we have identified that materials fall into 3 categories. The first is they're already on site. These are materials such as leftover bolted block, some carpentry materials, and all the small tools that we'll be using. These will be inspected and stored properly before use on site. The second is to be picked up by Greenbeam personnel, and the third is to be delivered by the material manufacturer. To support material manufacturer deliveries, we will have flaggers placed at necessary locations along the entrance. We will also guide these delivery drivers into the site, and upon interception, Grace will have them sign a site delivery slip. This is to help with our quality control, ensure that we're checking that all the materials have arrived properly, and that they're going to the right place. I'd now like to pass it on to Grace to discuss this quality control management plan.
So yeah, I worked with Carly to develop a few of our quality checklists, the first of which is our daily quality checklist. These will be filled out by our trades each session to ensure that they have reviewed the necessary information to start their day and have cleaned up their work sessions before they leave for the day. Second is our quality verification checklist. We have provided an example of what those may look like in your supplementary documents. These will be used at the completion of any major items to ensure all standards have been met, such as ADA compliance. And then for punch lists, Greenbeam will be completing internal punch walks and at least 1 punch walk with the owner to ensure all the owner's expectations are met. These will be created and with photos and managed through Procore.
Grace. Now I'd like to touch on our progress tracking. How are we going to track our progress? Ensuring that we have proper document control, making sure they've been received, reviewed, and efficiently returned to those who need it. Our Procore daily logs, we will leverage these to ensure we're tracking manpower, getting a little bit of feedback from our trade contractors, and ensuring we understand where they're at the time. We'd also be leveraging our 40 BIM model out on site. As you guys saw our model before, we'll be developing that a little bit further. And we'll be leveraging this with the Trimble technology, which will access all of our phones, iPads, or computers. However, we will not be using an augmented reality, which is the XR10 headset. As discussing with one of the experts, it can be difficult to bring this equipment out on site due to its ability to be less active in the sun or harsh conditions. We will also make sure that we are talking with our subcontractors out on site, maintaining that clear constant communication that Grace was talking about, and ensuring they're giving us our verbal updates both in the Tuesday meetings and on Thursdays. I'd now like to pass it to Jensen Long for our safety plan.
Hello. Every meeting safety is extremely important to us, and I'd like to outline that through our safety plan.
First of all, I'm going to go over our safety management structure, which centers around me, the safety leader. I will be implementing and enforcing the safety plan as well as coordinating training, and I will be the direct contact to the owner regarding all means safety. I will also be in communication with our project manager, Carly Wilkerson, over integrating safety into our schedule, coordinating weekly meetings, and going over our continuous improvement program. I will then also be talking to Nathan daily about, as Nathan is our main contact with the subs, I will be going over the daily field. He will be going over the daily field oversight with the safety leader and reviewing the activity safety assessment requirements. And he will communicate all the safety expectations that we've outlined on the activity safety assessment to the tradespeople. So how are we going to train our personnel? So I've outlined 3 main training objectives that we need to go over in the first 3 weeks. The first training session will be the carpentry training session, where we will bring a DeWalt representative to train us over various power equipment such as hand saws, table saws, power drills, and those sorts of equipment. We will use these skills that we have learned from the DeWalt representative to build a form that measures 52 by 6 by 8 inches in order for our next module the following week, which will be our concrete training. In our concrete training module, we will hand mix 4 bags of concrete to pour into the form that we made the previous week, and then using that form how would you say? Sorry. What? No. Using the pad that we have poured, we will then put masonry blocks upon that pad in order to train our personnel about how to properly stack bolted block and use that knowledge to have better quality, also with safety. Following those 3 training packages, we will then have toolbox talks every Tuesday. These toolbox talks will be outlined using our activity safety assessment, which we will outline what threats we have for the upcoming week, and then we can use our toolbox talks to effectively counter those safety threats. Our daily procedure will involve me filling out a daily report to identify hazards, and that will be used to compile a weekly safety report to the owner. Before every work session on Thursday, we will have a safety meeting 5 minutes before work begins, where I will outline our current safety hazards, as long as any questions anyone might have. For tracking, I will track attendance through Procore, but using attendance forms, and I will also track our weather and incident reports. Our continuous improvement program is extremely essential to mitigating risk throughout the duration of the project. Our activity safety assessment form will be created prior to any activity on a weekly basis. This will document potential safety risks that we see going through as our schedule changes, and these risks will be compiled into an email that will be sent out on a weekly basis to all personnel. Our corrective action form will be whenever we observe unsafe behaviors or practices on the job site. I will then use the corrective action form to mitigate or delegate tasks to certain individuals to correct any sort of safety violations we see, and then those violations should be resolved within a week, and then they will be verified by me, the safety leader. Our crisis response program has 2 facets, one being for disciplinary and the other being for extreme circumstances. In the case we see disciplinary actions needed for unsafe behavior, the first warning will be a verbal warning by me, the safety leader. The second warning will be a written warning from Carly, our safety manager. And the third and final warning will be a suspension and then a safety meeting or a suspension meeting with the owner. And in severe cases, certain personnel will be suspended by me, the safety leader. In extreme circumstances, such as cold temperatures or warm temperatures, when we have cold or warm temperatures, we will either have mandatory water breaks in warm temperatures, and in very cold temperatures, we will have mandatory heating breaks where personnel can go to their cars and warm up on certain intervals. In the case of severe weather, all severe weather will be tracked by me, the safety leader, to assess if we have a threat for that day and if we need to take certain precautions. In the case of lightning, when thunder is heard, all the work will be shut down and work can only resume 30 minutes after the last lightning or the last thunder heard. And then we have our medical emergency plan, which where we will monitor the ingress and the egress of the site to make sure that medical personnel can quickly and safely enter our site and remove whoever needs medical attention quickly. I'll now pass it on to Ben, who is our financial leader, and he will go over our finances.
Hello. Thank you, Jensen. It feels like introductions were a long time ago, so hey, I'm Ben Schultz, the estimator. Before I get into numbers, which obviously you guys want to hear, I'm gonna leave you hanging for a second and follow on Carly and Grace and Jensen talking about Greenbeam's financial mission and how we implement practices to make sure we're meeting that mission. So Greenbeam's commitment to transparency starts right now, well prior to mobilization, when we walk you through how we develop our budget and the methodology that we use to arrive at all the numbers we do, and continues throughout the project as we develop forecasts that we share with the owner, as we make sure that everything that we're seeing with regard to costing is being built into our work and is being communicated to you guys. Our commitment to responsibility also is seen through those monthly forecasts that we put together, and our commitment to escalating problems that are coming down the cost pipeline preventatively, so making sure that senior leadership is looking at anything that could become a huge cost balloon before it actually does. And all of these practices demonstrate our commitment to financial discipline, which keeps us meeting those first two expectations. All right, so for this semester, fall 2025 consulting fees, we logged all of our work that we had done as a supervisory team on the project up until a week or two ago, like just prior to the final document submission. And then we combined that with projections for the remainder of the semester, so the remainder from 2 weeks ago, so that includes the past couple weeks as well as the rest of November and December. And then we use data from the Bureau of Labor Statistics as well as ARS means and Greenbeam's experience in the industry to figure out these hourly rates for each of the roles and each of the task types that we have been doing as we developed this presentation that you're watching right now, as well as our deliverable from a week ago. And that came out to a total of just under $25,000 for fall 2025 consulting fees. Now for spring 2026 design, management, and labor fees, we have a total of $52,000, just over, for labor directly through Greenbeam, so that's the student workers for the next semester. And that was developed based on an hourly rate pulled from the Bureau of Labor Statistics as well as working with our PM and our schedule manager to figure out the 1 hour Tuesday plus 3 hour Thursday sessions. So those trainings that Jensen was talking about that will be carried out on Tuesdays, so as not to impact work on Thursdays, everyone is going to be tracked as being compensated for that. It's obviously you have to pay your workers to be training them on company time. And then that comes out to a total of just under $105,000. You'll see that owner subcontracted labor number, just under $7K. That is for the subcontracted excavation and pouring of the structure B basement. So that's not priced in with our normal labor because we'll be going through a different route to actually get that contracted. And then finally, for our spring 2026 material and equipment fees, you've got a breakdown by structure, major cost bucket here for each of the numbers. So the biggest one is structure B at just over $9,000, makes sense, 2-story. It's got the most material in it by far out of any of the structures. And then our cheapest is a concrete training. You know, it's a piece of formwork that big, tiny pad Jensen was talking about. $17 for that. And then we've also priced in a credit for the bolted block that is already present on site. That was counted and inspected by our personnel during multiple site visits during this semester. And that comes out to just over $21,000. After you add in the credit for the 3D alternate, it doesn't really change that much. It's just over $21,000. Oh, sorry, Brandon. Can you see that at the bottom there? Okay, cool. I wasn't sure if it's like below the table line. So this cost data comes from Menards, Home Depot, and RS Meetings primarily. There's also one, like for the gravel fill, I took that from a particular vendor's website, but if you look at the very back of your supplementary packet, I don't know who all has them at the moment, you can find a full materials list for each of the structures. So corresponding to each of those buckets, you can find all the materials and equipment used in each. You might notice that some of them, like if we buy like a fastener box and we don't use all of it on structure C, it kind of overlaps into structure B. So you'll see that in a note on the right there, as well as the source for each of them. Yeah, that's a full itemized breakdown. And then coming to this final slide, here's the big number, 150K. So that is just under $25,000 for fall, $105,000 for design, management, and construction next semester, and then just over $21,000 for material and equipment fees next semester. With the alternate, doesn't really change that much. All right. Thank you very much. If you have any questions, we'd love to hear.
Sir in the back corner.
I don't know who wants to take this, but could you kind of walk through what you've come up with for value adds or cost reduction alternatives for this, and, you know, thinking about the big number, don't just focus on materials and the labor as well. I mean, what kind of things could we do different? As an owner, I don't think we got $150,000,
So that $150,000 is more or less a hypothetical number. The actual paid number would be that $21,000.
Well, the question really is about value adds. Maybe what do you have for that?
So value add, we plan on having a sustainability approach of where we will, any wood beams that are 36 inches or longer will be squared off and kept for storage, so we reduce our costs on lumber there rather than buying an 8-foot board for a 2-foot bracing. We'll have plenty of recycled material for that. We plan on using as much recycled material on site, which is the bolt block. There's currently some pea gravel on there that we plan on reusing, and the water barrels as well.
Also, I will note that the labor pricing there that you saw, which was contributing in a major way to the $150,000 as well as the $36,000 supervisory fee, those are worst case scenarios. So assuming that we have to use every single session to its maximum, everyone shows up and is being paid the rate that they would for being there the whole time, working the whole time, it's an absolute worst case scenario number for that big chunk. So if we are able to find productivity savings in the field, or we find that things aren't quite as bad as all of our worst case assumptions, then that number would come down.
Just a follow, any design changes you made to offer an alternative design?
Our only one was really the 3D printing concrete. We could, of course, increase the amount of length that we 3D print to reduce costs, but that would, again, it would increase the amount of time that we spend after class, because there's a lot more prep work that goes with the 3D printing compared to the just laying down bolt block.
The structure of the roof that you're building next to the observation deck, I couldn't tell in some of the renderings, is it, which way does the roof slope? Is it both ways, one way?
Down south.
It just slopes down to the south, yes. So
it's 6 monotresses.
Okay.
Yeah. So it slopes, continues the same
slope of the current.
Yes.
Okay.
And so it slopes to the south, which is, there's just a grassy area back there, and we will likely extend, there's a gutter system currently on the masonry structure that we will extend over and just continue that.
Yeah, something sort of connects to this idea of design efficiency. I was wondering if you could speak to the approach of having the sort of central structural line in the basement to support the flooring on structural beam with the 2 columns, and the what appears to be cast in place concrete wall right next to the stairs. Mm-hmm. Having both those there, or how that combination is existing relative to efficient design and construction. So what was driving that composition?
So our reasoning for that was obviously the section of joists that would go from that support wall in the middle to the end are fine, but it's just that 4-foot section on either end of that wall that stretch of 10 feet is a little too much. So we planned on just having the support posts be equally spaced and just add a little bit more in the areas that it really needs it, and then consequently just having continuing it through, which will.
What is the overall width dimension? I don't believe I got that in.
It's a 10-foot wide structure, 20 foot long.
Okay.
So the joist would be spanning 10 feet.
The 2x2 opening that you've got in structure B, have y'all taken just constructability from a structural standpoint with the bolt block into consideration there, and then any thoughts about infiltration from a weather or critter standpoint?
Yeah, so we will have metal, just metal panels that will line that wall, line that interior, provide structural stability, and we were kind of going off the same concept of how the existing entrance to structure 1.4 is. That's currently open, but we could always add in flaps or something like that to create a little bit more of a weather sealant to the entrance, depending on how stuff ends up turning out.
Also, just to touch on constructability, a scenario like this is covered like very explicitly in the bolt block design manual, so or like installation manual. So yeah. They're like parts manufactured specifically for it.
So dealing with water in two places. First, around the excavation and the footing, does your sump pump, is it collecting foundation water? I think it was slide. Is it collecting foundation water, or is it only collecting water off of your gutter system?
So the sump pump would be just collecting any water that accumulates like on top of the floor, and so we like squeegee it into the corner and for that. So if there's major spills during the water collection or like water trapped in.
So you have no worry about any water around the foundation.
Maybe we should have.
Okay, and then your water shut off of the gutter to deal with overflow. Is the valve or whatever you called it shut off sufficiently protected from freeze up so that you don't end up destroying this one? Don't end up destroying the diverter due to freeze thaw.
That's a
great question.
Very good thing that we would expand in our design and make sure that we account for that.
Okay, thank you.
How did you arrive at the $6,862 budget for your subcontractor?
That's a combination of labor pricing from, it's all the way. Sorry. Labor pricing from RS means based on the volume that we want to excavate and then exactly the volume of concrete that we want to pour. So it has like 5 cubic foot, 5 cubic yard, just exactly that number.
Is that a cost number or is that a market number?
That's a cost number. We have a markup on top of it.
Okay.
For your existing watershed that you're connecting the existing track to your new track from, where you're gonna demo that one section built from that shed, what is the elevation change there? Because I remember having to take a step up, and does it meet your max slope? Or are you concerned about any like tripping hazards when you build that into your next section?
Yeah, so it fell, I believe it fell within the max slope. If on site turns out it doesn't, we can always demo a bit of that and just start the slope further back. And with tripping, we have it, there's a step to it. We plan on, as soon as it reaches that outer wall of it being level with the existing concrete pad and then sloping down. So there'll be a couple inch elevation rise there, but we can properly flag that off and mark it with orange spray paint so that it's not as much of a tripping hazard.
And when we notice that there is a tripping hazard, we will note that in our activity safety assessment and properly mark that out.
So for your basement, obviously that's a very large scope of work that you guys are planning to have done before you start, mass excavation versus, the site
off-site session is safety. There is a little bit of wiggle room. And again, there's also weather and float days built into our schedule.
With that being done, with the general labor group as well, we can allocate the groups that were supposed to be starting on top of the flooring, say the carpentry, into the general labor groups. We can have them doing other site items that will need to be done as well. Just having that extra category allows that site efficiency.
Yes. So I know your guys' building kind of butts right up to that maximum height clearance. Do you guys have a plan? Like, should you guys get to the top of that building and be like over an inch over? Do you have a plan on how you're gonna kind of take the steps backwards to get that building below the maximum height?
When we start with the subcontractor, starting with the basement, we will go and check and get proper grading done, so we ensure that the subcontractor starts at an elevation where we will be well clear of that maximum. And then if we get up to that roof portion and realize we're really close on that, we can always go and redesign the roof to have less of a pitch, but still enough for rainwater and it to be a safe roof. And we currently have two 2x6s stacked on top of the bolted block to provide a little bit of bump up on the trusses. We can remove one of those and alter our securing method between the blocks and the trusses.
Yes. Two design questions. The first, what's your intended purpose of structure C? It kind of just seems like it's there to meet a requirement and not a deeper.
That was Governor argument. It provides illumination for the existing track there. Because when it's dark out there, or God forbid, like foggy or something, it's just a huge choking hazard.
So
Like
that
spaghetti of wood.
illuminating that entire structure from last year, or was it just that specific section?
It will illuminate like all the tracks to the north here, like everything up that way. We kind of feel like being powerful enough to illuminate all that.
And what about the part north of the existing structure?
We can add lights onto that as well, attach them to the outside and just continue that electrical system. And then the structure is also just, it's kind of there, but it's there to provide just another open air source to hang out, especially on work done in future years. In hot weather days, it'll be a great place for students to stop and eat their lunch under some shade while catching the breeze.
And then second part, can you detail the materials of your roadway again?
Yeah, so
They're also in your supplementary.
but so we will, for the west section of the roadway, it will be this bolted block siding along here. Kind of it'll follow the same design as the bolted block track currently out there, and we will have a pea gravel or another sub base that will just form up to the height, and we will pour. For the west section, we'll be hand pouring concrete for that actual roadway that the RC Harlem was on.
Is there any structural steel component?
The structural steel that comes with the bolted block is what we consider for our structural steel component in there.
Okay, so I'm not sure how much you learned from Cassidy from 2 years ago on their bold block roadway. Have you thought about the unsupported horizontal length of that roadway when you filled it all in with pea gravel?
You did the calculations on that, right?
Yeah, based on the
Could you think it's constructability? Oh, okay.
It was anchored into the ground properly.
Okay, all right.
Yeah, our foundation is probably deep enough.
Yeah, the both block tracks have, I don't remember the exact depth it goes, but it goes in a fair amount and should be able to withstand the load of the gravel horizontally.
Yeah.
Okay.
Those dimensions, I don't have them off the top of my head, but those dimensions are in the install manual, and it's what we based the design on.
So your guys' other track, I don't know if I missed it, is that just concrete that's gonna go down on the ground?
Yes, it'll model a sidewalk.
Okay, so
that way we can fit our ADA standards.
do you guys have kind of a plan for a sub base so that you can
You do?
Yeah.
What is the-
I believe your grab will include a materials list
Yeah.
to have so we'll have some slight excavation to go down a bit, and then we'll pour gravel in there and have it compacted for a proper subbase rather than just pouring on loose earth.
Yeah.
Also making sure it's level with our general labor group before and stuff like that.
Schedule question. What was the critical path of the schedule, and what was the near critical path?
I can't list it off the top of my head,
Okay.
but that is our.
Which is the thing that's taking the longest to complete?
I believe that'd be structure B. Yeah.
Structure B masonry specifically.
We start with structure B, and the roof of structure B will be the last thing that we put on.
One last question for Ben. So your cost for the foundation was estimated with RS means or whatever, or did you get a firm price from a local contractor?
No, all of it is our estimates of the labor and the material for all of that. We talked with Brandon about the process for selecting an actual subcontractor, and he didn't want us going out for pricing, like contacting anyone in the industry about this beforehand. Because you know, we're like asking them, and then it's like, do we get selected, or is this a real project that's getting built? So that's not actual quoted pricing, but it is really
So is that your risk matrix of what happens if that number is a little bit higher? Or
yeah, there's
higher?
I mean, I don't think I would say this in like an actual owners meeting, but there's like a little secret contingency in there.
Secret contingency.
Secret contingency.
Always just see us.
Yes.
So, for where you guys are tying in your new roadway to the existing wooden roadway, are you planning on just flooding up into it, or are you gonna actually, like, connect it in some way? I don't know if maybe you touched on that, I missed it, but.
Like inside the structure 1.4, or the east section.
The west section.
Like the bolt up to the left.
Yes,
the
or are
wood.
you guys just gonna butt them up, or are you gonna actually attach them in some way to ensure that there's no movement between those two pieces?
Well, we have, I know what this is.
Okay. It'll most likely be, we plan on just butting right up against, and we will have like a rubber, some flexible element put on top of that, so that any flex between the two doesn't affect it, and the RC hauler can go over it. The RC hauler has pretty large wheels, so we're not too worried about it being affected by small differences in elevation.
Time's up. Thank you.
You did it.
Oh my God.
Alright, we'll go live in about 3 minutes. Ready to go. Cap, you're up.
Good afternoon. This is Cap Construction's Capstone Development Project. My name is Harley Gamp, and I'm the Project and Safety Coordinator.
I'm Daniel Herrick, and I'm the Senior Superintendent.
I'm Cole Shipley, I'm the lead estimator and scheduler.
I'm Payne Folk, and I'm the Design Integration Manager.
I'm the SMAWL, and I'm the Superintendent. Let's get into the history and the project overview. In January 2024, the class began with a clean slate. Nothing going on, just a concrete pad, 2 storage units, and an observation deck. Forwarding to the end of the year at April 2024, you can see a horizontal, complex structure that's being poured for concrete. They also added a watershed unit with roofing on these storage units. The year after started with a concrete pad that's covered with a tarp, as you can see right in the laser. You can see it's covered up for weather conditioning. Towards the end of their year, they added a horizontal structure that's made out of wood with 2 360 systems. They also finished up past year's work with wood just because it's probably cost, and they added a vertical structure right there with a steel roofing system. This is our year's project. This is our Revit file, and you can see everything that Payne will go into further detail later on. These are the callouts of what we're investing in this project. On the A side, you see the old year's project with our structure C, that's going to be 1 story high, structure B, that's 2 stories, and all the different colors entail the horizontal structure that Daniel will be touching up upon. It's in the green, yellow, orange, and blue slide. Payne Folk will be going over this video that brings it more in depth.
This walkthrough shows us facing south, and as it goes through the walkthrough, it's going to go to the west here, and you're going to see the start of where our horizontal begins. Our horizontal will go off the back side here, and this is where you'll see structure C here, where we are building a lab that we'll touch on later. Use the existing road to come back out on the other side. You'll see structure B there. You won't see the basement that we have that will be involved in that. However, you'll also see the concrete sidewalk around it that is actually part of our road. And you'll see a roundabout for future expansion, and we will detail that later.
Before we get into all the specific project details, we're going to talk about what drives every decision we make on our job sites: safety. Before any work starts on site, we will complete a 30-minute site-specific orientation to all trade personnel. This will be a more detailed look at what I am discussing here today. After this, all personnel will then must be required to pass a site-specific safety quiz to ensure eligibility that they can work on site. Moving on, culture is what drives all of our identity that we remind ourselves about and our core values: commitment, adaptability, and purpose. We are committed to our safety and quality of work, as we are all OSHA 30 certified, which means an even more commitment that we have for safety. We are adaptable with always the changing weather and the project conditions, and we are purposeful in everything that we commit for our community and our people. This is where the site-specific orientation is. Moving on, when we do get on site, we will have a morning meeting. Those morning meetings will discuss the daily work that all personnel will be doing that day, PPE requirements, key safety focus areas, and ensure that every person, whether they're on site, our trade personnel, or visitors, understand PPE, so we will have this poster posted around on site. Also, with those morning meetings, we will go through job hazard analysis for all of our trade partners and our foremans to identify and reduce risk. To wrap up our morning meeting, we will have a stretch and flex session to reduce fitness and morality and boost that. With this, we will have this poster posted on site so that anyone, all of our personnel and visitors, again, will be able to understand all the stretches that we'll be going through and be able to participate in our stretch and flex. Moving on, we want to ensure that everyone takes their own action and on site, so we do have a proactive safety program. This QR code is live and active if you would like to scan it. When you do scan it, it is going to take you to what our CAP hazards form is. On this form, when someone on site would see a hazard, and we don't want it to become an accident, they would scan the QR code and it would take them to this so they can submit their name, the date, if it was a good catch or near miss, a description of the event, the corrective action, whether they took that action right then and there so that it did not become an accident, or if the management team still needs to handle this, and then the people involved in the event. This, once the form is submitted, it will go directly to the management team, so if it hasn't been handled, we can then handle it right then and there. This promotes a proactive culture so that everyone on site is aware of their surroundings and safety, so that safety is not just a program and something we can check off a list, it becomes an everyday mindset that we want everyone on site to have. Moving on, we will have a cloud-based safety network that we will track all of our training, PPE usage, our safety audits, and our CAP hazard reports. We will also have routine safety audits to verify equipment conditions and also just to verify PPE usage again. CAP is an industry-leading standard with our experience modification rate of 0.75, and we are also striving for 0.7, while also maintaining a 0% accident rate to ensure S-Bright stays accident-free. We will also look at safety effectiveness through key performance indicators, and those will be managed by this equation right here. Finally, we will have weekly safety updates with the owner and our owner meeting and the management team.
Moving on to management plan. Communication is a big part of any project. And so in order to go about that, we're committed to talking with the owner as we go along in a weekly meeting. We'll have a single point of contact, and that'll be myself, the design integration manager. However, if something happens, I'm sick, not available, we do have contingency plans. Daniel being the second one involved, and he'll be at every meeting, however, he just won't be the main point of contact. And if one of us can't fulfill our duties, Harley will step in and take over as well. So we want to make sure that we're clean cut on our communication with the owner. Within our internal team, we have our own communication lines. The main things I want to point out here is we have a superintendent down here in Bassam, and he will be mainly field focused. So as the senior superintendent will look at the management side and us, they'll be specifically looking at the field and working with the laborers out there. The other thing I want to bring up is that we will be looking to hire a subject matter expert in BDC. We had great work from our senior superintendent doing this. However, in order for us to provide a great product, we want to make sure that we have a BDC manager that is experienced in that field. Going on to our trade partners. Our trade partners, we're going to have about 35 of them. The superintendents will overlook most of their work. And we have 4 work packages that they're going to get involved in. And down at the bottom, you'll see some of the skills or experiences that they're going to get within those work packages. You'll see power tools is through all of them because at the end of the day, we all need to know how to use those, and that will allow us to cross-train and allow others to be in other areas because we'll need to move some of our workers over to B when we work on B. In order to get them into these work packages and teams, the main thing here is we're going to invite them to bid, and they're going to bid their technical and soft skills so that we can get them involved in areas that they want to be involved in, as well as we want to make sure that the leaders of those groups have a firm foundation in that type of work and skills. When we get all that information, we'll work with the owners to provide the best teams to work together on this project. Going into our site plan, develop this to mitigate risk when traveling around and traffic flow, MOT. So you'll see parking at the top. That's going to be away from the project and everything so that when cars are coming in, easy to go, and then you can cross over once you have your PPE on and everything. The main thing here is the flow of traffic, as that will be where all deliveries come in, and depending on where we need the delivery, we have our 3 laydowns in the green. We call out A, C, and B, which is a little bit different from what we were given when we originally have, so that we have specific areas to call out when we get out there. As there's not as much work going on in C, and so it's labeled C so that we have an area to call out, whereas what we originally got, we don't have it called out. And then we have lunch and break areas so that you can get away from the work, kind of get away when it's break time, and then you have your lunch space so that it's just away from all the work and we're safe there. Risk mitigation. We've identified 5 main categories of risk, and for each risk that we come up with, we're going to go through each category, select what category might be a part of, go through the likelihood of it happening, and then also the consequences that may happen, and then some of the mitigation ideas, although they're not limited to that. So this is just a matrix to allow us to kind of think through our risk as we see them come up. We can always add to the risk categories. The communication completion is an important part of our project because we want to provide a great product to the owner with creative ideas. So through 25 to 100% completion within construction, we will communicate through Procore on shop drawings and RFIs and things of that nature so that they are aware, trade partners and owners, of what's going on. In order to get to completion, when we get close to it, we're going to work on as-builds, punch lists, and the closeout. The as-builds are important so that we can turn this over to the owner at the end of the day and have a great product that they can work together on with the future of the students here. The punch list will happen with trade partners and with the owner. The trade partners will happen as they go through the work, and then with the owner will be the final step in being able to turn this over and what they see we need to finish up before we turn it over. And then the closeout, cleanup, housekeeping, and then just overall turnover. So getting into design, this is where the meat of our presentation is going to be and where our main idea comes from. So we're going to look at the vertical construction overall. Within the vertical construction, we highlighted this segment of the RFP talking about the fact that he wants a fully functioning lab. Well, when we were looking at that and we're kind of looking at what's going to happen at BU, which we'll touch on later, is the risk that goes with building that and getting a lab to the owner. So we talked to the owner out in the field, talking through some of the stuff, and we talked through what the purpose of B was and the purpose of C. So at the end of the day, we came up to the owner and was like, hey, got it approved of, let's make the structure at B the building to supplement the construction engineering temporary structures course, which was actually mentioned in past RFPs. Down here at the bottom, what to insert for structure C, we are now turning structure C into our student lab. And so we essentially flip-flop that in order to provide this. What this provides, first off, we wanted a centralized location for the student lab because there's storage and there's connexes above, and you got the storage unit, the existing masonry on the left, which you can see on the papers in front of you. It maximizes the current concrete pad so we don't have to deal with creating another one for the lab, and at the end of the day, we'll provide the student lab completed on time. The benefits for students. You got 2 categories here. You got the current students and you got future students. When looking at the current students, the main thing here is that current concrete slab that's there is sloped. as from the field calculations and surveying, we found that it was uneven topography of about 6%, so we have to understand some means and methods and dowel and pour some concrete to get that thing leveled out. And then we'll get to the practice layout and formwork procedures. Future students, because it's a temporary structures building, will be able to put in permanent visuals for underpinning and formwork, demonstrations for dewatering, and potential for lifting and rigging simulations, just as a supplement to what's going on in our classroom in 455. When you talk about what impacts that has on cost, schedule, and risk, the cost, we're going to end up having to demo out some of the existing road. We're going to save about $305, and we'll actually be able to use that wood somewhere else, that timber. Schedule impact, there's really no schedule impact. It's mainly moving that student lab to an area of less risk and providing that on time. Risk impact, there's several different ones that are listed here. The unforeseen subsurface conditions at B are one of the big deals in part of the excavation that may cause issues. So we're going to eliminate that from the student lab portion, and however, it's still going to be at B, and then we're going to introduce like concrete cutting hazards, demolition going on, things of that nature that we are aware of. Now going into structure B, Daniel will go through the structures.
Thanks, David. So starting off with structure B, which is the most critical to our project, it will be located in the northeast corner of the map. When considering structure B, the two main things that we would consider from the RFP were the fact that it needs to be A, a two-story structure, and B, have an elevation max of 565. The first thing that we wanted to do was go out there and check the current conditions. To do this, we used a site level, and we got a ground elevation of about 555.6 feet. With this information, we realized that we only had about 9 feet 4 inches of usable room above the ground, which means, according to any building code, we cannot fit a two-story structure in this space, which we ultimately decided to create a basement. Once we determined that we needed to excavate, something that we had to do was on-site testing. There was no geotech report given at the time, and we wanted to ensure safety, so we decided to do a pocket penetrometer test. With these two values on our two tests, we determined the soil type to be a type A soil. After speaking with the owner, this does make sense as all this soil was brought in on site and compacted. Here kind of shows our current condition and implementation of how we view the project is going to look. Starting off on the bottom, we are going to have 8 inches of compacted stone, followed by an 8-inch concrete pad, 8 feet for the basement, 7 foot for the first floor, and then a roof pitch of 1.5 inches to 12 inches. This brings our total height to around 18 feet, 2.25 inches, and our max elevation will be 564.5 feet, which gives us about 6 inches of play from the max that it can be. Moving on to the excavation itself, it is going to be a 16 by 20 foot area. We are going to slope the dirt at a 1-to-1 ratio. As I said earlier, we classified it as a type A soil, but to be safe, we're going to classify it as a type B. According to OSHA regulations, a 1-to-1 ratio slope fits all safety protocols and is fine to do. Once the area is excavated out, we are going to compact it with number 53 stone and place a sump in the northwest corner for water collection. Biggest thing to note about the excavation is that this is critical to our schedule, as this will be going on during the pre-con phase. This will hopefully be excavated in early December, as the ground will still not be fully hardened and it should be easier to excavate. I also want to address some of the safety concerns, obviously, with leaving it open for 3 to 4 months. To do this, we are going to place tarp over the area and block off and make sure there's proper signage so no one falls in it. Moving on to the basement is going to be 14 foot by 18 foot. We are going to have an 8-inch concrete slab that is 15 by 19 foot, leaving 6 inches of play on each side. We are going to use bolt block walls for the walls itself, and then we're going to have a wood staircase that leads up to the first floor. Here kind of shows the inside view of the basement with nothing in it on the left, and on the right this shows what we visualize that it could look like. At the end of the day, this is 100% up to the owner, but we do visualize this space to be a temporary structures lab. In the basement, we could show underpinning visualization, tying rebar, using Simon's panels, really whatever the owner wants to do for his CE 473 class. If he doesn't decide to do any of this, you can always just use it as a storage area. Moving up to the first floor is going to be 14 by 18 foot, which is the same size as the basement. The primary purpose is going to be used as a temporary structures lab. We're going to have TJI joists and plywood for the floor. TJI joists are engineered lightweight joists that are able to withstand the weight. And the structure itself will be done in a pole barn style fashion with wood, metal framing, and then insulation on the inside. These show our isometric views. The two biggest things to point out here would be the solar panels on the roof that is going to be used to power the building for all the lighting aspects and the air compressor. And then we also have a garage door, which is shown here, which is a potential value add to the owner. This way, if he ever wants to back out a truck bed or fit bigger material into that space, he has that option to do so. The total cost of building B is around $10,200, and it accounts for 60% of our total budget. Once again, here's the inside view of building B and what we visualize that could be in it. As I mentioned, we are going to put the air compressor on the first floor, and we are also going to use this area for cart storage. This is when the cart is not used, and we want to make sure that it stays working and active. Moving on now to Structure C. Structure C will be located in the southwest corner. Structure C is going to be 10 foot by 17 foot, which matches the existing horizontal, or matches building A that's already there. It is going to be used as a woodworking lab as the primary purpose. When doing our technical proposal, we were talking to the owner about it, and our first idea was to expand the observation deck. He liked this idea, but he also wanted us to be more creative and think of a true purpose for the building, which is why we ultimately decided to submit to ATC. Last thing to mention is that it'll be a pole barn style, similar to B. This will not only help with repetition, but it'll also help with the schedule. And then, one last thing to note would be that we need to level out the existing concrete pad. You can't see it on this photo, but there is a moderate slope right here. So once we get the structure for B formed up, we're going to pour the pad to level it out. Once again, here's an isometric view of building C. The total cost is about $2,750, and it accounts for 16% of our total budget. The last thing to note for Structure C would be the red square that you see there with the opening. This is going to be used for our horizontal structure, as we want the option for the truck to be able to go in and pick up material or do whatever it wants to do in that area. Alright, now we're going to move on to the horizontal sections. The horizontal section is split up into 4 different parts for scheduling purposes, which Cole and I will touch upon later. The total linear footage for the horizontal roadway is 210 feet. Biggest things to highlight are that the primary material will be timber and concrete, and that the south side placement that you see here. Going back to the previous photo, you can see that HRS-1 and HRS-3 are placed on the south side of the masonry building. This is because we wanted to leave proper access and egress in the north for the observation deck and for the existing connexes. We didn't want to be able to block that off or create 50 ramps. Moving on to HRS-1, which will be located in the southwest corner, directly connected to the masonry building at A. HRS-1 is going to be about 35 linear feet, the primary material being timber. We didn't want to overload the weight on the masonry building with our cantilever option, and you may be wondering why we went with the cantilever option. This is because in the grass area that you can see highlighted there, that is actually a ditch, and after talking with the owner, he did not want us to interfere or disturb with the ditch. And we thought that the cantilever method would be an innovative solution that not many students have done. Moving on to HRS-2, which is located on the west side. This is to help connect the existing structure here to building B. HRS-2 is going to be about 30 linear feet with the primary material being timber. We not only wanted to think about the future of our job site, but in upcoming years with other students. We decided to make this area timber, but it can change. We decided to make it timber because of any future work in the south. If equipment ever needs to get in that area, or if they ever need to drive a truck through that area, this area can be easily taken out and removed and be put back in. And then I also wanted to highlight that on the left, it's already wood, so we wanted to keep that existing aesthetic. Finally, I want to talk about the 9% slope that you see here. If any of you have read the long RFQ, the biggest thing was that the slope could not be greater than the maximum of 5%. However, we wanted to test out this theory. To do this, Peyton and I asked the owner, Brandon, if we could borrow the RC truck that will actually be driven on that site, and we wanted to make a makeshift ramp to determine the actual slope that the building could do, or that the truck could do. As you can see in the photo, this looks like a little bit more than 9%. It's actually about 60%. And here's the video of the truck going up and down. As you can see, that clearly did not struggle at all, and we do not see this to be a problem even with bad weather conditions. At the end of the day, that 8% or that 9% slope could change to 5%, whether the owner wants it or not, but we just wanted to propose this idea to him. Now finally, moving on to HRS3, which will be located in the southwest corner as well. This will help connect everything together. It'll help connect the existing building, or the existing roadway to C, it'll connect A to C, and then it'll connect C back to the existing structure. HRS3 is 25 linear feet, with the primary material being timber, and the reason why this is third on our schedule is that HRS3 cannot be complete until the framework and structure of C is most of the way done. Finally, we got the fun one, HRS4. HRS4 is located in the northeast corner. This will be about 120 linear feet, with the primary material being concrete. Starting from left to right, you can see building off HRS2 is going to be 2 foot wide. Then once it reaches the roundabout, it's going to expand out into a 4 foot wide sidewalk that encompasses in 360 building B. We decided to do this for maintenance purposes and for bad weather. If there ever needs to do work onto the building, you have a clear, strong walkway that you can do, and you're not walking through muddy soil or grass. Last thing to highlight would be the roundabout that you can see here. This roundabout is used for future expansion purposes, as if Brandon wants to go on the south, this would be an easy way to connect the roadway. This is also a great opportunity for students to learn how to pour concrete in a circle, because no one really has experience with that. Or we could also 3D print it at the Bowman Laboratory, which is also a good opportunity for students. And then one last thing to mention would be the circle in the middle. We do plan on putting a flagpole here provided by our mentor, Pat McGriff. The total cost for HRS4 will be about $2,750, and it will account for 16% of our total budget. Now I'm going to pass it on to Peyton, who's going to talk about our maintenance program.
Within maintenance, we talked to the owner about what he kind of envisioned for him. We brought him a few ideas, one being the existing masonry on the left side and doing the roof that I've heard about several times today. We have identified with him that there's another area that he was kind of looking at, and it's the water collecting in front of the connexes as it shut down work last year. You got sealing and closing off, plus the gutter system over at the existing masonry, and then you got the damaged roof that's already there. For the water collecting in front of the connex, that'd be one of the first things we'd have to address so that we don't shut down work as we go through. Whether that's going through and putting in a ramp, or we work on the drainage system there to get it there. We have a few ideas, and we're still working on exactly what the owner would like to see there. On the existing masonry, although you cannot see them very clearly, there are holes that you can actually see through the masonry. So we want to seal this up, waterproof it, so that it sustains over a longer period of time than where it's currently at. Missing and damaged roof to the connex. In the past, wind took off the roof and the truss that was there, so we need to replace that and put the metal back on so that we can continue that water collection. And then the existing masonry also has a gutter system that needs fixed. It doesn't have fascia and needs a drip edge on it so that we can protect that lumber from water. The total cost is about $1,700, and the total budget is going to be about 10%. It's going to be about 10% of the total budget. For all of this design that we're going to work on, we're going to use the XR10 to help us recognize where we have collisions, and we're going to integrate it first in the pre-con phase so that we can understand exactly where we may have collisions ahead of time, proactively thinking. We'll improve coordination with this as we'll go out there with our trade partners and figure out exactly what they're working on and see where we clash with other trade partners. And then finally, it's for the owner to visualize the final product on site. Being able to visualize it and see if that's actually what they want is a big deal for the owners. Now going on to budget control, the song will take that.
Now time is money, and money is money. So we gotta control our budget so we can actually get the project done. Ladies and gentlemen, the owners are investing in us students to use our creativity and design techniques as engineers to bring value to the site. But again, we have to control the price so we're able to actually complete it. One of the issues is structure B. We have two value adds for structure B. Value add 1 is reusing bolt block. Now, as we discussed earlier, the year before us used bolt block in their vertical structure. Reusing these bolt blocks can conserve around $1,600. Of course, we'll be looking at the material to make sure there's no cracks and that we can actually provide it for the class. Value add 2 is excavation for 1 day. Now, as Daniel and Payne elaborated on, if we do for 1 day, we have to do it prior to the spring semester. This is because if we do it in the fall semester, there could be freezing in the excavation hole. This will conserve around $500. Both these value adds can conserve $2,000 in total, and I'll be showing you later in a chart why that's so important. Structure C, as Daniel touched upon, is a different aesthetic from the existing structure from last year. Last year was bolt block. This year we're doing a pole barn style just to match the aesthetic of structure B. The concrete pour for the foundation will be used to level off that high slope that Daniel also talked about. Our roadway is hybrid, both concrete and timber. This is so students can still get a hands-on approach of concrete with pouring and formwork, while still getting the feasibility out of timber. We will reuse wood again from last year's structure and try to implement it into our design by saving money and cost and schedule time. Looking at our overall costs, we're roughly around $17,400. As I talked upon structure B, we're at $10,200. This is over half the budget. With these two value adds, we can reduce this cost and try to keep it limited to the other structures as well. Off that point, our man hours is about 2,170 man hours. Again, structure B is over half that man hour time. We're going to try our best to keep this as low as we can. With those two value adds, I think it can help tremendously. Some strategic budget mitigation is we'll have weekly meetings with the owner to look at our plan versus actual costs. This will help keep us on track and fly the marks that we think we're going above budget. We'll perform value engineering to help reduce these costs, which will be shown by identifying the costs, analyzing functions, developing alternatives, and assessing options. Last, we will prioritize what the owner wants now. This will help us by knowing what to take out with maintenance and other silly things we could get out of the site to save costs and time. Cole will now be talking about our schedule.
Thank you. I will now be talking to you about the overall timeline and schedule of our project. In terms of project coordination and general information, this is a 74-day project with a 20-day pre-construction period, a 23-day pumping period that will be going on over Christmas break, which will be done as needed, and then a 31-day construction period. Our workforce is going to be split up into 7 crews consisting of 5 workers each. And then in terms of weekly schedule, we'll hold our 1-hour planning and safety meeting Wednesday, with our 3-hour work sessions being Tuesday and Thursday, with half of our workforce being devoted to each day, and then owners meetings Friday. Our project start date is January 13th, 2026, with our finish date being May 5th, 2026. This is our major milestone schedule, which is a condensed version of our overall project schedule. One thing to notice here would be fall of 2025, where pre-construction is split up into 2 phases, coordination and excavation. The coordination phase started in October, back when we submitted our ATC and was waiting for our approval. And it will finish up week 7 when we finish our excavation operations plan. This will allow for us to roll into the excavation section, which will be our work at risk portion of this project. That'll set us up nicely for spring 26, where we have the milestones that we identified as our required onboard training, construction of our horizontal roadway, structure B being our temporary structures building, structure C being our student lab, and then overall maintenance on the existing facility. This will bring us to our finish date of May 5th. This is our 4D model, which shows our progression of construction over the next few months. This is the overall view of the project, which you can see HRS1 and the basement at B starting to go in. After this, you'll see the walls for B, horizontal roadway 2, and the structure for C start to go up as well. From there, at the end of February, you'll see structure C and HRS3 start to finish up, which will then allow for us to focus on B, the more complex part of this project. In the background, structure C and the roadways are having finishing operations going on, hence the reason that they're not being shown in this video. You can see the structural skeleton for B go up, with the exterior walls about to go in, and then we'll, in a second. I think we just got through spring break. Then you'll see the roof go on with the gutters, doors, and then our finishing task being putting the solar panels on. Directly after pre-construction, our critical path starts with our required 2-week onboard training, which is required before any other construction activity can start. After we finish this, we move to mobilization, which marks the start of each milestone. From there, the rest of the critical path revolves around structure B, with this being the most complex part of the project. On top of that, we identified our near critical path as structure C. The reason for this is because it's the phase that has the least amount of total slack, also known as float, being 7 days. In general, this means we have 7 days of leeway in terms of moving structure C's activities around due to any possible scheduling changes that may come up in the future. On the topic of schedule changes, CAP does have a schedule recovery plan in case any delays do come up. Our 2 current options are to implement weekend and weekly overtime sessions over the course of the project. These sessions will be optional, however, they will also be incentive-based to encourage attendance and overall boost overtime numbers when necessary. In the event that we do need to implement this plan, we will hold coordination meetings with the owner to overall come up with the perfect solution that suits all parties involved. This will be done to increase transparency, be the best communicators that we can be, and efficiently and effectively finish this project on time and on schedule.
So you've heard everything about what we want to do for this project, so why choose us? We believe that we have walked you through our design, which at the forefront is our commitment to safety and our safety first mindset. Then with our innovation and our hands-on experience that we have provided through our design and our always proactive thinking is why we believe you should choose us. We would also like to say a quick thank you to our mentors, Pat McGriff and Meredith Kinkle, for always guiding us through every decision and allowing us and pushing us to think outside of the box. Thank you so much. Questions?
Todd, go ahead.
Yeah, so help me out here, guys. So what's the total project cost? I mean, if I add this up, I add about $18,000, right? For each structure. If you add all the structures up, is that?
So ours should have been $17,000.
Is that with the alternatives or
without the alternatives?
17,000.
17,000 and whatever hundreds of dollars after that. Yes.
Okay, thank you.
Yep. Mason.
So I'm sure you're about to get from Marty to the technical questions, but I wanted to ask. You guys have the technical knowledge, and that's great. But at the end of the day, we could pick any team today, and they'd be able to pour a concrete slab and build a structure, right?
Yep.
So what I want to know is, like, the greatest challenge in Capstone isn't the ability to build the structure, but it's the ability to lead the people that build that structure. So what's going to incentivize me to come out and work for you for free on a 20 degrees Fahrenheit Thursday? What are you going to provide? What's going to be that rallying point that you can bring the team together on?
I appreciate the question, Mason. When not expecting that one. We haven't really thought that through because we want to know what our trade partners and laborers value. So what are they going to value to even want to come on a Saturday? And so we're going to get their input when we go through our management plan, and we'll work with them on what would actually get them out there, because we do want them to come out there. So at the end of the day, we're just going to see what they want, and then we're going to adapt and see what we can pull off to make it incentivized, because we can all provide free food. Is that the only thing that's going to get them to go out there? Yes and no, maybe. So at the end of the day, we're going to communicate with them and see what they have that they want. So, Tyson.
The cantilever part of the track around the building, it's up decently high, I guess maybe hip height or.
Yep.
Does it have sides on it? Does it have anything to keep the car on it?
It was not pictured in there, but there will be a guardrail that goes in to protect it from falling off.
Thank you.
Yes. Sam?
So also regarding that roadway and kind of in a similar area, like you are demoing the existing roadway, which provides like a circular part of the track, and then you're taking out that you're not providing the roadway all the way back around. So I guess what's your reasoning, and are you taking away something that the owner needs and providing them now a dead end as opposed to the circular track that exists?
So are you talking about that demo part and just seeing where like the term is now and what that uses for the owner?
Like I know it was to keep the track connected, so I guess what is your guys' design reasoning for disconnecting that track and giving yourselves a dead end?
Absolutely. Daniel, I'll pass that one off to you on turn.
So, I can't figure out how to pull it up. But if you guys look at the sheet that you see in front of you, the biggest thing why we had to demo out that area was for Structure C. We are connecting Structure C directly to Structure A, and that road is in the way. And with our roadway that we did end up deciding to go with, there is really no dead end. You can, at any point in that roadway, you can get around the site fairly easily.
And to add on to that, the main thing here is there's actually a shelving unit inside of that existing, so it can come back on itself on that road and go the other direction. And same thing will be set up in the student lab that will be there at C. Todd?
Yeah, so you go back, you use the word bid, like this bid process with the teams or the students. Is that more of a qualification on what they're capable of doing, or define that bid? You use the word bid, and you kind of lost me there as far as what you're doing with the students.
Absolutely. So when talking about the bid, those skills that you saw on that one slide, those are kind of what we are going to see what they have capable of, and we're going to select the teams off that. And so they're essentially bidding their skills to us on, hey, similar how we bid our project, they're going to bid their skills, and we're going to see where they want to be, or maybe we need a lead here, and we'll talk through that, and that's essentially what the bid portion of that means. Does that answer your question on that?
Yeah, I think so. Just using the word bid is a little confusing to me.
Absolutely. Professor Widener.
Couple. The risk mitigation table didn't have cost, and yet I thought you had cost mentioned as a risk later on. Is that correct? So here the cost is not listed here. But go 3 or 4 slides forward, and you have cost
within the ATC slides. Yes.
Yeah.
Yes. So that was kind of going back to we can add them. Though the cost one is a risk that we are aware of. We just didn't put one in that matrix itself. At the end of the day, this one, the ATC was specifically to give to owner, and so we should have provided that within that matrix as well for you guys to visualize it.
Okay, all right. And then one other thing, and that is, at building C, you say the slab is not level.
Correct.
And so your intention is to put a topping on it to level it up. Is that correct?
That is correct.
And so how are you going to deal with the fact that you're going to be feathering out that topping slab? How do you prevent it from just self-destructing? Because feathering out something like concrete is very problematic.
Yes, I appreciate the question on that. Here, we planned on building the concrete forms to be able to do it. We'll brace it, just giving the students an experience on concrete form work and leveling out that topography, and we're going to dial it in as well. So, I may not understand the terminology feathering, but I do know that we're going to level it out. Daniel, would you like to add anything to that?
Yeah, I could add a little bit. So we don't specifically have to do concrete. That was kind of what we were considering. We could also just put up a little layer and backfill it with rock, or we could make like a little wood deck that we could also use. But this is something that we were going to discuss with the owner in the pre-con phase.
Okay, all right.
Or maybe look at just making the studs taller.
Yeah. Absolutely. We'll take that into consideration as well. Brian, what do you got?
Did you include your solar panels on building B when you were looking at your overall height?
We did not, actually. We will have to go back and look at that and implement that into the height
maybe clarify with the owner if they are to be included in the overall height, if they're not?
Absolutely. Absolutely. Brett?
Real quickly, 2 questions. Is there a reason for the garage door being on the north side and not the east or the west, in case you have longer material, or you want to drive the truck fully into your structure?
So, that is actually something we did discuss several times. We went with the north side, however, it's up to the owner. We went with the north side mainly because that's where that roadway is, and so it was just easy to back in there as well.
And then secondly, is there an option to include steel in your roadway? I know the RFP requested, third, and I get the idea of altering the design to include the ATC, but is there, potentially an option within that last HRS4 to include some steel construction?
Absolutely. We'll take all that into consideration. We are in the design build field of construction, so we are more than willing even to hear from other teams on how they would implement that. Right?
2 questions. You mentioned a flagpole earlier.
Yes.
Is there a height requirement being so close to the airport?
We were told there wasn't, however, we would have to look into that. When we were looking at B, essentially that 565 over there would be our max, so when we were doing the flagpole, we'd have to look into that, looking at that 565.
And then second question, you mentioned having a 3-hour block on Tuesday, Thursdays, and then a 1-hour block on Wednesdays for the meetings. How is that going to work with schedules with students? Because I know when I did it, we had a 1-hour block on Tuesday and a 3-hour block on Thursday, and that was it.
Absolutely. Going into that, I'm going to hand that off to Cole as he went into depth with the owner on that a little bit.
Yes, so essentially Tuesday and Thursday would act as 2 separate labs for Capstone. So half of our workforce, like any other class, like chemistry, say for example, you would have, say, 2 labs that students would get divided into. You would have half of your workforce on one day, half of your workforce on the other day. So that way each student still has that one lab that they're taking, but also it just divides our workforce up a little bit so we can keep the job site a little less crowded. And so that way we always have people doing something rather than having everyone out there one day and maybe you have 5 people that don't have anything to do. It's just overall to increase schedule efficiency and try to keep risk mitigation down with so many people being out there.
I'm going to go to Christy in the back real quick.
Yeah, following up on the horizontal roadway question about the steel, can you just kind of point out which aspects of the horizontal roadway are the cast and post concrete, precast concrete, and then if you have an idea of where the steel would go, or?
Yes, absolutely. Going into that part of the RFP, I'll hand it off to Daniel.
So for the steel, one of the big things that we were considering were the cantilevers on building A that you can see. If we were to actually pour that out of concrete. And then as far as the roadway goes, for this 2-foot section, we were planning on this not being cast in place, being pre-made and just brought down. I forgot the proper terminology. And then the 4-foot section will be cast in place. The big thing with this is that we just wanted to give students hands-on experience of pouring a sidewalk, as it is a phase 3 thing on most job sites, but it is something that everyone should have experience in doing. And then I already touched up on it, but the 3D printing for the roundabout is another option that could be in place.
Okay, back to Todd.
So this is kind of a schedule orientation, so what I thought I heard you say is we're gonna go out and we're gonna dig the hole in December now?
Yes.
And set the sump up and all that kind of stuff? But yeah, you're not doing any kind of orientation or anything until, what was it, January 12th, I think?
Correct.
How are you gonna do, how's all that gonna work here in December, I guess?
So we as a team will do that work and work with the subcontractors that we're actually going to sub that out to.
So you will not be using outside labor or the students?
Nope, they can come visit it because it's good experience to go see the excavation and things of that nature, but they will not do any of the work. So.
Regarding structure C, kind of, you have this large opening, and from what I understand, like that's just gonna be an additional area. What is your guys' thought behind limiting that in terms of equipment use? By putting a roadway around it in all directions, you essentially cut yourself off from bringing any sort of equipment close to that entryway.
Yep. Appreciate the question on, especially the equipment and being able to access that area. Daniel, what would you like to do?
So, as we talked about, Student C will be primarily used as a woodworking lab. We don't plan on putting any equipment in this area. It'll just kind of be used for if you need to cut a 2x10 and say it's raining outside, you don't want to do that in bad weather. This just kind of gives you an area to do that.
So then is there any safety concern regarding the fact that to get over the existing roadway, you have to take stairs, and when you're carrying lumber, is like, I guess what was your guys' risk mitigation with that?
Yes, absolutely. Thinking through that, the main thing is connecting. We could bring out that concrete slab a little bit more, and then you'd have like a laydown or like a walkout area, and then we could tie it into the road that's existing there, and then you essentially can make that into a ramp, so then you take away some of those tripping hazards and whatnot, put up guardrails so that nobody's falling, especially when we move that around. We can also use that terminus where the car would come in to move some of the heavier stuff onto that road and then pick it up on the other side.
I could also add upon that. Since we are using an existing building, we also brought up the fact that if we do need more space, since it's open here, we would open the wall, the bolt block wall, and have it all open just as an idea. That's not going to be what's going to happen, but that's an idea just for the factor if we need equipment and other stuff being brought in.
You're up on time. Thank you very much. Good work. It's kind of hard to see from the back, but yeah.
A lot of you guys have taken some time out of your day. Most of you have taken your entire day to come watch these presentations. So I just want to say thank you for all of you. So let's get into the agenda. First things first, we're going to meet the team. You guys want to know who we are, and then you guys want to know what we've done. So we're going to get into a top-down view of our executive summary, just to give you guys a quick synopsis of what we've been working on. Then we're going to get into the design, the management plan, the schedule, budget, and then safety, maybe last here, but it's first in our hearts, and then you guys get to ask us some questions. So first, my name is Nicholas Fry, and I work as the project executive.
Hi, my name is Elliot Azzi, and I work as the design.
My name is Nathan Weston. I'm the estimator.
I'm Gabriel Fernandez, and I'm the safety manager.
I'm Jose Piñero, and I was the project scheduler.
Alrighty, so first thing we had to do was ask why. Why are we doing this? Is this just Brandon giving us a bunch of busy work? No. We're doing this for a reason. One, he wants us to get some experience with the design build method. Two, he wants us all seniors, to have some learning, get something out of this on an actual construction project. And then finally, he wants a lab space for us to be able to give to the future CEM students that go through this program. And our design encapsulates all of this. We have 5 parts of our design. A 2-story structure that will work as a lab space, an observation deck that can see the entire site, a horizontal structure that will interface not only with our 2-story structure, but also with the existing infrastructure, so you can get from one site to the other side just by driving the RC car. Then we have a management plan that's going to go over how we're going to communicate with the owner, how we're going to build it, and then how we're going to create a culture on site. Then we have a 15-week schedule that's going to break down who's working where, what linear parts are we going to work on. We have an estimate that not only goes over the materials and machinery, but also calculates the labor and what our part of the design would have cost to give us a little insight into what this would cost in the real world. And then finally, we have a very detailed safety plan that we're going to wrap up the presentation on. So I'm going to hand this over to Elliot, and he's going to talk about the design.
So hi, my name is Elliot. I'm going to talk about the design. So I know most of you have been here since 8 o'clock, and I get it. We are the 3 o'clock time slot. So I want to get this point across. What makes us so special? What makes us so different compared to the rest of the projects you just saw? Well, I'll tell you. Basically, Purdue has instilled in us 3 key aspects we believe as a group makes a great engineer. And that's innovation, execution, and feasibility. And we believe, and we're about to present to you, something that we are extremely proud of, and we represent all of that in our project. So, with that being said, we're not trying to strive for a satisfactory design. We are trying to go with the Purdue goal of excellence. So, let's move on with the specifications. So essentially, if you look on the right, that's the S-Sprite project, incorporated with our design as well. Today I'm going to go over the basement as well as the tunnel system that we have made, and I'm also going to go over Structure C, which essentially is a truss system, almost as if it's a bridge, and we're very proud of that too. So that's what I'm going to go over today. And before we begin, I'm going to go over the location. So don't worry, although there's going to be a lot of components in this design phase, I'm going to provide this as a key at the bottom of the slide so you know what and where I'm talking about when I talk about these designs. So that being said, the red section is going to contain the tunnel design, as well as the basement and the comments box. And then if you look at the center, there's also a green section, and that's where our project is going to connect to the 2024 project. And then on top of that, we have the blue section, which is our Structure C. So this is also just a plain view of what we have, and this kind of just gives you an idea of what you're going to be looking at. So, Structure B. So Structure B includes a basement that's 10 feet deep. On top of that is a slab and a connex box. And then on top of that, we have our tunnel system. And that's something we're extremely proud of, our tunnel system. Why, you ask? What's so special about a tunnel system is you basically can't see the track. Well, that's the thing. You can because we're incorporating polycarbonate material, which is one, transparent, and 2, extremely durable. Why are we doing this, you may ask? Well, it's because we want workers to be able to move freely across the site, And on top of that, we also thought about the future CEM projects, where they could also utilize this space as well. And on top of that, keeping with the same idea, with our track over here against the gravel, as you can see, it's at grade level. Why is it at grade level? Well, we want machinery and workers to be able to access different parts of the site extremely well, or very easily. And so moving on, then if you look towards the end, that is where we connect our project to the 2024 project. Now, getting into that. Now you may tell me, if you look at these design specifications, you may say, well, Elliot, that's not a 5% slope. That's a 10% slope, and you would be right. And we also got, the reason why I mention this is because we also got approval by sending the RFI, and because on the 2025 project, we saw that it was also a 10% slope, so we were able to use that. And that's extremely important to us because this allowed us to get to the depth of the tunnel and to reach the height of the connection of the 2024 project extremely fast, and basically 10 feet instead of 20. And so this is also just a few other examples of what we have, just a plain view and a site view of what it should look like. Again, as you can see, the pathway is on grade level with our track, and then the elevation as well of our track connecting the 2024 project. Moving on is our pride and joy, again, the tunnel system. So we're very happy because we're essentially breaking ground with this. We're doing something that as we have not seen at S-Bright before, and that's the innovation aspect that we want to tackle. So what we have designed was, again, like I said, the polycarbonate material. It swings around in an old O shape, and then it connects to the 2024 project. As you can see, it consists of wood, metal, and as well as concrete. And this is also some other drawings that we have drafted up, just to give you an idea. It's 30 inches in width, and you can also see the different heights that we have our elevations at. And then on top of that, another thing that we really wanted to dive into was the components of the tunnel section. And so we talked about it for a couple of days. How exactly are we going to do this? How exactly are we going to put the polycarbonate material on top of it? Are we going to screw it? Are we just going to lay it? And we decided and designed a tunnel component where you can slide the polycarbonate panel in and out. That way it's very easy for maintenance. And for, let's say, if your car gets stuck underneath the tunnel, it's very easy to get it right back out. And then moving on is the site in total. As you can see, it's the basement as well as the Connex box, and this is just a side view. This connects the entire tunnel system as well. These are just some drawings, as well as this as well. You can see the landing of the stairs and the staircase in the center of the track. And then on top of that, you can see the depth of the basement, which is 10 feet from the ground level, but that's not including the thickness of the slab we intend to pour. And this is structure B. So this is essentially what we want it to look like, and this is what we are extremely proud to present to you today. Next on, our second pride and joy would be structure C. And the reason why we're also very proud of this, we could have done something a lot more simpler, but we decided that as a group, for the last 4 years, we've been working on these truss systems. And this is a perfect opportunity to incorporate these ideas into a class that encourages to explore these ideas. So, yes, we designed a truss system. It's a little bit elevated compared to the observation deck. It serves as an extension to the current observation deck, and we're very proud of it. We have done the calculations, and we have calculated a few other things like the wind load. And as you can see, it's connected. The bottom part is supported by the CNE blocks we're going to put together. And if you're asking to yourself, how exactly are you planning to get the truss system up there? Don't worry, Nick will answer that question. And then on top of that, we have the railing. And this is all very specific. We designed this to a T. You can do this right now on site, and this would be exactly perfect, not interfering with any structure that's currently there right now. And this is just another drawing that we have. And finally, this is our project, and we are extremely proud to show you this. And this is just another plain view of what it should look like. Thank you, and now I'm going to pass it off to Nick for the management plan.
All right, once again, I'm Nicholas Fry. I was the project executive. And this is our management plan. It's broken up into 3 parts: owner communication, subcontractor communication, and then construction execution, how we're actually going to build the dang thing. So I'm going to focus right now on the two communication parts, and after we've done our schedule, I'm going to get back into how the means and methods of how we're going to build it. So first, owner communication. When you're looking at the parts of a design build method, you have the subcontractor, GC, and owner. The owner is probably the most important part of it, because they're the ones that actually going to own it and inhabit it once we've turned it over. So we want to make sure the owner is getting what they want out of this. The three ways we're going to do that is by being clear, we're going to be concise, and then we're going to be correct. So, to be clear, we want to be as transparent as possible with the owner. The way we're going to do this is every Monday, we're going to have a meeting with them. We're going to go over what we worked on last week. We're going to discuss any changes we've had to make to the budget, to the schedule, to the design, discuss change orders, and then give them a short 2-week look ahead on what we're going to be working on next. Next, being concise. We want to make sure the owner has everything they want in an easily accessible place. We don't want them to have to go through 5 different applications just to find the schedule, just to find an RFI. So we're going to be using one site. That site is going to be Procore. We're going to be on it. All of our documents that we're going to be working on over the project, they're going to be on it. And then we're going to have all of our subcontractors on it as well, so we can be transparent with them as well. And then finally, we're going to be correct. We'd like to believe that we build this perfect the first way through, but most projects aren't perfect. So we're going to have a plan in place to correct these mistakes. First way is we're going to have a quality assurance and quality control team each week, making sure that we build it correctly on site. If they don't catch it, the last 2 weeks of our schedule are solely for punch list items. So we're going to go out there with the owner, and we're going to make sure that they like what they're going to get. Now, subcontract communication. We want to build a culture on our site. We're lucky because we've already had 8 teams of 5 people working together for a whole semester. Those are going to be our teams that are going to be the certain subcontractors. But we don't want just their cultures separated. We want a full class culture working together, a culture of safety, a culture of communication, and a culture of accountability. So, how are we going to do this? On Tuesdays, we're going to have a meeting with all the subcontractors. We're going to go over what we did last week, we're going to get their feedback, and then we're going to assign them to whatever project that they need to be working on. We're going to tell them what they need to do so we don't get to the site on Thursday and are just lost. For us to be effective, they also need to hold us accountable. They need to make sure that we're doing our job. But we also need to make sure they're doing their job. So this quality control, quality assurance team, it's going to rotate between all the groups each week. So one group isn't just going to be the bosses, the ones calling you out on all your mistakes. It's going to be a different group each week. And then finally, we're going to make sure everybody is qualified. So everybody's already gotten their OSHA 30 certification from this class, but we want to take it a step further. Whatever they're working on, we want to make sure they know how to do it. Whether that's teaching them in the 2-week training sessions that we're going to have at the start, or switching them up. Whenever we're assigning them to their certain work packages, we want to make sure that they've done work like that before. Now, I want to recap what our baseline schedule is. Monday, we're going to have an owners meeting to go over the project with the owner, make sure everything's clear. Tuesdays is going to be our subcontractors meeting. Thursdays is when we're actually going to build the thing, and then over the weekend, we're going to compile everything, adjust our schedule, budget, and design, and then we're going to give it back to the owner on Monday. With that schedule in mind, I want to hand it over to Jose, who's going to talk about our full schedule.
Thank you, Nick. Once again, my name is Jose Pinheiro, and today I will walk you through the schedule and how we're actually planning to execute this project in the available Thursday sessions that we have next semester. We have come together with a schedule that is realistic with the time and the people that we have available. We came up with a schedule that consists of both pre-construction and construction, and today I will focus on the actual construction of the project. So we have 15 available working sessions. They last 3 hours. 2 of these sessions are designated to training. So effectively we only have 13 sessions to physically build the project. So we have to be very intentional on how we allocate our people and how we schedule the activities. In the baseline schedule, I included each activity that has to be completed in order to finish our project on time and safely. On the Gantt chart behind me, you can see the activities labeled with its durations and the dates. These activities include the site preparation, which is the excavation of the project, the vertical structures, which include structure C, our basement, our connex box, the stairs, then the arrangement to the current building, the horizontal construction, which is our tunnel system and our track, and finally our MEP and final inspections. With this being said, I want you to visualize how we're actually going to execute this looking at our site plan. We have 4 main locations in which we're going to be working on. We have location B, location C, location 1, and location 2. I will walk you through each of these locations so that you can visualize how this schedule ties into what we're going to be working in the field. Starting with location B, this is our busiest location, and most of our critical work is going to be happening here. At this location, we will excavate. We will form and pour these slabs, the walls, the ceiling. We will do the stairs. Parallel to that, we will also come together with the track. We will assemble the track, assemble the tunnel system, and install the polycarbonate material on top of that. And after that, we will install the connex box there. As you can see, location B is really busy, and we want to keep less than 15 people working at this location to avoid overcrowding and be more effective in our work and be more safe. With that being said, I want to move into location C. This is where we're going to have our second vertical structure. We're expecting to build this parallel to our excavation. We're going to allocate 15 people here, and we're going to get it done in 3 sessions. Then, location 1. Location 1 is where we're going to tie the existing building to our new track. We are allocating 2 sessions for this. On the first session, we will come on site, we will arrange the current building so that it's ready to receive the new work, and after that, our second session, we will tour the end of the track and connect to the current building. We're expecting to have 5 people at this location. Lastly, location 2. This location is situated next to location B, and in here, we're going to form the precast tunnel pieces. We're going to do this in 2 sessions with 15 people. And after they're ready and location B is ready, we will install the precast tunnel pieces at location B. So this was a quick overview of all the locations that we're going to be working on. Now, to wrap up the schedule, I want to talk about our critical path. Most of our critical path, basically all of it, happens at location B. And it goes like this. We arrive on site, the 2 training sessions, then we excavate for 4 sessions, then we form and pour the slab of the basement in 2 sessions, then we do the walls in 3, we put the ceiling in 2, and then finally we install the connex box in 1. That adds up to a total of 14 working sessions, leaving us with 1 session for flow. This session will be designated for final inspection and punch list, although we are aiming to have 0 punched items. This way, if something slips, we can use that flow session to recover. With that being said, now Nick will go over the construction execution of the project.
Alright, once again, I'm Nicholas Fry, and I'm going to go through how we're actually going to build structure B. So, what's going to happen first is we're going to be working on the site excavation. We're going to be digging for our basement, digging with the right sloping. It's 1-to-1 because of the soil type B. Once we're completely out of that area, we're going to be working on the road that connects the existing infrastructure. Once all of our excavation is done, we're going to get people down, and they're going to be working on the floor of the basement and then the footings for all the walls. While that's going on, we're going to begin our prefab for the tunnel system. Our tunnel system is going to be concrete prefab with a wooden road inside of it, and we're going to lay that down in there. What's happening in the basement is we're going to take 3 sessions to put up the walls. 1 session is just going to be putting up all the formwork, and then we're going to do 2 pours over the next 2 weeks. Once those while that's happening also, we're going to be putting up the polycarbonate material on top of the tunnel so that we're actually done with that tunnel system and they can go work on something else. We're going to put in the stairs to get down to the basement, and then we're going to put the sheet metal roof on top of it so that it's structurally sound. And then finally, to cap it all off, we're going to put the Connex box on top of it as our second floor. Now, structure C. So we're going to start with our CMU block as the base of the structure. We're going to be using scaffolding to get up. We're actually going to build the truss on the ground, and then we're going to lift the truss up, set it in place on the scaffolding, connect it to each other, put the floor on the observation deck, put up the permanent guardrails, and connect it to the existing observation deck. Now I'm going to hand it on over to Nathan to talk about our budget.
All right. Good afternoon, everybody. My name is Nathan again. I'm the estimator for this project, and I'll be talking about our budget. Just to start off, I wanted to mention, why do we have a budget? We know money is a really important thing, especially when coming to construction sites. We want to make sure that our project can be funded and realistically paid for with the resources we have. For that reason, we developed our budget, and I'll go ahead and get into it. So just to give an overview of our budget, I'll start off and say our number already. $74,907. This is broken up into three big sections: the fall 2025 design, the cost of labor, and the equipment and materials. I want to give a brief overview of like how exactly did we go about this budget. Of course, I'll break it up into the smaller details here in a minute and of these three, but just in general, what was our strategy for this? We wanted to build this project with a lot of learning experience. That was our goal. We wanted to make sure we get a large variety of different types of construction in this. For that reason, we recognize money is not our priority. As you see, this is a bit over the 10,000 suggested mark, but as we go through this budget, I hope this will prove that our budget is realistic and can accomplish what we're doing. Also, I wanted to mention that this is a more conservative take on the budget, considering a lot of our work is with college students, unexperienced workers. I imagine there will be mistakes. There will be times we need to redo things. So for that reason, there's a fair amount of contingency built into this budget. So just to visualize these numbers, here's those same numbers you just saw on the pie chart. You can see that 65% of this total cost is coming from materials and equipment. The other 35% coming from design and labor. Starting with the fall 2025 design. This is broken up into four sections. We have the modeling, which includes everything Elliot has wonderfully done, estimating, which is what you're hearing right now, scheduling, which is what Jose has done, and I've roped into everything else as other, which includes everything Nick has done and everything Gabriel will present on in a minute about the safety. So how are these numbers obtained? We started with calculating the total construction cost. So that's the total cost of labor and the total cost of equipment and materials, combining those together, and that's our total construction cost. We took a percentage of that total construction cost and labeled it as our fall 2025 design total. From that, we took common industry percentages of modeling, estimating, scheduling, and so forth to obtain these values. And to view these on visually, we can see that 45% of this pre-construction fall 2025 design is coming from the modeling. A big portion of that is from all the work that we've done for the modeling, followed by the estimate, scheduling, and everything else. Moving on to the labor. So labor, we've got four sections for this one also. The site preparation, the vertical structures, the horizontal structures, and the maintenance. Overall, this comes to a total of $18,183. So how were these numbers obtained? Labor was an interesting task. So we can't exactly go out and ask people, how much you making a year? What we did is we went to a tool called RS-Means. I'm sure most of you all are familiar with RS-Means. It's a great resource to get labor values, but also equipment and materials, which we'll hear about in a minute. But we went to RS-Means. We could find a task that we're going to accomplish, say like excavation. And we'd find associated labor crews and how many workers we need and productivity rates and so forth. But most importantly there, we found hourly pay. So we could get our hourly pay, we can get our productivity rate, our quantity of whatever material or equipment or task that we're doing, combine all those to get a dollar amount and put it on this budget here. Here's a visualization of the numbers you just saw. So one thing I'd like to point out about this is there's a very even split between the vertical and horizontal structure. This indicates that the labor for both the vertical and horizontal structure is pretty even, as we're paying pretty much similar rates throughout the project. And a smaller percentage minority for everything else on this site. Moving on to the materials and equipment. So this is very similar to the labor. It's broken up into 4 categories. We have the site prep, vertical structures, the horizontal structures, and different from the labor, we have contingency. So first question you might ask is, where did the maintenance go? That number was very small, so that has been roped into the site preparation. Next question you might ask is, what's the contingency? What's that for? Like I said, this is a conservative budget. I want to make sure that we have room to make mistakes and to learn and grow from that, and not have to pay a price for that. So that number is included on there. So how were these numbers obtained? So I started with RS means, just like I did with labor. I took that a step further. So what I did is I got quotes online for, say, about 90% of everything we're going to build. Everything else was taken from either common costs I could find online or other methods. But the quotes I'd like to highlight were from local stores or local equipment providers that we could purchase materials from and easily get delivered. Looking at this visually, you can see that 54% of this cost is coming from the vertical structure, followed by the horizontal cost taking 33% of that total cost there. Moving on to our top 9 cost driving items. So this is materials and equipment and the 9 most expensive items on there. One thing you'd probably highlight here is this big red section on the left here, the polycarbonate. 31% of our materials and equipment is coming from that. You might be wondering, how much is that actually? What's the actual dollar amount? That's about $13,000. We recognize that's pretty expensive and probably not ideal for trying to save money, but considering that's our main highlight of our project, it's something that we think is amazing and something we think that people will remember about a project. We wanted to include that. Now, what if the owner didn't want to include that? We've calculated an alternative to that would come out to be about $36,000 to not include the polycarbonate. That would include every safety measure we have to take in place, such as putting up guardrails around the tunnel so that nothing falls in, but that is the alternative to that. And lastly, I'd like to talk about our maintenance plan. So as we're going about doing construction, there's a good chance that certain values that we've estimated will be either higher or lower. And we want to monitor that. We want to make sure that our budget is staying on track and in the correct place. So as we're going about doing our work, every 2 weeks we're going to evaluate the budget. And at the owners meeting that Nick mentioned, we're going to share that with the owner. We're going to analyze where we are. We're going to take out necessary contingency where we need to, or even put money back into it if that's a thing we have to do. With that, we'll conclude the budget. I will now pass it off to Gabriel for the safety.
Thank you, Nathan. So once again, I'm Gabriel. I was the safety manager for Atlas. And first of all, I want to give it out and say that for Atlas, our main mission is to prevent injuries before they occur by having clear procedures and consistent execution. We want to extend our safety program to everyone on site, not just our employees, but we also want to extend it to visitors, to the owner, and subcontractors. So our safety plan wants to establish a proactive and consistent safety culture that will last throughout the project. To do so, we have 2 main ideologies. The first one is PPE worn at all times, no exceptions. And the second one, which is really interesting, is stop work authority. Everyone on our site has the responsibility and the right to stop any unsafe act, even if it's performed by themselves. If someone doesn't feel confident or doesn't feel comfortable by performing a task, thinking that it can injure them, they have all the right to stop it. So our safety program starts with safety training. During the first 2 work sessions, we're going to have 2 site orientations. In here, we're going to run everyone down about our PPE, our equipment present on site, and the main hazards associated with it. And after that, we're going to do a task-specific orientation. So after the 2 sessions is finished, and we're going to start construction, we're going to teach everyone how to perform their task with the maximum safety standards. And here we are going to include equipment and tool training, as well as hazard identification for the specific job. And lastly, we have a specific and qualified operators stickers. So we want to train our operators in a specific piece of equipment. We don't want a bulldozer operator to operate an excavator. And to do so, we can either provide them the training, or if they're already trained and qualified from a third party, they can also bring that to us and we're going to record it. And to make everyone aware of who the qualified operators are on site, we're going to hand them a specific machine sticker that they're going to place on their hard hat so everyone can identify them. Next, we're going to have a safety meeting scheduled per week. This is going to stay consistent throughout the weeks. So first of all, on Tuesdays, we're going to have a quick safety briefing about the Thursday's work. And we're also going to receive feedback from our subcontractors on what were things that we can improve or things that we missed from last week's session. After that, before we're going to start our work on Thursdays, we're going to do a quick search on flags rodeo. This is going to include everyone on site. We're going to make sure to include everyone that is present, even if they're not going to work. And we're also going to do a quick job hazard analysis and sign-off required. This sign-off is really important because it represents the fit to work of each employee. Each employee is required to sign off before they can begin working. Periodically, we're going to have some toolbox talks, and here we're going to talk about specific equipment or tool trainings that are going to happen. For example, if a specific job requires to do or to use a power drill and someone doesn't know how to do it, we're going to train them on that. Not even teach them how to use it, but the most important thing is teach them how to use it safely. And also, we're going to run down any inclement weather toolbox stuff. For example, if it's too cold or too hot, what are things that our employees can do to stay safe while working. And lastly, after all work is done, we're going to do analysis of the work performed. First of all, we're going to investigate any incidents or near misses, find the root cause of them and how we can prevent them in the future. And we're also going to do a performance analysis to check if, even though we did the work, do we do it safely, and what are things that we can improve for the next session. And now I want to introduce our life-changing categories. Our life-changing categories represent possible injuries that may alter the well-being of an individual for a long term. And the good thing about this, or the main important function of them, is that they can directly relate to specific tasks. For example, we're going to build our basement, and we can add the excavation life-changing category to that task. By doing so, we can identify what are the best protective measures that we can apply, and also make our workers and employees aware of the risks behind the work that they're doing and what they can do to stay safe. Another important part of our safety program is our daily visual inspection. So basically, we're going to use a lot of electrical equipment and tools throughout the site, and before anyone is able to operate them, we want them to visually check them. Some of the things that we want them to look out for is that if there are any damages, any exposed conduit, any faulty guardrails, or any damage to the plugs. By doing so, before they can begin operation, we can prevent any shocking or fire hazards. And in case that the machine or the piece of equipment or tool finds to be damaged, we're going to tag it out, we're going to retire it from service, and if it is needed, we're going to repair it or replace it. And now I want to introduce our biggest hazard on the job site and how we're going to address it. So of course, one of our main key components of our project and what we're really proud of is our basement. It's a 10 feet deep basement, and of course it has a lot of hazards associated with it. To do so, we decided to create a 4-step program that can prevent any injuries. For example, the first part will be a competent person to file a trench inspection permit. In this permit, the competent person will classify the soil type, and will also add the required protective systems and the access plan for the excavation. After this, OSHA requires us to have ladders placed every 4 feet of the excavation, and if the excavation is more than 5 feet deep, we're required to have safety guards around the excavation. After both of these elements are in place, the protective systems and trench inspection, now our workers are allowed to enter our excavation. No one is allowed to enter our excavation without a permit or without protective systems. And lastly, we're not just going to let them work and we're going to forget about them. We're going to constantly monitor for any soil changes, any water presence, or any change in our conditions that may affect them. And as you can see in the picture below, we're going to have corridors around our basement, and from point green to point green, we're going to place our ladders every 4 feet. And now, our site security and housekeeping. So first, our site security is really important to us. We're going to have a lot of people working in there, and our first main point of control will be the access to the site. No one can access the site without a previous approval. It's not open to the public. Next, we're going to have a material drop-off and delivery receiving over there. As you can see, this will allow us to keep an efficient and safe methods of traffic, a designated place where all material is going to be stored. And in terms of housekeeping, our expectations are to keep our walkways clear at all times. We want to have a daily debris removal so we can avoid any tripping hazards while working. And all of this debris or waste is going to be collected down below, and we're going to have a periodic collection system that will come either 1 week or 2 weeks as required to pick up our waste, and we can continue to clean our site. And the last part of our safety program is our emergency preparedness and response. So throughout our work site, we're going to have this picture or poster placed in different parts. And here you can see our evacuation route. So as I mentioned before, it's just one exact entry and exit to the site. So in here, any place that you are located, either if it's around B or C, you can clearly know what direction to follow so you can exit safely in case of an emergency. In this diagram, you can also find the location of first aid kits as well as fire extinguishers as needed. And lastly, we're going to have the closest hospital location. It's in Lafayette. It's around 5 miles distance from the worksite, and also emergency contact in case of any trouble. And that will be all for our safety program. I'm going to hand it to Nick so he can give a closing statement.
All right. Well, as we wrap up our presentation, I want to say a couple things. I want to say thank you to Rachel Steiner and Carly Applebaum. They were our mentors through this whole semester. They helped us a lot, and we are so thankful for everything that they've done for us. I also want to thank Brandon and Brett. They were also very helpful, helping us with our presentation, helping us with our report. And I also want to thank the construction engineering program for giving all of us an opportunity to do this. And then finally, I want to thank all of you guys for sitting through our presentation, taking time out of your day. It can't be understated how much we appreciate this. So now I'm going to open up for questions. Yes.
I have a question about drainage and your tunnels and then the stairway that goes down. What's the plan for drainage?
All right, so thank you. You're talking about drainage. I'm going to let Elliot take this. He's ready to jump on.
Sorry. Yeah, for the tunnel system, we do have certain components of the tunnel to have small holes inside so that there is a drainage system, because underneath it essentially just be groundwater, dirt. And essentially that will go down into the soil. But essentially, another point that we wanted to point out was that it's essentially going to be sealed by the polycarbonate material. So a lot of water wouldn't necessarily access the tunnels since it would be covered with these panels. And then another thing for the basement and underground, we do have a PVC pipe. We do have a pump located outside in the center of the track. And while we do our excavation, we're also going to dig enough so that we can connect that pipe and locate it in the center of the basement floor. And that pipe will then be connected to the pump located outside.
So there's a polycarbonate door, so if this is ground level, you're starting to go down for your tunnel, there's some sort of...
Yeah, so for that design, we wanted the car essentially to access, and if we had a little latch here, the car wouldn't be able to access it. So there is, if you can look at the kind of... So this is what we have right at the beginning, and different aspects of our tunnel system all have drainage areas. And then on top of that, this is what I was talking about, the PVC pipe. And so, yeah, there is no latch for that now, but that is a good point. That's something we could add on to that as well.
And to answer your question about the stairs, so the stairs are gonna, we want an easy way to get down to the basement. The stairs are gonna be outside, but we're gonna have a little landing area and then a door that's gonna open out to access the basement.
So is there a drain at the bottom of that stairwell? Or is the stairwell covered, you're saying?
No, so the stairwell's not, so like Elliot was saying, there's gonna be drainage system down there to help. Were you the one that did the calculations on it?
I did do the calculations. I did some rough calculations on it, it being 1 inch thick. And we calculated it around, if you stand at the center of its weak point, so essentially right in the middle, it should calculate to around 350 pounds. So we figured this is like a good amount for people to be able to stand on. If not, we would increase the thickness, maybe increase the price a little, but we thought it was adequate.
And one of the beauties about the design build process, if we come across something later in the project that we maybe missed, we can adjust that and talk about that with the owner and perhaps create a change order or something. So thanks for your question. Yes.
So the dimension of the polycarbonate panels is 1 inch by what, and what's the weight per cubic foot?
Okay. So if we go back to the dimensions, we had these drawings. Sorry, it's a lot going back. Too many drawings. Oh, here we go. So this is the slit that I was talking about earlier. Maybe you guys have not seen it. So it's the front view essentially. So I don't know how far you are, if you can see it or not, but there is a slit right in here, and it essentially spans around 2 feet and 2 inches, and that's how large it will be. And when we did those calculations, we had that in mind as well, and essentially where exactly it's going to be supported at. So including these supports, it's calculated to be around 2 feet, so 2 feet by 1 inch, and then as I mentioned before, 4 feet long. And so they're all separate panels from one another, not one long.
So how much does the panel weigh?
So I will get back to you on how much the panel weighs, but from our understanding, it's nothing that we should be concerned about. We understand that it's not supposed to be as heavy or impact the structural foundation of the tunnel. So.
Thanks for your question. We'll look into that and get back to you. Anyone else?
You talked about doing field-built trusses. Did you look into any pre-manufactured truss options?
No. So one of the things we were talking about is getting learning experience. So assembling on-site was what we wanted. We actually did not look into any prefabricated trusses. If that's something the owner wants, we can look into that as well. So thank you.
So for your the basement essentially, and then you said you're going to set a Connex box on top of it. What's your structural steel look like in the basement ceiling? So essentially the floor slab that Connex box is going to sit on. Did you guys do the math of what kind of structural steel you would need in that concrete to be able to support the weight of both the dead and the live loads?
Yes, Gabriel, you did the calculations on that. Do you want to take that?
So basically, what we want to do with the steel is create a small platform to see the Connex on top. If I'm not mistaken, we're using grade 18 of steel, which can hold the container and the people to be inside the container. And that also aligns with our budget and with our project execution.
Thank you very much for that.
You mentioned building the trusses on the ground and then lifting them up. How do you plan to lift them up into place?
So what we were planning on doing for that is we already have an excavator on site, some machinery. So what we were planning on doing is bringing it over, hooking it up, lifting it up, and then scaffolding around it. Excavator's going to hold it in place, and then we're going to attach it to the CMU block down, to the CMU block supports.
How tall is your structure see? It looked like from the renderings it was like almost 20, 30 feet tall.
Yeah, so I'm sorry if it looks 20, 30 feet tall, but it is, so at the bottom of the truss, it's actually at 9 feet, and we designed that so people can still be able to access in and out underneath it, and that's what we really wanted to do, but overall, it's an extra 5 feet in addition to the 9 feet, so in total it is around 14 feet tall. And I believe the observatory deck is already 10 feet tall, so what we did is essentially extend the stairs connected to that observatory deck and then extend it 4 feet up, and that's how you get an elevated observation deck.
And secondly, how are you guys building B? It seemed like you were excavating. Was there sloping? Was there not sloping? You guys putting in a soil box? How are you
have sloping on, so we're gonna have sloping on the west side of it, because we already have to dig down for a tunnel a little bit, and then we're gonna have shoring on the other 3 sides.
Back to the truss. So once you have your truss up there, I think you mentioned that you put the surface material on top. How do the workers access to do that work, the surface material, the decking, and then the handrails? What's the access?
So we're gonna have scaffolding that goes all the way up. We're gonna build scaffolding. We have it built into our schedule, the time that it takes to get up there. We're gonna go over proper lifting practices and proper scaffolding practices in our safety training. So that's how we're gonna get up there. Back.
I think you've got an interesting design. Speak to how you're going to manage the complexity in terms of the field design solutions that you report. So the construction engineering aspect that you have to do once you get out to the field.
Okay, so we're gonna talk with the owner during our owner meetings, but we're gonna have us on the field actually going around making sure, along with the quality, they're known as the observation team. We took them as the quality control, but if there's issues that arise, we have people on site, as well as if it's a bigger issue, we can take it back with Brandon and discuss it there, or with the owner and discuss it there.
Do you feel like your team, more than you, right, the whole class, if you're running the project, is prepared for solving the problems that are going to come up in the field?
Yes, I do believe so, because they've all done something like this. They've all created their own individual plans on how they would address problems in their own projects. So we just have to create a way to connect them all together and create one centralized system. But I do have faith in all of my co-students to solve the issues that arise by themselves. But once again, if it's an issue that's larger than just one person can take on or one group can take on, we have a plan in place to be able to go back and deal with it.
I just want to follow up. So the process that you envision to pull this whole team together so they all get, I think you talked about pride and innovation, the drivers that you have. How do you instill that in all 40, not just 5?
Sure, since I mentioned it. I mean, I'm going to be honest with you, for the last 4 years, that's all we've been doing. I mean, Purdue, everywhere I go, is strive for excellence, strive for excellence. I don't see a reason why we should do something so basic and repeat something if that's what our university represents. And so that's why we want to go outside the box, go below grade, and go above as far as we can. So if it means for me to go speak up in front of all those 40 students, so be it, I will. But at the end of the day, I think it's instilled in us in the last 4 years that although we encounter problems, although we face challenges, what a Purdue student represents is to tackle those challenges head on, and I think that's what defines a Purdue student. That's why I believe those 40 students will be on board. I think it's just a representation of the school and everything we've been through. So thank you.
I think we have time for one more, maybe two.
Was the owner, did you talk to all about your budget issues, and how did they react to that?
So actually, he was the one. We had a conversation with Brandon, and we're like, hey, we're having an issue getting under this $10,000 budget. And he kind of made it a point. Last year's group and the year before were nagging him about giving him them a budget. So he just said, here's $10,000, here's your base budget. If you want to go over it, you have to justify why. And that's why in our project, we believe the cost that we're going over $10,000, you're getting more value out of that from the learning experience that all the students get, from doing concrete work, from doing lifting work, from excavation work. We do believe that value outweighs the cost that we're over $10,000. And I do believe we're approaching the 50-minute mark, so once again, they said it right there. I'm not just trying to get out of there. So, thank you very much.
Yeah.
All right, you have about 3 minutes.
And then if we have an actual environmental.
Yes.
All right, here we go. We have DL Contractors up.
So does anybody not have a deliverable to start? We have a couple handouts here that we just want to reference throughout the project. We just want to make sure that everybody has a copy. Good? Okay. So to get started, I just want to say thank you for taking the time today to meet with us. I'm sure it's been a very long day, especially being in this 4 p.m. slot. So we just really appreciate you guys all being out here. So we're going to give you the Capstone Development Project on behalf of DL Contractors. So to start, my name is PJ Summers. I'll be the active project manager for this project.
My name's Natalie Lawson, I'll be the bid coordinator.
My name is Ben Gunter. I was the lead designer for this project.
My name is Lucas Gress. I am the estimator.
And my name is Clark Sweet, and I'll be the superintendent for this project.
So to just give you a little insight into our group and the company as a team, we provide a full scope service so that the owner has all necessary requirements at hand. That includes in-house design, 3D modeling, project management, safety, training, estimating, and scheduling. So to start out, I want to go over that deliverable that's in front of you. So we have a site plan that we'll run through our design phase. At the top left, you can see some of our estimating supplements to justify kind of how we got through some of these cost items. And then on the back, you'll see a full scope schedule that we use to progress through our project. So to start, I'm going to turn this over to Ben, who's going to go over some of our fall 2025 design.
Alrighty, just to give a brief overview of what we were asked to do. The first point was to build a 2-story lab space at point B on the map there. They asked that it had electrical and lighting, as well as a minimum square footage, a minimum footprint of 200 square feet. Secondly was a roadway for a remote control truck, being approximately 200 linear feet, and traverse from point A to point B. Thirdly, it was requested that there was a structure incorporated at point C. This one was fairly broad. And then lastly, general maintenance of the site, as well as providing additional power and compressed air supplies. So moving on to the lab space at point B. So it was requested that it was 2 stories, and this would prove to be an interesting challenge for us, given that we did have a height restriction leaving only about 8.5 feet from the ground to work with. So obviously, we decided to go with a cast-in-place reinforced concrete basement. The remainder of the structure is timber framed, and we wanted to include a lot of windows both up and downstairs to provide lots of natural lighting. We did also incorporate just general electrical and indoor and outdoor lighting. And this will also be housing the compressed air supply for the site. Moving on to the roadway. We really want, given that it had to go, it had to traverse across the site, we wanted to make sure that it impeded as little as possible. So you can see here that the path we chose is minimally invasive and avoids existing infrastructure. We also wanted to incorporate a series of cast in place and precast sections for the track. This is also where we plan on recycling some material and implementing 3D printed concrete for our precast deck sections. And we also wanted, I also wanted to point out that due to the path of the track, this also allows us to run our electrical conduit across the site with no extra work. So going on to the structure at point C, this is where we really thought we could add a lot of value. And because it was so open-ended, we decided to go with a slightly raised deck. This provides some just additional usable area for students and visitors. We incorporated some lockers for people to store personal belongings, extra personal protective equipment, as well as some tables, chairs, benches for people to take a break, sit down, eat lunch, whatever they need to do. So then going on to our maintenance items, there is an existing structure next to the point C that is not completely enclosed. So first things first is we wanted to enclose that and add the next big pair of barn doors to allow for material storage outside of the elements and make sure that they are easily accessible. Next, we wanted to install solar power floodlights at various points around the site, just so that in case people are there working later in the afternoon, visibility is not an issue. General electrical, we wanted to add a couple outlets adjacent to this, our proposed addition at point C, just for general usability. We also wanted to add additional access stairs around existing and our new portions of the track, just to improve access, as well as repair some of the lumber on the existing observation deck. Just from being out there, we noticed that could use some improvements. And then lastly, add some weather and safety stripping to all of the existing stairs on site. So
now we'll move into some of our,
and then the last point we wanted to touch on for fall design was just our approximated design costs. You can see our proposed and then what our true cost ended up being for fall design. What this did not include was extra software and consulting with industry experts on this project.
So now we'll get into some of our pre-construction aspects. This pertains mostly to kind of how we're planning to manage and tackle the project. So to start, we'll go over some of our quality items, and I will have Riley discuss some of those.
So quality is really going to drive this process, especially with our schedule. So the first thing we want to implement is our meetings every week, both to update them on the conditions of the site, to make sure that submittals are being approved and looked at, and just to make sure that we maintain open lines of communication. We're going to have a submittals log, which we will manage through Procore. We want to make sure that all the materials on site are being stored correctly, that work's being done properly the first time, and that any testing results we need are coming out correctly. We want to use Trimble XR10 on site for issue tracking and also just to verify that the as-designed conditions are being becoming the as-built conditions. You can walk the site with that, and it can also be used for visitors to kind of get an idea of what we're working on out on site, give them an idea of what the finished product would be. And then daily records, we're going to have logs every day for all the work completed to track schedule, make sure we're meeting our schedule, and then safety logs, if any safety issues come up, that we can work on a solution for the next work session. I'm going to hand it over to BJ to talk more about safety now.
Yeah, so for this project, there's several different facets. Clearly, it's a challenging project. We have 40 different students that are going to be active on site, so we want to outline roles and responsibilities right off the bat. Clark will be our active superintendent for this project, so he'll be our hands-on, boots on the ground, making sure that all of our daily records are maintained and ensuring hands-on experience with all of our employees. I'll be the active project manager, so I'll be handling more of the overall general leadership, kind of guiding our way through the project, and then just making sure that we have allocated PPE for all of our teams. So our plan for this project is to break each team up and have team leads associated with each portion of the project. So as a team lead, you'll be responsible for making sure that every team is using the proper PPE and communicating those weekly procedures as we move forward. In addition to that, they will be communicating directly with Clark, and they will halt any unsafe work as necessary. In addition to that, we also request that each member of the team be able to halt work if necessary, and we want them to maintain and ensure that they're wearing their own PPE as well, and also call out the teammates of theirs. And then finally, just visitors, we want to ensure that they're following all of our safety procedures, and then that they're escorted through site through a member of our project management team. And then as you can see here on the right, this is our site plan, so you can see layout for the material laydown area and parking, as well as our evacuation route. So we just have some general safety items that we want to outline, and it's my responsibility to outline that to each individual for the project before we're actually going on site each day. So then moving into how we're actually planning to identify hazards on site. So the graphic you can see on the right is a risk analysis matrix created by DL Contractors. It shows the combination of likelihood versus severity of consequences of these actions so that we can address high-risk hazards on site and make those a priority item for us. The hazard matrix on the left is actually an outline for SRITE on how we're planning to identify those hazards specifically to the site we'll be on, showing severity and then also addressing some of the mitigation methods for those. So now I'm going to turn it over to Clark, who's going to talk about our safety training day.
Yeah, so in the spring, the very first work session, we will not be conducting any work. We're going to dedicate this day to preparing for all safety risks as well as some team integration, which I'll get into later. But the highest priority as a company is safety, so we're going to start with that. The purpose of this work session will be to establish all the best safe work practices as well as set the project expectations for the rest of the spring. Some of the key items that we want to discuss and train our students on will be site orientation, including all the risks that will be on site, as well as tool handling for any power tools as well as regular tools, so that everyone knows the expectation of proper use. During construction, there will be some other key items that could pose a risk, including working around heavy equipment and the best practices to do that safely, trench safety practices, and also our best fall protection procedures. Now I'm going to transition more to talking a little bit about the schedule, beginning with our resource allocation plan. On the right, you can see the personnel allocation, and this will give you the number of people who are dedicated to each location or phase of the construction process. I'd like to highlight that the highest number of resources will be allocated to the structure at E. This is a very important phase and will also is also our critical path for construction and will require the most attention of our workforce. And then I also want to draw your attention to this flex team section here. This will be 6 of our more adaptable and experienced workers who we will be able to place on any phase or location of the project to ensure that each section is consistent and moving in a timely manner through the execution of construction. So for the teams, before the spring semester begins, we will send out a survey to our whole workforce where they will list details including their past work experience as well as some of their interests. Then us as a management team will collectively delegate the work evenly between each team. That way, that way each team can be as strong as possible and very balanced. So as I mentioned, so that first work session, after we're done talking about safety, we're going to move into team integration to really break people out and get them comfortable with their teams. This will include demonstrating what their roles and expectations of them will be for their specific tasks. And this will really help us be able to hit the ground running when we begin construction in the second work session. So now I'm going to talk a little bit more about our general schedule. So the philosophy behind our schedule was to be efficient with clear sequencing. On the handout, the schedule is in front of you on the back side if you want to take a look. So the best example of our clear sequencing is that top section, which includes our structure at B construction. There is a lot of constraining items where it would not be safe to conduct work simultaneously. So it has a very structured sequence of hitting one item after the other as we construct our structure vertically. For the efficiency aspect, if you want to look towards the middle of the schedule, towards the track section, you can see that some of the items are overlapping. This is where we really took advantage of the site where we believe we can have really allocate our resources and spread them out. That way no one is just standing around without work to do, and construct the track from both sides. That way we can maintain our schedule. You can also notice that, so this schedule is how it's best designed for you as the owner is it's very realistic. I would like to once again reiterate that first session where we are not going to do any work to ensure that everyone is safe and has their expectations set in front of them. But you can also see at the far right of the schedule, in weeks 15 and 16, those are left blank. We have incorporated 2 potential weather days during our construction phase, as we know that we could be dealing with freezing temperatures, snow, and even storms, so we wanted to make sure we planned ahead with that. And those can be dedicated and implemented fluidly anywhere in the schedule, which would just shift it back a week. It's also, I would like to mention the red writing you can see on the page, which will show you the critical tasks, which can also be seen in this table. I would like to mention that we are going to maintain the highest quality of work by delegating these high-risk items on different work sessions. This will allow our team, our management team and safety team to not get overwhelmed and be able to provide all of our focus to these key tasks, which mainly include our excavations and our pours, which, like I mentioned, are on separate work sessions. All right, now I'm going to pass it over to Lucas to talk about our budget overview.
So for the spring management and labor costs, our total proposed cost is around $40,000. This cost includes the management and labor cost, along with estimator, scheduler, VDC controller, designer. It also includes our labor costs by work area. The structure at B, the structure at C, and maintenance, along with the horizontal roadway. It does not include labor done outside of scheduled work hours, so time outside of the 3-hour window each week. In the figure at the top, you can notice our costs are broken down by work area. The structure at B has the overall highest cost by work area, and then the structure at C, the carpenters have the highest total cost by trade. The figure at the bottom, we decided to break our costs into 3 different areas. These include the construction, the management, and the design cost. Overall, our construction costs by trade were the largest total cost for this portion. And overall, the costs associated with our spring management and labor is not going to count towards our lump sum total. And this is due to our student learning experience and all the students who are going to be doing the work themselves. So now I'm going to pass it back to PJ to speak on our construction costs.
Yeah, so as we continue to bridge this into our fall 2026 construction, the way we have this broken down is into 3 main sections, each of them being 4-week periods, so that we can really get into the nitty-gritty of how we're actually planning to execute this project. So we'll begin by going through schedule and then some safety and quality items that we want to ensure that we're hitting our mark on, and then we'll just go through the budget for that week. And then in summary, we'll conclude with a 4D model and our overall project summary. To start, Clark's going to begin by running us through our week 2 through 5 schedule.
Okay, so for the first section of the schedule, weeks the first 4 work sessions, which will be weeks 2 through 5. We will begin with excavating both the building foundation as well as digging the trench for our tunnel as part of our track. And then this will lead into our team's constructing the precast section of the track, which can be seen here for the eastern part of the track. This will be precast, and then as well as our teams pouring the track on slab and pouring the foundation of the building later in this section of the schedule, towards weeks 4 and 5. And then for the observation deck, that team will be mainly focused on demoing the current one. This will allow us to complete our excavation through this section without it hindering the heavy equipment. And then once that is completed, the observation deck team is going to transition into beginning and completing the construction of the platform, which you can see on the left of that top picture. And then the maintenance team will be working on fabricating all of the stairs for the site. So as the roadway is poured, there's going to be access stairs implemented there, and we're going to have those pre-made by the maintenance team so that we'll be able to fluidly implement them and always have access to all parts of our site. I'm going to turn it over to PJ to talk a little bit about our high safety risks for this first section.
Yeah, so each section here, we kind of want to go into specifics of, hey, these are high area concerns, and this is what we really want to focus on for that 2 to 5 week period. So for elevated falls, during this time we'll have excavations on site, both with the tunnel and with the building at B. So we want to make sure that we have proper fall protection in place if necessary, have our safety rails installed, and then we also have an elevated risk with removing part of the observation deck. So we want to ensure that we have proper tie-offs for anybody that's going to be working at those high elevated areas. And then additionally, this work's going to be conducted during mid to late January and into early February. So we want to ensure that we have all of our weather conditions intact. So we want to make sure that, hey, we're doing warming breaks as necessary so that we're not putting our workers at any risk. So now Riley's going to talk about some of our quality items that we want to make sure that this process we're ensuring is correct so that we don't have to go back and make errors or have errors present later.
So starting at structure B, our first main point here will be installing the necessary safety measures around excavation. We want to submit for this because we just think it's such an important item. There's a high risk of falling here, so making sure that we have the safety measures installed will help prevent that. Along with that, concrete testing for the foundation, we're going to conduct slump and compressive testing, making sure that we are reaching the correct strength and workability. Moving on to the roadway, the track layout is going to be extremely essential. As Clark said, we're starting to construct the track from either end, and we're going to meet in the middle. So making sure our layouts, as we go through the first week, are lined up so that later down the line we don't have an issue. Our bolt block anchorage. So the first course bolt block, we're really going to focus on submittal for this with photo verification that it's been anchored properly to avoid any later structural issues. Moving on to the observation deck and maintenance items. Demolishing the existing observation deck is extremely important for our schedule. It allows us to excavate for the tunnel, so making sure that that is completed within that first couple sessions. And then maintenance, the stair fabrication and storage. We don't wish to store wooden stairs out in the open because they're not going to be useful to us later in the semester. So storing them in that existing structure, which is marked on your handouts in front of you, will allow us to keep them dry and then be able to implement them as we need. So I'm going to hand it over to Lucas now to talk about the cost of the first 2 to 3 weeks.
So for this first portion of the project, our proposed cost is around $12,000, and that includes the tax on the materials that we're going to purchase. This proves to be about 35% of our total material cost for the construction phase of the project. Significant costs during this part include purchasing the concrete for our foundations at the structure at E, as well as concrete for our precast roadway components. We also have a lot of costs associated with our observation deck expansion, the lumber for that. And then finally, we have some costs with excavation of our basement for the structure at B. So we also noticed some recycled materials that were left over from previous year's projects, and we would like to reuse these during this component of this project. And these include bolt block and some Quickcrete. So from the figure there at the bottom, you can see our cost progression through week 5 for this part of the project. And then finally, the figure here at the right shows our costs broken down by discipline. These are all summed together to give our subtotal, and then value add is deducted from that to give you the cost minus value add. Now I'm going to pass it back to Clark to speak more on schedule.
Okay, moving into the middle section of our schedule, which will be weeks 6 through 9, if you need to follow along. For the horizontal roadway, this is when we will be precasting this section and also installing them to complete our tunnel construction, as well as completing the wooden bridge construction to the south of the site, which will be behind Connex, as you can see in this picture here. For the structure B, the team will be mainly working on, they will start by pouring the basement walls. You're going to cast in place these basement walls, and then they will be moving into installing the stairs, as well as the joists, beams, and flooring to holistically round out the basement construction. For the observation deck, they will be working on replacing the decking that we had demoed earlier in the schedule to allow for that excavation. They're going to be replacing it with new lumber as soon as the tunnel is complete. And after that, they're going to be working on installing the lockers and the picnic tables on the platform, which will then be able to be utilized by the students for the remainder of our spring construction and hopefully for many years to come. The maintenance team is going to be enclosing the existing structure that is there on site. Currently, the roof is exposed and one wall is completely open. So the maintenance team will be working on enclosing that roof, as well as hanging the barn doors to basically weatherproof that building. Now I'm going to pass it over to PJ to discuss a little bit more about our safety risks for this middle section.
Yeah, so for these weeks, clearly, as Clark said, we're prefabbing a lot of our work. So we want to ensure that all of our employees are properly trained on equipment usage, as well as ensuring that we keep a tidy site so we can reduce slip, trip, and fall hazards. So in terms of equipment use, we have our safety training day to start. That's going to be our baseline. And then this week, we especially want to focus on making sure that we're inspecting all of our equipment before it's used and maintaining its serviceability long term. And then we also want to make sure that everybody's familiar with what tools they'll be using, as each team will probably have different equipment used for each portion of the project. And with that equipment usage comes slip, trip, and fall hazards. It's still going to be cold outside, so hazards such as ice are still present, possibly. And then just in terms of extension cords, power cords, things of that nature, we want to ensure that those are all tied up and hung up properly so that we're reducing the risk of injury for that. So now Riley's going to talk about some of our quality submittals for this portion of the project.
So starting with structure B, the basement wall formwork is going to be extremely critical for us, as obviously this will be supporting the next floor. So making sure that's done well and that the walls are plumb before we move on to the flooring is going to be important. Along with that, the stair installation, once we start building the floor out, we need access to the basement still, and the stairs give us that access. So making sure that's done, and once again, concrete testing. For the roadway, we are fabricating the tunnel at this point. It's going to be made out of precast walls and precast slab pieces. So making sure that this is done, and so that we can drop it in by the end of week 9, will allow us to move ahead in our schedule. Lastly, for the roadway, the support posts for the wooden bridge, making sure those are good to go. The observation deck, we are installing the lockers, making sure those are anchored to the existing structure so that there's no risk there of tipping over or anything. They're secure. And then fabricating the barn doors so that we can continue to store material in that existing structure. So we're just going to talk about cost analysis now for 6 through 9.
So for the second portion of the project, our proposed cost is around $16,000. And this cost, again, includes tax for the materials that we're going to purchase. This cost proved to be the largest total cost for each of the 3 segments of our project at 42% of our total construction budget. Significant costs during this part of the project were the concrete needed to pour the walls for the structure at B, as well as a lot of the lumber and carpentry materials that we need to construct our structure at B. So we again noticed some more materials around the site that we would like to use during this part of the project. These include some metal wall studs, some insulation, and some lumber. And then there's also an option for an enhancement to the existing structure. This includes substituting our swinging barn doors for a garage door. And then lastly, the figure at the bottom shows our cost progression through week 9. And then the figure on the right shows our cost broken down by discipline. These are combined together to give us our subtotal. And then the value add is deducted from that to give us our value add minus, or cost minus value add. And now I'm going to pass it back to Clark to speak on our final segment of our project.
The final section of our project will be weeks 11 through 14 on the schedule in front of you. You may notice that week 10 is excluded. This will be spring break during the spring semester where we will have no work being conducted on site, and then pick back up in week 11. So for our team working on the horizontal roadway, they're going to be integrating the tunnel with the wooden bridge to the south of the site and ensuring that they connect smoothly. For the structure B, that team is mainly going to be focused on completing the main floor, which will be the structural walls, and then moving on into completing the roof as well as the interior and exterior finishes. For the structure at B, we are going to be wrapping up by integrating our platform with the higher observation deck with the staircase that will be installed and secured, as well as the permanent safety railings. That way students can once again access that upper observation deck without risk of falling. Our maintenance team is then going to be wrapping up by installing our electrical connections to the buildings, as well as the solar lighting on site, and then finishing off by installing our gutter and rainwater collection system to the structure at B. Now I'm going to pass it over to PJ to wrap up our safety risks for this section.
Yeah, so this portion of the project poses hazards both with electrical work as well as manual exertion. So during this project, we're going to be hauling a lot of stuff so that we can go and install it. So we want to make sure that we're not lifting loads that are too heavy for us. We want to go through, do an ergonomic test, make sure that everybody's in fit shape to do that work and that nobody's hurting themselves. As for the electrical hazards, we'll be installing all of our electrical lines during this period, so we want to make sure that we're using resistant gloves if necessary and that we're not running anything with active lines. So we want to make sure that we go through all those protocols before they begin so that we're not subjecting anybody to risk during the project. So now Riley's going to finish up our quality for this portion of the project.
So at structure B, our main item here is going to be the truss installation for the roof system. Making sure these are secure not only keeps us safe, but it also allows us to actually finish the building with the roof. Moving to the roadway, transitioning from the tunnel to the wooden bridge, making sure that we line up here since we have been coming from opposite ends. We've already laid it out, but checking that our elevations are correct at the very end. Also checking the water drainage on the track. As Ben mentioned earlier, it's incorporated into our sloping, so making sure that it's working properly now. Moving to the observation deck and maintenance. The observation deck, we're replacing the decking now, bringing that back into service. So making sure that the safety rails get installed and that we're able to install that new staircase and anchor it to the platform below. Maintenance, our big thing here is going to be weather safety stripping the staircases. If you walk on the staircases in the middle of January, it's really slick and it's a really dangerous thing to climb up that observation deck. So we want to ensure that these are installed for the safety of everybody on site. So now Lucas is going to talk about our final costs for week 11 to 14.
So for this final period of our project, our total costs are going to be around $9,000. This again includes tax on the materials that we're going to purchase. And this represents 23% of our total material costs for the construction part of the project. Significant costs for this portion of the project include concrete needed for our elevated horizontal roadway slabs, as well as lumber needed for our structure at B. And then finally, there's some extra costs for the electrical that we're going to install around the site. We noticed some more materials around the site that we can use during this part of the project. These include some unistrut, PVC conduit, and some large water barrels that we can use for rainwater. And then finally, there's some interior and exterior enhancements that we're proposing for additions to the project. The first is enhanced enhancing the exterior of the existing structure, and the other is enhancing the interior of the structure at B. And then it's important to note that all these enhancements that we're doing on the project are not considered in our budget, or they're not considered in our cost or in our value add cost. And then finally, the figure at the bottom shows our costs expected through week 14. And then if you guys look at your handouts, that figure on the bottom left is provided to you guys. And then finally, the figure on the right shows our costs expected, our material costs broken down by discipline. These costs are combined together to give us our subtotal, and then the value add cost is deducted from that to give you our cost minus value add. So moving on into our overall cost, our project is going to run from January 15th to April 30th. The image here on the left shows what our project should look like after we are done with all of our improvements. Looking at the figure on the right, our costs are broken down by discipline again for the entire construction portion of the project. They are all combined together to give us our proposed lump sum total of $39,000. And then our value add is taken out of that to give us a proposed cost of $34,000 if all the value add options are used fully. And then finally, the bottom figure shows our costs broken down by work area. In that figure, you can notice that the structure of B has the highest total materials cost for the project. And then in your handouts again, we provided the chart that shows our costs for each work area and a pie chart. So overall, we proposed a total cost of around $39,000 for the Capstone project. We believe that this is our best value, and this is our best. So anyway, I'm going to pass it back to PJ to talk more about our 4D simulation.
Yeah, so I'll have Ben start this simulation here. But the goal of this is to simulate how our project is going to come to fruition along with our schedule. So as you can see, we begin by removing the observation deck so that we are able to trench in this area for our tunnel as well as in the building up there. As you can see, we're beginning to work on both sides of the track and come into the middle here. The building is going to continue through the base foundation and walls up there on the top right. During this time, the construction of this lower platform is also going on. And so we continue to build that roadway simultaneously with the building and the observation deck. So our vertical building is clearly our critical path to this. It's the thing that's going to take us the longest. So as that's going on, everything else is going on simultaneously so that we're not wasting any efforts. And then this brings about our connection here, this little transition at the bottom where we connect the track as a whole and end up finishing our building in week 14 as proposed. That does not include our spring break or our weather days, so there's gaps in there that will also be allocated. But that brings about the end of our presentation. We would now like to open it up to questions that you may have. Yes, ma'am.
I saw in the pictures something about window wells. I don't think you guys touched on that. Are they for light only? Are they big enough for egress? What's the drainage like in those?
They will have gravel subbase and they will be big enough for egress as well as lighting.
We do have a couple sets of construction documents that we put together as well, kind of outlining those dimensions. If anybody would like a copy, we'd be happy to share them. I only have 3 copies of them, but I would like to share them if anybody's interested. But it kind of shows our dimensioning of how we're going to plan to lay out some buildings and stuff.
The biggest technical risk that you believe you've got over the course of the construction period?
Can you repeat that question?
What is the biggest technical risk that you foresee over the course of the construction period, and how do you propose to address it?
In terms of safety? Or
anything other than safety technical?
Okay. I would say our biggest issue would probably be dealing with the schedule, so I'm going to let Clark answer that question.
Okay. All right. I would say our biggest technical we are planning on incorporating a lot of our flex team resources to this as well, as there will need to be a lot of form work and bracing put in place before the pour takes place.
And when does that occur?
Currently that occurs in week 6, I believe, is when that begins.
So you still got weapons over frozen ground?
Yes, so that is true. We are currently our 2 weather days are just at the end of our schedule. Realistically, we expect these to fall towards the beginning of our schedule, as the freezing temperatures and the snowfall are our highest risk items. So we are expecting that currently it's showed in one of the earlier weeks, but we expect it to be pushed back a few weeks because of the incorporated weather days.
Yeah, so how much time have you allotted? Well, I'll change it. Are you fabricating your own formwork for the foundation walls, or are you renting formwork from Simon's or somebody like that?
Yeah, so we went to a lot of analysis on that. We wanted as students to be able to put that together as part of our learning experience. Same with doing the concrete basement. We wanted to do something that hasn't been done on site yet, so that pertains to building the concrete foundation and the formwork for that. So Clark, I don't know if you want to elaborate more on how we built out our timing for those.
Are you asking about the timing?
Well, I'm asking about, how much time are you planning on constructing the formwork rather than just assembling it?
Yes, so constructing the formwork, we are expecting to take a longer duration. It's one of our, I would say, longest items for the number of work sessions. I don't know if you see that there's a work session column on the schedule. So we are expecting there to be a significant amount of time to do the formwork and bracing and rebar in a few work sessions before the actual pour occurs.
In terms of the formwork for the building, we have one day to assemble the formwork for the foundation. So we, as a team, felt that we were able to have one work session allocated to actually assembling the formwork, and then we would come back and forth the following week so that we got everything set up. In terms of the basement walls, they're a little more difficult. We actually have 2 work sessions allocated for that, and then we'll come back and forth that the week after.
Okay.
Yes.
I'm just curious, where are you getting your numbers for like the concrete and foundations from? You had $16.5 grand, and I mean, I don't obviously you plan on making your own formwork, so I don't know if that's included in there. That number just seems really high.
Yeah, so I'll turn that over to our estimator who put a lot of work into coming up with that number.
So our concrete estimate and values, they came from RS meetings, and I believe that includes items such as rebar, the concrete itself. So that's where we mainly got our numbers from.
Okay, I mean, you can get a cubic yard of concrete for $150, but I was just curious.
Well, and another reason for that is also because of the way we design our walls, and then Ben can speak more on the design of our concrete.
Yeah, the basement walls are designed to be exceptionally thick, as one might put it. This is to account for the lateral soil pressure on the walls, as well as at the top. We are planning on having it notched to account for to allow for the joists and columns to be set for the building. Yes, ma'am.
So, you guys talked about how you're removing and replacing the existing observation deck. I guess how did you come to the conclusion of removing the entire thing as opposed to just removing the boards that need extra attention?
Yeah, so it's not shown exactly on the model because of how we used a pre-built model. So actually the way that observation deck is constructed is there's 2 sections. So we are planning on only taking out that left section, and we will just replace that and repurpose the wood for additional use somewhere else on the site, and then we'll come back and refurbish it with new wood after. But we just wanted to make sure that there was enough space for our excavator to get in and dig that trench enough. So that's the main reason that we wanted to do demo of it.
The trench falls, or trench which becomes our tunnel, falls directly underneath where that existing observation deck is located. So we are planning on removing all of that lumber. We're going to leave the columns in place, but yes, we needed the space to allow our heavy equipment to get in there and get the construction done.
When you say tunnel, are you enclosing the top? Is it open?
Yeah.
I know you said there were concrete on the sides and the bottom, but I wasn't sure about the top.
Yes.
Yeah, sorry. Where's, I think it's on slice. Sorry, the rendering, we wanted to show the interior of the tunnel, so it is only a cut through, but we do plan on enclosing the top of this.
Is that another slab or?
Yeah.
Yes, ma'am. It's a precast concrete slab which will drop in place.
Apologize for the background.
With that tunnel, is there a concern of the guarding stuff?
You said, is there a concern with the car getting stuck?
Yes, with no access into the areas of the tunnel that are covered.
It is a rather short section. It's only a few feet. And we also requested and received the dimensions of the vehicle, and we ensured that there would be plenty of access. It wouldn't get stuck, and if for some reason something happens and it's down there, it's more than easily accessible.
We did also look at additionally adding a section that we could, like a manhole of sorts, to kind of enter that so that the vehicle didn't get stuck. But after design, we kind of realized that the section wasn't that long of a tunnel, so we really were able to kind of eat through there if necessary.
Okay, so you got a tunnel and then essentially a submerged roadway, is that correct?
Yes, sir.
Do you have any concerns about water accumulation? Is there drainage?
Yes, sir.
Water out of there?
Yeah, most definitely.
Yes, sir. Unfortunately, we were unable to show it, but there is a drain incorporated at the lowest section of the track, and since we're going to be excavating there already, we plan on doing additional small excavation off to the side to essentially allow for French drain to be in place to allow adequate runoff from the track.
Okay, thank you.
Yes, sir. Yes, sir.
With the newer lower deck that you're building with the table and the lockers, how high off the ground is it? And is there a need for any sort of railing around the edge because of the distance?
It will be approximately a foot and a half off the ground. So we did not. It's more than easy enough to install railings on there if we deem it necessary. But as it stands, it's approximately 18 inches.
And for access, we have stairs down to the back as well. So you don't have to just jump off the platform to get to the slab.
So the model isn't exactly representative of what that concrete slab looks like out there. It comes with a flat part on this section and then elevates down from there. So we're planning on using brackets and columns and cutting those so that it's level up there. But it should be essentially flush with the left section of that. And then we have added access stairs so it's easier to traverse up and down and you're not stepping down as much. In terms of safety rails, we weren't above 6 feet anywhere, so we didn't deem it essentially necessary. But if after conversation with the owner, he feels it's necessary, we can go back and install some.
Any other questions? Good work.
Those are instructions, Brett.
Yes.
For anyone who's a judge, can you please finalize controls, submit them to the surveys, file results, and then we'll have the top three, and then we'll discuss.
We think it'll take about 10 minutes or so.
Yeah.
And if you're a mentor, you have feedback, give that to Brett as well.
No.